So I have a question. Will I be sharing my screen with my presentation?
I was going to make the same question.
Yeah.
Because everything is preloaded, but I don't know if still we can just.
I heard that we can. I have seen a few days now, so they are sharing their own screens.
Okay. I prefer that. Yeah.
So you just go to the share content and show your presentation, right?
I'm going to test it. Let's see. You can see my screen?
Yes, it works.
Let's see if
Thank you.
does that work?
Yes.
And you can only see just the whole slide.
Done. You're done.
I'm done. I can go to bed.
It was great having you here.
All right. Let's see now. I'll stop sharing.
So.
Okay.
Hey, yeah, it looks like you're an expert. So we just make a start and that's it, or we're waiting for. Is there anyone from the organization there? Yes, right? Hello?
You can start now.
Okay, so we just make a start?
Yes, sir.
Okay, and for questions and so, there is a chat, or will you be allowing another room, or how it works?
Sir, chat.
The chat. Okay, so I make a start, right? Good. So good morning, everyone. We are at the risk session of this Friday at this congress in India that we all would have loved to attend in person, but we are doing our best remotely. So the presenters of the session, it is, besides myself, I'm Professor Ignacio Escuder Bueno, and I will make a short introduction of myself at my presentation. And I'm going to ask all the others, Dr. Naidu, Takahisa Tabuki, Eya Isamaki, Dean Darkey, and Andy Zielinski, that please, at the beginning of your presentations, make short comments on yourselves, at least your affiliation and a little bit of your bio, if you wish. With no more delay, we are allowing around 10 minutes per presentation, and I will be introducing all of them. After the 10 minutes, I will check in the chat, and I will allow 2-3 minutes of questions, and by the end of all presentations, we can have an open call for questions to any speaker. So again, thank you very much to presenters and attendees and the organization. And I'm going to share my screen, and I'm going to make my presentation as a keynote speaker. So I'm going to share. I am assuming that you are seeing my screen.
Yes, sir.
So can you see it well?
Yes, sir.
Yeah, we can see it, Ignacio.
Thank you very much. So I'm Ignacio Escudero Bueno. I like to present myself as a three-hat person. So I'm a professor at university, but I'm the founding partner of a spin-off company from my university, which is Polytechnical University of Valencia, and my company is Ipresas. And my third hat is that currently I'm serving as chairman of the Spanish National Committee on Large Dams, a mandate that will be finished by October after having a big convention in June in the Canary Island that I will keep you posted. So I wrote this paper with Mr. Pramod Narayan that I'm quite sure many of you know. He is the director of the DRIC project. He's a great engineer and a very good friend, and he was kind enough to let me present our paper. So let's go from far to close to the world of infrastructure. What is the world doing on natural risks governance? How do we as a world monitor it and deal with it? Probably most of the responses are at the headquarters of United Nations at the Global Assessment Report on Disaster Risk Reduction that they issue every 10 years, and in the office of the same name. And basically they compute all natural hazards in terms of annualized average loss. So in the language of the United Nations, the way to characterize the disaster risk is on quantitative terms. And this is the language that the world speaks to further take action wherever it is more necessary. So coming a little closer to dams, what is the world doing on infrastructure risk governance? So natural disasters, now infrastructure risk governance. From the point of view of infrastructure, there's plenty of things going on, and the world is moving forward towards risk-informed approaches. And let me bring you the example of the Inter-American Development Bank, for whom I've been working as consultant for more than 5 years and helping developing these materials and policies. So they, in compliance with their policy of disaster risk reduction, they have launched a procedure for every infrastructure project, not only dams, which is a 5-step procedure, which is gradual, and it goes from screening to potentially quantitative analysis, depending on the needs. In any case, for those infrastructures which are classified as medium or high risk, they at least need a qualitative risk analysis plus a management plan. Mostly, but not only, but mostly the qualitative analysis is done in terms of failure mode identification following a flow chart, as the one you can see to the right of your screen, in which you have, let's say, a previous part ensuring that everybody gets the right information, etc., and individual participation in terms of suggesting failure modes, and then there's a group approach and a number of conclusions. This is for all infrastructures. This is not only for dams. And coming all the way to dam safety risk governance, what is the world doing? There is probably most of you have had the chance to have a look to it. There's a very recent publication from the World Bank, which is under the name of Laying the Foundations, in which they have a full chapter on risk assessment as currently applied to dams in the world. One of the best practices captured there is about using risk indicators to inform prioritization of investments. And there we can talk about individual risk, societal risk, Euler principles, and the combination of those are made in the form of particular risk indicators. The one risk indicator the World Bank highlights is the equity weighted ACSLS, which was first presented by Icold around 10 years ago, and it's been widely applied. It's in our guidelines, and it allows to show how in the context of prioritization of investments, once you know from where to where you want to go in risk reduction, every indicator of those, and in particularly equity weighted ACSLS, that you can, the description, you can find it in this document or the previous document, but basically is like, it's the same indicator as adjust cost per statistical life, but with a factor that weights for equity. And the most important is that you typically get trajectories as concave as this one. So you can lower the risk faster in your portfolio. And indeed, at some point, you might question if this particular portfolio is the right one to keep investing, or you should be doing better in other. So this was first applied to the Duero Basin in Spain with 27 facilities, some of them in the pictures to your right. And that's how we are dealing with this question in dams. Main challenges in implementing it worldwide, in becoming mainstream. I think some of the speakers are gonna also talk about challenges, but the way Eric Halpin and myself did put it some years ago when we wrote our paper in the Journal of Risk Research is that you need to set up the concept, the ontology of the risk. We need to be ready to cope with complexity, uncertainty, and ambiguity. You need, in some cases, go all the way to quantitative analysis and ask yourself about your tolerability to risk. And last but not least, you need people to be well trained and capable and engaged. You need to communicate inside and outside your organization, and you need to make decisions. And the decisions is the form, governance is materialized. So the world is moving with some struggles, but it's moving one way or another through this wheel. And more and more places everywhere are getting this in their own way and making some considerable success. So what is India doing that can serve better to the cause of risk governance? Basically, the DRIP has been a major step forward. I'm going to refer to the guidelines for assessing and managing risk associated with dams published ago, where the program of dam safety is recommended to be based on solid pillars like maintenance and operation, instrumentation, surveillance, inspection, and emergency action planning, but not only. It is like a loop, providing feedback and vice versa to failure mode identification, dam safety risk assessment, making the proper decisions on gaining more knowledge and making actions either in the form of investments in fixing activities or gaining more knowledge. The most important thing is that India has more than 4,000 large dams, that it's making this in a comprehensive way, and it's gonna, in my opinion, change the dynamics in the full region. And it's a mirror where most of us, and certainly or the neighbors in the region, are gonna look to know what to do. And I'm sure it will incorporate the best practices and will move forward to create best practices for others. As I said, DRIP is in the heart of this paradigm shift, and it incorporates a lot of actors, institutions, universities, funding bodies as the World Bank, and it's an enormous effort in terms of governance that is setting the ground for a great improvement from all senses. So there's a question that we wanted to put on the table, Mr. Pramod Narayan and myself, which is, we are making all this effort, but why? Is it that dams are a threat to sustainable societies, then we have to deal with them as a threat, or they should be conceived as an inherent part of what we think sustainable societies are in the modern world? And there's no a universal approach to this, but going to the facts, dams and reservoirs play a major role in sustainability. Water supply, irrigation, drought mitigation, clean energy, of course, flood protection. And again, going to the facts, I like to bring this figure, now that we talk a lot about storing energy and balancing the grid, etc. 94% of the world energy storage capacity, which is a must for transition to a clean energy setup, 94% is hydraulic. I think that's a big fact that we cannot forget. The capital role in dams in water resources and flood risk management, of course in public health in terms of providing foods, etc. But while doing the risk assessment, it's not that we are certainly thinking that we are dealing with a threat, is that we are doing an accountability of the added value of different operating rules. For instance, how can we optimize energy production versus flood protection, and doing both right? Prioritization of all type of investments, and at the end, creating resilient communities that are enabled to understand and manage risk comprehensively. And that comes from emergency planning to smarter urban developments. So we are at the heart of the sustainability, and we are ensuring our sustainability instead of dealing with a threat to sustainability in our point of view. So proper dam safety management programs such as DRIP understand dams are inherent part of sustainable societies, and investments in dam safety are ensuring our future from that point of view, without neglecting, without ignoring the risk, but making it an opportunity to do things better. And that's the spirit of DRIP 2 that will be starting soon. And that's the final comment that Mr. Pramod Narayan and myself wanted to make. So thank you very much for inviting me as a keynote speaker, and I'll be happy to check the chat and or start giving the word to the next speakers. I'm gonna stop sharing. Is there any question in the chat? I don't see any.
No, sir.
Good. I will open the floor at the end again. So if there's other questions, I can take them by the end of the session. So I'm going to start giving the word to our speakers. Remember to introduce yourself, please, in the first slide, and to use around 10 minutes. So first speaker is Dr. Naidu, and the paper is on seismic hazard assessment at Palgan district, a structural perspective. So you are invited to share your screen and proceed.
Yes, sir. I'm present, sir. Thank you, sir.
You are very welcome.
Can you see my presentation, sir?
Yes, yes.
Okay.
And we hear you well and loud. So
Good morning, ladies and gentlemen. This is Dr. G.D. Naidu, scientist from Central Water and Power Research Station, Pune from India. So in my presentation, I wish to speak about the seismic hazard assessment of Palghar district from civil engineering point of view. Basically, Palghar is an area situated in the state of Maharashtra in India. Recently, this area has drawn the attention of earth scientists in India, as this area is witnessed with unusual frequency of earthquakes in the magnitude range of 1 to 4 since November 2018. So the causative mechanism behind this seismic activity is a debate among the experts in seismology. Some experts have opined that this is an earthquake swarm, as these earthquakes are restricted to a small area of 4 to 5 kilometers for long duration. On the other hand, some other experts have an opinion that this is not an earthquake swarm, but these earthquakes are connected to tectonic activity, as most of these earthquakes have the focal depth of greater than 5 kilometers. So, no. Actually, my slides are.
we can see you pass it.
No, sir. Actually, I want to share my presentation from my side.
We were.
Sir, please you share again. You share again, please. You share again. Hello.
Yeah, please. Just a minute.
Okay.
Now we are not seeing it.
Hello.
Yeah, it's
Sir,
uploading. It's uploading.
Okay.
Yeah, my
Yes.
presentation.
Yes.
Yeah. We see it.
Yes. Thank you. Yeah. So, experts have different opinions, and this debate will continue until the causative mechanism is understood. behind this seismic activity in Palghar district. But at the same time, a large number of buildings are being hit by these earthquakes. So a major civil as well as the housing structures needs to be strengthened and designed as per earthquake resistant building codes in the Palghar district. So earthquake resistant building codes such as BIS, Bureau of Indian Standards, and also in addition to this, we need to estimate some site specific seismic design parameters estimated by some methods, widely accepted methods. So here, Bureau of Indian Standards are readily available, there is no doubt. But in addition to that, we need to estimate the future ground motion of the forthcoming earthquakes using the site-specific seismic design parameters to mitigate the seismic risk. So keeping in view of the structural safety as well as the threat to the life in the Palghar district, we carried out a seismic hazard assessment study using the probabilistic approach for 2% and 10% probability of exceedance of MCE as well as DBE levels of ground motions, which corresponds to 2,500 years as well as 500 years return periods with 50 years of exposure period. So these are the frequency of earthquakes in the Palghar district at different focal depth ranges. Here you can observe the most of the seismic events have the focal depth range from the 4 to 20 kilometers. So this may be one of the evidences to say that these earthquakes may be connected to the tectonic activity. So this is the seismotectonic map of the Palghar and its surrounding area. So here yellow shaded portion is the Palghar district, and these are the different seismotectonic features, faults, lineaments, etc. And some historical earthquakes are also plotted over here, and this earthquake cluster belongs to the Koina-Varna seismic region. So these are some steps in the analysis of earthquake catalog in order to estimate the future ground motion, the earthquake parameters. Here, initially we prepare the earthquake catalog by collecting the historical seismic events from different agencies like USGS, ISC, IMD, etc. So this catalog contains the magnitudes in different scales, such as local magnitudes, surface wave magnitude, body wave magnitude, and moment magnitude, etc. So coming to homogenization of earthquake catalog, this is a process of converting these different magnitude scales into one magnitude scale. So here, for this study, we converted all the different magnitudes into moment magnitude scale using suitable conversion relations. So here the question is, why should we convert into moment magnitude? Why not others? So the reason is the moment magnitude is used in several ground motion prediction equations to reduce the saturation effects. And then coming to declustering of earthquake catalog. So declustering is the process of removing the foreshocks and aftershocks from the earthquake catalog. In general, the seismic hazard analysis is based on the assumption of Poisson distribution of the earthquakes. And main shocks are the statistically independent and they follow the Poisson distribution. So that is the reason we use the main shocks in the seismic hazard analysis study, and we remove the foreshocks and aftershocks from the catalog because they are the dependent events of the main shocks. And then coming to catalog completeness, so earthquake catalogs are generally incomplete due to inadequate instrumentation in the olden times. So here for this study, we used a statistical approach proposed by STEP to estimate the period of completeness for different magnitude ranges. So these are the different seismic source zones identified in the Palghar and its surrounding areas. This is based on the seismotectonic features as well as the occurrence of seismic events within this area. So here Palghar district is situated in the seismic source zone 1 along the west coast fault in this region. And here seismic source zone 2, which corresponds to the area of Koina-Varna seismicity. And then here seismic zone 3, which corresponds to the area between the upper Godavari fault and the Gold fault. And this seismic source 4, which corresponds to the part of So Narmada Tapti lineament zone in central India. This is basically a rift zone. So these are the various seismic source zones identified in the study area. Yeah, this is the completeness plot for the standard deviation versus the time interval. Here, the period of completeness is estimated for 3 different magnitude ranges only for seismic source zone 1, where the Palghar district is located. So the period of completeness is estimated for the magnitude range from 3.2 to 4.4 as 15 years for this particular magnitude range based on the deviation from the deviation of the data set from the mean. And the period of completeness is also estimated for the magnitude range from 4.4 to 5.2 as 70 years, as shown in this plot. And
Dr.
for
Matthew,
yes,
you're approaching the 10 minutes. If you could finish
yes,
in about 2 minutes,
yes,
thank you.
Yes, sir. Yes, sir. Thank you. So for rest of the events having the magnitude greater than 5.2, the period of completeness is estimated as 400 years. So this is the exponential decay curve for annual occurrence rate of the earthquakes versus magnitude. From this plot, you can see that for smaller magnitudes, the annual occurrence rate is higher, but as the magnitude increases, the annual occurrence rate decreases. So in order to estimate the MC and dB levels of ground motions in Palghar district, we need to select a suitable ground motion prediction equations. Basically, there are several ground motion prediction equations developed by several others worldwide. But the question is, which ground motion prediction equation is suitable for this region? So basically, the Palghar district is situated on the basaltic terrain, and there are several earthquakes have occurred on the basaltic terrain in the past, such as Jabalpur earthquake and Latur earthquake, Koina earthquake, and Bhuj earthquake, etc. But the recorded accelerogram is available only for Koina earthquake on this site. So the response spectra developed by few ground motion prediction equations suitable for Indian conditions are used to compare the response spectra of the Koina. So these are the few ground motion prediction equations. Here AS97 stands for Abramson and Silva 97, and BA08 stands for Moore and Atkinson 2008, and CB stands for Campbell and Bozorgonia 2008, and this is Kanamori 2006, and this is Lee 1987. So these are the few ground motion prediction equations used for comparison. So out of these ground motion prediction equations, 3 different ground motion prediction equations of Abramson and Silva 1997 and Lee 1987 and Campbell and Bozorgine 2008 are found suitable for this study area and used with weightage of 30% to AS97 and 30% for Lee 1987 and 40% for CB08 are used to estimate the future ground motion in the study area. So here ground motion parameters are estimated only for rock site condition, and the spectral amplitudes are calculated at 28 natural periods from the 0.02 seconds to 5 seconds. So these are the parameters estimated for this Palghar district. So seismic hazard here estimated in terms of peak ground acceleration and the spectral amplitude at 0.2 second and as well as 1 second for both MCE and dB levels of ground motion. So here the PGA value is varying from 0.15 to 0.26 for MCE level of ground motion. At the same time, for dB level of ground motion, it is varying from 0.05 to 0.1. And coming to spectral amplitude at 0.2 seconds, it is varying from 0.35 to 0.55 G for MCE condition, whereas it is varying from 0.14 to 0.22 for dB condition. At the same time, for 1 second, it is varying from 0.08 to 0.1, and for dB condition, it is varying from 0.03 to 0.4. So these values are written periods of 2,500 years, which corresponds to MCE level of ground motion, and 500 years for dB levels of ground motion with an exposure period of 50 years. Yeah,
Doctor, I really need you to conclude, otherwise there will not be time for others. If you can go to conclusions, I would very much appreciate it.
Yes, thank you. So this is the final seismic hazard maps generated for this study. So here the seismic hazard is estimated in terms of PGA as well as spectral amplitude at 0.2 second and spectral amplitude at 1 second. So here these maps are generated for 2% probability of exceedance, and these maps are generated for 10% probability of exceedance. So coming to conclusion, apart from Bureau of Indian Standards, it is also necessary to estimate the site-specific seismic design parameters for earthquake-resistant design of major civil structures, as this estimation considers several parameters such as local geology, distance from source to site, and also thickness of the overburden and shear wave velocity of the underlying geological strata, etc. So here the seismic hazard contour maps in terms of peak ground acceleration and spectral amplitudes at 0.2 second and 1 second are being generated for 2,500 years return period and for 500 years return periods. This is equal to 98% and 90% probability of not exceeding in 50 years. So it is observed that the seismic hazard in terms of PGA, it is varying from 0.15 G to 0.26 G for MCE condition and 0.05 G to 0.1 G for dB level of ground motion in the study area. So finally, in spite of the fact that the causative mechanism is not clearly understood in the Palghar seismic activity, Palghar region, so this may be either due to the reactivation of the existing faults by internal tectonic process or intrusion and circulation of fluids, meteoric water, that is within the weak zones of the crust. So here seismological networks have already been established by NCS as well as NGRI recently. In addition to this, some geophysical investigations are also being carried out to understand the causative mechanism behind this seismic activity. Thank you for your attention.
Thank you, Dr. Naidu. We are not going to check on questions in this case, as we went a little bit far on time. We will see if there's questions by the end of the session. Thank you. Next speaker, Takaisa Tabuki, if you can share your screen and proceed. I think Dr. Naidu has to stop sharing.
Excuse me, our next presenter is Takahisa, right?
Yes.
Okay. I sent the video to the Icold.
Okay. Okay. If you can upload it, please.
Sorry. Can you show?
We're on the way. Yes, I believe so.
This one. Okay.
Yeah. Okay. Go ahead.
Chairman, this is Tabuchi, Kansai Electric Power Company.
I would like to make presentation about the establishment and the implementation of the emergency action plan on the Namniap 1 hydropower project in Laos. According to the Federal Emergency Management Agency in USA, the EAP is a formal document that identifies the potential emergency condition at the dam and specifies actions to be followed to minimize loss of life and property damage. The EAP includes a notification flowchart, response process, responsibilities, preparedness activities, inundation map, and additional information. In the guideline, some cases having damage on the assets along the downstream river course are introduced, and it is recommended that the EAP is uniform with other EAPs that are managed by national level agencies. There is 9 villages along the Namniap River, as shown in the left figure. Total of 1,600 households and 8,500 people are residing. The villages are located near the river, as shown in right figure. They rely on the wells for drinking water due to deterioration of the quality of river water, and it is rare to use the river water as irrigation because their main cultivation style is rain-fed agriculture. Fishing is not popular because of the decreasing yield, where in the past people lived mostly on boats for transportation amongst villages, especially during the rainy season. Since the construction of the Namniap 1 project, access road most transport is now by road, and boats are now mainly just used to access farmland across the rivers. To facilitate this minimum water depth, allowing boats traversing the river is maintained in accordance with the concession agreement. I would like to explain the example of the implementation of EAP and issues in Laos at Project X. Had not disclosed the inundation map since residents are likely to panic. When emergency events did occur, many residents did not get notified because contact person had not been given essential information. At Project Y, some of the saddle dams were overflowed by hydraulic gradient in the large reservoir during the flood event. There also, it took time for the flood to propagate from the upper reach the downstream of the reservoir, and the event couldn't be prevented by control spillage. Now, Project Y is updating the flood prediction simulation to control the reservoir water level during the flood. At the Project Z, one of the saddle dams breached gradually over roughly 24 hours period. It caused substantial damage because while residents were notified of the event, they did not know how to evacuate effectively. It must be ensured that they will have an appropriate understanding of the EAP. Namniap 1 management plan is shown. It is divided to operation plan, inspection plan, maintenance plan, deterioration diagnosis, environmental plan, and safety plan. EAP is one of the safety plans. In order to identify conceivable emergency events, a few scenarios are considered. For each of these scenarios, risk levels are defined and relevant actions are allocated. These definitions have been temporarily set based on the practice in other projects during the construction phase. However, they were adjusted according to the actual behaviors of the dam, as suggested by NLP1 subset review by the Dam Safety Review Panel organized by Lao government. The initial impounding was suspended twice in accordance with the guidelines set out in the EAP, and each time investigations were undertaken and appropriate measures were taken. It is judged that the plastic movement of the dam foundation closely corresponds with repeatedly rising and lowering the reservoir water level. The items to be monitored and their frequency and determined along with the period convergence of dam behavior, and dam behavior are monitored and evaluated by the NLP1 staff daily. The example of the application of damage along downstream river course, the way of the precaution is differ from each project. For example, discharge test and the prevention from the entering are not conducted in some projects. NLP1 conducts the precautions of damage along downriver course carefully based on the example of other projects. The warning is conducted using the speaker on the car before the discharging. The warning is conducted from the dam site to downstream village. In addition, the signboard was installed at the downstream of the dam. This figure is inundation map. In case of the design flood, 10 hours from the start of the flood discharge amounting to 3,000 cubic meter per second occurs, resulting in inundation at the middle river course, which is the maximum inundation after 28 hours as shown in left figure. And after 48 hours, the inundation turns on convergence and is reduced to below 0.5 meter at the middle river course as shown in right figure. From the middle to downstream, the river course will be widely inundated with 1 to 2 meter depth and partially with 5 meter depth. However, around the confluence with the Mekong River, no inundation occurs. The figure shows the inundation map of the confluence with Mekong River. It was found the Mekong River flood has much impact around the confluence with the Mekong River, so that it is necessary to share information and discussion with related agencies on how to mitigate this area. The notification flowchart is shown in left figure. According to the agreement with the Lao government, the NLP1 does not have responsibility for notification and evacuation residents. However, the NLP1 is making the effort to work cooperatively with the Lao government. It is key that special attention is given to elderly as well as to the less mobile and to mentally impeded persons. So they will have an understanding of the EAP and that where necessary special agreements are made to ensure they are evacuated. Therefore, NLP1 conducted the explanation of evacuation and the evacuation drill. Okay. In conclusion, first, in order to identify conceivable emergency events, various scenarios are considered, and for each of these scenarios, risk levels are defined, relevant actions are allocated. NNP1 has established the method to notify the dam operation with a timely and appropriate manners. Third, when usual movement is found, the quick response, such as investigation, evaluation, and measures are also required. Fourth, it is found the Mekong River flood has much impact around the confluence with the Mekong River. Therefore, information sharing with Mekong River Committee is necessary. Fifth, evacuation drill is important and it was implemented in 2020. Okay, this is my presentation. Thank you for hearing my presentation.
Thank you very much, Takaisa Tabuki. I don't see questions in the chat, but I have one question, if you can take one from my side.
Yes.
Because I'm not sure I fully understood the issue with the disclosure. In your presentation, you had said that at least in one case, the inundations maps were not disclosed because people could panic. So if you can develop a little bit the state of the issue, are you disclosing all these maps widely or not, or how is it going?
Yeah. So, what I want to say is that if only inundation map is shared with residents, it might cause might cause panic. But if I share the inundation map with explanation and the drill, evacuation drill, panic will not occur. So this is the point of the sharing information.
Okay, now it's much more clear. Thank you very much.
Thank you.
So our next speaker is Eya Isomaki, who, by the way, I take the opportunity to say hello, and I'm sure it will be a very nice presentation. So please proceed when you're ready.
Thank you. Thank you, Ignacio. So my name is Eija Isomäki. I work in the ELY Center for Kainuu as a dam safety authority. Now I have some...
Ladies and gentlemen,
sorry, this was not supposed to...
My name is Eija Isomäki. I work in the ELY Center for Kainuu.
No. So you're doing the video?
No, I was not supposed to.
Do whatever you want. You can share a screen.
It went wrong. Okay, maybe this way. I hope my screen is showing you now. I can't see it now anymore.
It's not still in presentation mode, but we see it.
Yeah.
Just
Good.
Go ahead.
We will go with this one. So my name is Eija Isomäki. I work in the ELY Center for Kainuu as a dam safety authority. I'm also the secretary of Icold and a member of the board. Here you can see where Finland is located. It's about 3.5 hours from India, as if you only see the time difference, so not that far. Here, some facts about Finland. They say We are the safest country, one of the safest country according to many ranking lists. We also have the happiest people here. But how about dams? So some facts. Finland is a very flat country, so we don't have that high dams. Our highest dam is about 50 meters high. Our population density is very low, but we have thousands of lakes and plenty of groundwater. Actually, most of the people in Finland drink groundwater. It is so clean that we don't really have to do a lot for it to be able to drink it. But we do have a pretty precise Dam Safety Act, which came in valid 2009. We had a previous one also. It was dated 1984. After the act came the Dam Safety Decree 2010. These both legislations apply to all dams, basically. So water storage dams, flood embankments, waste dams, and these include tailing dams as well. And after this legislation, we made a dam safety guide 2012, and it has been updated a few times after that. This guide is something that explains the people working with dams, how should they work. So it's guide for them and for us as well. These all are written also in English, and you can find them in the web. So classification, when the new act came 2009, already 10 years ago, more, we had a classification in the legislation as well. There are 3 dam classes, 1, 2, and 3. And in class 1 is such that in the event of accident, it causes danger to human life or health or considerable danger to environment or property. Basically, all but one of our class 1 dams cause danger to human life. And the class 3 dam is such that in the event it causes only minor danger. And of course, we have thousands of smaller dams that are not in the classification. Here are our dams. So we had 451 classified dams, and 86 of these belong in the class 1. Of these 451 dams, 120 are waste dams, and these include the tailing dams as well. And 56 of our dams are large dams according to Icold criteria. They are mostly embankment dams and usually connected with hydropower. In the map, you can see how they are located. There are different classifications and different types. And then the challenges. As I was writing my paper, the World Declaration on Dam Safety was also published and written. And I was not surprised as there were many similarities in these papers. Aging infrastructure, retirement of experienced personnel, and climate change are huge issues in Finland as well. So first case, I will show you one case which is connected with aging of infrastructure. This is Tammerkoski in Tampere. This is in the middle of huge water systems. So with the borders, you can see that in the middle there is a blue spot where this Tammerkoski is located. And the water reservoir area, water system area is quite big actually, as you can see in the map. These dams are in the middle of the city. There is actually 3 dams which go through Tampere city, and this is one of the largest cities in Finland. Offshore dams were built, and also National Board of Antiques was involved. This is a big institute in Finland, actually. These dams are around 100 years old, so they are quite unique in Finland. And This is a picture from the channel that heads to the power station. And when they were taking the bricks off from the channel wall, they were putting numbers to it so that they would be able to put them just to the right spot after the work was done. Then the aging of people. In Finland, we don't have really dam safety training anymore, or education really. So we organized dam safety training course. This was done by us, the Dam Safety Authority, and Tampere University was the one who really operated this training course. We have the 12 training days. You can see the contents over there. And they were held in 2019 and 2020. There were 100 to 150 participants in each day. Also, students were involved, and they were able to have this training course as part of their education. And we had a very good comments on the course. It was really needed. Then we have Dam Safety Information System, which was first mentioned in the legislation 2009, and after that the work was done. Nowadays, all classified dams in Finland are in the system. It's a common tool for authority and dam owners, so the dam owners can see the information of their own dams, and they can also share the information, for example, for consultants and such. And authorities like Dam Safety Authority and Rescue Authority, we can see all dams in the system. There are certain issues which are described in the Act and Decree, which must be in this system. You can see these over there, the list of them. And many dams have more information there. So there you can add pictures and maps and everything there. It's very useful. And basically, I could enter the system from any computer. So I have a possibility for that. And then the climate change. In Finland, we have 4 seasons, really. So we have a very warm summer, and we have very cold winter normally. But there has been change for that. This winter was not typical because it was, I would say, normal. We had a -25 and there's still around 1 meter of snow outside. So I'm in southern Finland. But climate change has changed this so that we have more of a milder winters here in southern Finland. Last year we had winter flooding, which is kind of showing us what the climate change is capable of. This was not normal, not typical 100 years ago, and it was a very special situation. In northern Finland, the climate change has created more and more snow during winter times. And then fragile ice and ice dams are something that appear during before winter time. And they are causing more troubles. Just a few weeks ago, we had troubles with one hydropower station as the hydropower station went off. And then they had to open the floodgates, but there was too much ice, and it was not an easy situation, but they were able to handle it. Climate change also has to be considered with dam safety hydrological calculations. And we check these every 5 years. And there has been some changes made because of the calculations. And then the conclusions. So 2020 Fingold celebrated 60 years of important work with dam safety issues. These challenges in dam safety are there, and they are not disappearing anywhere. So there is a lot of work to be done. Dam safety authorities, consultants, and everybody working with dams, dam owners, and everybody are doing their good work to minimize these challenges. You can read more examples and descriptions in my paper. I hope you are interested in. But now I say thank you.
Thank you very much, Eya. I keep not seeing questions in the chat, so I'm gonna make a question myself, if that's fine.
Yes.
When you were talking about climate change and the changes in hydrological calculations, etc., I wonder, particularly being most of your dams for hydropower, how is it, if it is affecting a lot the operating rules and the way the dams are operated, and if it's stressing the system anyhow, or you're still handling it properly?
We are handling it properly, I would say, or the dam owners are handling it. But for example, on one dam site in Middle Finland, they are building a new hydropower station. It's being built by side of the old one, so that they will be able to handle more water in that place, for example. So they have to work with it.
Okay, thank you very much. Let's see if there's more questions by the end. Please don't leave. And we give the word to Dean Darkey. I also take the opportunity to say hello. And I wish we all had made in person, but that's the best we can do. So Dean, the floor is yours.
Thank you, Ignacio. Are you able to see my screen?
Yes.
Okay. I need to go to presentation mode, and you can see that.
Correct.
Correct. Okay. Very good. So thank you, Ignacio. I am Dean Durkee. I'm a senior consultant and vice president with Gannett Fleming, and also past president of USSD, the U.S. Society on Dams. So I'm going to present today on the challenges associated with the implementation of the Federal Energy Regulatory Commission's risk-informed decision-making process. We refer to the Federal Energy Regulatory Commission as FERC. And FERC is in the process of rolling out these new risk-informed decision-making guidelines. And as many of you may know, in the US, we have not previously used a risk-informed approach. Aside from some of the federal agencies, the Corps of Engineers and Bureau of Reclamation, which has been using it for about 15 to 20 years. So the rest of the country, most of the dams in the country have not been subjected to this process. I'm going to use an example, a pilot project that was completed under these draft guidelines to kind of illustrate how the process is utilized, and then talk about some of the challenges when I get to the end. My presentation is 58 slides, so I'm going to go quite quickly to try to get this under 10 minutes. So I'm sure Ignacio will keep me honest.
I will be monitoring.
Okay, so this is my agenda. I won't spend a lot of time on that. I'll just jump right into it. So this was a Southern Cal Edison project, and Southern Cal Edison was established in the late 1800s to provide electricity to about 15 million people in Southern California. They have about 83 dams, and they generate about 1,200 megawatts of total capacity. And they implemented their dam safety risk assessment program in 2008 and modeled that after Bureau of Reclamation. And they initiated that with a portfolio screening process. And the goal there was to gain better definition of their portfolio risk, to improve their risk management process and prioritize dam safety issues and budgets. This was initiated in 2009 in a several-week-long portfolio screening process with stakeholders from the dam safety, project engineering, and operations groups of Southern Cal Edison, as well as consultants and representatives from the FERC regulatory, as well as the state of California regulatory agencies. And they came up with a number of failure modes for each of the dams in their portfolio. And I mentioned 83 dams, but there's really only 22 that are regulated under FERC. So only those 22 were part of this screening process. They held some follow-up workshops to prioritize those studies and develop some actions to reduce or understand the risk where they could. There were multiple considerations there. FERC requirements, there are mandates under FERC. Risk priority category, ease of accomplishment. Maybe there's some low-hanging fruit, some things they could do, some interim risk reduction measures, and then just build on the momentum of work in progress. So out of that, they prioritized Rheindaler Dam as one that they wanted to utilize the risk process or the pilot process that FERC allows them to do. So a little bit about Rheindaler Dam. It forms Ellery Lake. It's in the eastern Sierra Nevada mountains. And it's a rock-filled dam with an upstream concrete facing. There's a parapet wall along the crest, an intake and outlet valve house. There is a auxiliary spillway on the left abutment and a flume downstream to measure flows through that auxiliary spillway. It's a quite old dam. It was built in the early 1920s, and there's not a lot of records on the construction. You see this plan view. This is typical of what we had to work with in understanding the dam, and this is the only section view that we have of the dam, and it shows that it's a loose rock fill with some hand-placed rock fill on the upstream side of this homogeneous embankment, and that was there placed so that they could then place the concrete facing on the upstream side of the dam. There's a parapet wall at the crest that I mentioned before. I won't go through this whole history, but the dam was built in 1924. There were some gates in the spillway that were removed. They had a remote control system that failed. They were subsequently removed. The parapet wall was added, and then the dam was reclassified as a high hazard dam by FERC in 2006. So there was a focus risk review performed on Rheindaler in 2015, and they determined that overtopping due to a flood event is the primary risk driver, and that there was potential for spillway blockage that would significantly increase those risks. In addition, most of the consequences are associated with campgrounds downstream. And this shows what the spillway looked like before they modified it. They took out the old radial gates, they raised the bridge. These are just some interim risk reduction measures that they did following that 2015 workshop. And so you see the new spillway here. They were just trying to increase the spillway capacity as much as they could. So we went then into a semi-quantitative risk analysis. We had 8 failure modes that were evaluated in the semi-quantitative risk analysis. And that was a 3-day workshop held at their hydro office, about an hour from the dam site. That consisted of a 1-day visit to the dam, as well as review of existing information, review of previous potential failure modes, and then performing the SQRA on the 3rd day. And this shows the results of that semi-quantitative risk analysis. And there was 3 risk drivers identified: this PFM1, which you can see here, which is spillway plugging during a flood leading to overtopping and erosion, and then failure of the slab. And then there's 2 additional PFMs associated with slope instability and spillway erosion potential. These were eventually ruled out. There was some additional work done between the semi-quantitative risk analysis and quantitative risk analysis, and that lowered the risk associated with these when that additional information was obtained. So going into the quantitative risk analysis, there was really only one failure mode to evaluate, and that was a large storm occurring in the basin and the reservoir rising and overtopping the parapet wall. Unsuccessful at intervention, and that overtopping flows exceed the erodibility threshold of the rock fill, ultimately leading to failure of the slab and then failure of the dam. For the quantitative risk analysis, we simplified that failure mode a little bit so that we could correlate the nodal estimates with the actual things that we had analyzed, particularly combining some of those steps in that event tree to, for instance, the erosion leading to failure of the slab. That was all done in one step in the probabilistic analysis. So this just shows our event tree. And so we had to look at a couple of different storm scenarios, the general storm and local storm, which occur at different times of the year. We did a stochastic event flood model, and we looked at debris blockage as well as without debris blockage. And this shows the results of that analysis. Essentially, whether you're talking about the local storm or the general storm, we overtopped the parapet wall between about the 1,000-year and 10,000-year events. So we had this overtopping initially beginning at about the 1,000-year event, and there's two places that we focused on. One was in the groin area where we had concentrated flows during overtopping. We expected more seepage in that location, and then we had overtopping of the embankment itself. So for structural intervention, we looked at the time that it would take for someone to get to the site from their office an hour away in Bishop, the availability of resources once they got there, and it was determined that essentially there was very low probability of successful intervention. And then looking at erodibility, we did this probabilistic study of erosion both for the typical embankment section and in the groin area, considering the local storm as well as the general storm. We looked at increments of overtopping between 0 and 2 inches and on up to 11 to 13 inches. And those shown in green essentially are expected to be no or insignificant erosion. Yellow refers to the slab not being exposed, maybe some erosion. And then when you get into the orange, you're starting to erode the embankment, but we're not exposing the slab, or the slab is exposed, but it hasn't failed. And then red, of course, is when the slab starts to fail. For consequence analysis, we did a 2D dam break model and use of RSIM, Reclamation's consequence model. And just I would note that 90% of the local storms occur between May and September during the peak recreation season. And 90% of the general storms occur between November and March when the campgrounds are closed. And so the results of that illustrated that we really have less than one potential life loss during the off season up to a peak, or during the peak season, up to 9 potential life loss. So the nodal probabilities were estimated by the SMEs with the appropriate experience. We had them estimate the low and the high before they estimated their best estimate to avoid anchoring to their best estimate. We assigned a probability distribution function and then utilized the Monte Carlo simulation. The annual probability of failure was established using the at-risk Monte Carlo, and then the distribution or annual probability of failure was developed based on a range of probability at each node. Consequence analysis was also performed, and the annualized life loss was then generated using that likelihood and potential life loss. So this shows our initial results, and you can see this for both the local as well as the general storm. And then we took a weighted average to determine our annual probability of failure incremental life loss. So with those results, then we started looking at alternatives for mitigating this analysis.
I have to say that you're a little over 10 minutes. If you could.
This will take me just a couple more minutes.
Okay.
All right.
Thank you very much.
Understood. So we looked at structural mitigation, which includes lowering the probability of overtopping or providing overtopping protection. So I'm just going to run through what those might look like. We could add an additional spillway. This is a labyrinth spillway. We could also modify the existing spillway, utilizing a labyrinth spillway and increase spillway capacity. This is just another version of a modification of the spillway. We could also raise the existing parapet wall in one section and lower it in another section, and then turn that into a larger spillway. And this just shows where we might raise that section of parapet wall. And then in this area, we would armor this section and allow overtopping to occur outside of the spillway at the immediate right adjacent to the spillway. And that's what that might look like in cross section. So then we evaluated those alternatives based on how much they would reduce the annual exceedance probability, and you see the results of that here. For overtopping protection, we looked at roller compacted concrete armoring of the rock fill. And this is what that might look like. We also looked at articulated concrete blocks, and that's what that might look like. There's also a lot of boulders available in close proximity to the dam, large boulders which could be used to provide additional overtopping protection in the downstream side of the dam. So here you see the boulders that are available on site. Those could be slush grouted if we wanted additional protection, and this just shows what that might look like. And then we evaluated the cost of all of these alternatives to determine which ones would be the most cost effective. These are still at a very preliminary stage. In addition, we looked at non-structural mitigation with enhanced warning systems or moving the campground so that we could lower the consequences if this dam were to fail. So in summary then, just the challenges associated with this are that initially the PFMs that have been developed previously are really not in an adequate condition to use for semi-quantitative or quantitative risk analysis. So going into these projects, we're going to have to do a lot of work on the potential failure modes that are existing from their previous process. There's limited to no flood frequency or probabilistic seismic hazards information, so a lot of that has to be developed in order to go into these risk analysis processes once FERC rolls out their new program. Also, while they have inundation maps downstream and they understand the population at risk, the consequences are not well understood. And of course, since in the US, we really haven't been utilizing risk largely across the industry, there's availability of limited number of people who can serve as subject matter experts in these types of workshops and these types of analyses, and the high demand for that limited number creates issues with coordination and schedule and drags the projects out quite a bit. And then there is a tendency for SMEs to anchor to their simulation and calculation results. So that was 58 slides in a little over 10 minutes. I'm sorry to rush it so much. I want to acknowledge my co-authors, Matt Muto from Southern California Edison, and Matt Balvin, who's a principal engineer at Gannett Fleming.
Thank you, Dean, very much. I'm afraid that we might not have questions, time for a straight question for you.
Understood.
As we still need room for our last speaker, though I don't see him. I wonder if Andy Zielinski is connected. From the organization, is there any video from him that he uploaded?
Good morning, ladies and gentlemen. Due to the time limitations, both on the presentation and on the size of the video I could prepare, I will just stop at key points of the developments of risk assessment framework for dam safety. One of the key points in this development was happened in 1980s, exactly in 1987, with the publication of U.S. Bureau of Reclamation, ACER Technical Memorandum Number 7, which presented conceptual model of conditions preceding dam failure. This model has been universally accepted and served for many years for the vast majority of risk assessment studies which were supporting dam safety decision making. And this model is still being used with some modification. It evolved into what we very often call today event tree technique for dam safety risk assessment. One of these event trees is presented on the screen. The next important point in the development of risk assessment for dams was publication of DEFRA guidelines. DEFRA is a United Kingdom environmental agency, and in 2013 they presented the concept of dams as systems which have physical features, have operational features, and have humans involved in all of that. Dams, even individual dams or single dams, can be perceived as relatively simple systems, but we also have very often dams in watershed where there are multiple dams and multiple reservoirs. In general, the dam system can be perceived to include 4 different subsystems: political and socioeconomic, management, technical, and natural. Technical, it is all what we put into the watershed, the structures, and it is also how we operate. Modern system safety science understands that dams are systems which are belonging to the class of socio-technical systems. One of the most important characteristics of socio-technical system is that its safety is the so-called emergent system property. It is not a component property, and it can be, and it has to be, analyzed in the context of the whole. Not all the past methods, which were developed over many, many years, can accommodate risk analysis of multiple dam systems when we have a lot of interconnections. These interconnections can be physical, but they also can belong to operational interconnections when the behavior of a single dam can affect the safety of dams downstream, but also dams upstream, because it forces them to change the way they operate. One of the methods which allows to do that is stochastic simulation of dam system. Stochastic simulation can include both slow and fast system dynamics, can explicitly include directly in the model all interconnections between different components. It can include control feedback loops and full range of system responses, not just failure or no failure, everything else. And another important feature of stochastic simulation is that the loadings, and especially hydrologic loadings, can be dynamically adjusted depending on the system response as the simulation goes along and the water is moved through the system. Depending on disturbances of the systems, the loadings can change. The adjustments can be made during the simulation, affecting the further simulation. Is it practical? Because we are talking about simulation for very long time intervals, tens of thousands of years, hundreds of thousands of years of daily time series. Fortunately, we have very good software platforms which can support development of complex models, and that includes models of river systems and reservoirs and dams. One of them is GoldSim, another one is MATLAB. And important part is that computing power of contemporary desktop PCs is sufficiently good enough to carry out risk assessment for large dam systems for, as I said, tens of thousands of years of simulations. Another development which began in early 2000s was the Bayesian networks, and it has been in development, and the most advanced developments, quite recent, allow for the integration of simulation and Markov chains in support of Bayesian networks for probabilistic failure analysis of complex systems. I want to end this presentation with a quote from a famous physicist, Edwin Thompson James, who observe that as knowledge advances, we can invent better and better models which reproduce more and more features of the real world and in a better and more accurate way. We expect that any model we are now able to construct will be replaced by more complete ones in the future, and we do not know whether there is any natural end to this process. Experience tells us that there is no end. The progress is continuous, and it will continue. What we have today will be replaced tomorrow or after tomorrow, but by what James said, better and more accurate and more sophisticated models. So what is the future? What we need to do to get this better models? Analytic methods, probabilistic characterization of hazards, failure modes, and failure mechanisms, with the emphasis on probabilistic modeling of mechanisms. We also need improvement in the practice of elicitation of subjective probabilities from experts in cases when analysis is not practicable or is not possible because we do not have enough knowledge. We also need to engage experts from other non-technical disciplines into development of better means of characterization of socioeconomic and environmental consequences. We also need to engage all stakeholders into development of new framing of risk evaluation criteria. That should include politicians and the public, not just dam safety specialists. Thank you very much for your attention, and I wish you very successful symposium.
Okay, I don't think Andy is with us, so I don't see either any questions in the chat, and I wonder.
No question, sir.
Okay, so looks like we're over time, so maybe we can get two very final short questions to the two speakers that I didn't ask anything. To Dean Darkey, very straightforward. Beyond that particular case that you presented, how would you judge how mainstream has it become within FERC facilities to do this type of analysis? It is 100% today, it's on the way, or it's and if it's mandatory or it's an option of
right. Yeah, it's a good question. It's not mandatory yet. The draft guidelines were out for review by the engineering community. Folks provided many comments on those, and FERC is now addressing those comments, and they expect to roll out the final guidelines and requirements sometime this year. And so I expect by the end of this year, it will be required for then their periodic investigations. So that'll be a comprehensive assessment that will include just the SQRA portion, what they refer to as a level 2 SQRA. As far as people using it now, there have been a number of pilot projects. I'm going to guess that maybe between 5 or 10. I know of 4 that I've worked on. And that's out of several thousand dams that FERC regulates. So most are not using it. The pilot projects are interesting in that there's a limited number of people, or in fact, one person who sits in on all of those because of the limited experience of the other people that are performing them. And So that's really limited the number of pilot projects we could perform in a year. And I tried to allude to that in the paper a little bit, or in the presentation. We just don't have enough people who are familiar enough with risk to perform these adequately as quickly as we need. But once they're rolled out, FERC's plan is in the first year to get 100 to 200 of them done a year.
Okay, thank you very much, Dean. And to Dr. Naidu, that I didn't ask anything before, of what the impact of the mapping is going to be on the seismic assessment of dams. Have you evaluated the impact in cost repairs, or how are those maps going to influence the industry of dam safety? Do you have a view on that? I understand that you don't have precise numbers, but what's your view, Dr. Naidu?
Still alive?
Are you there? He left us.
I don't know.
You're not there, right, Doctor?
He's not in the participants.
Okay. So there's a question for me. Explain risk chart in one of the slides on the top left. That's gonna be tricky. I'm gonna try to guess if there's something in the top left, and if not, we will conclude soon. Let me check if there's something clearly on the top left anywhere. Or if you could be more precise. I assume it might be this one. This is an FN chart, and that shows risk reduction trajectories. And the good news is that that is part of the appendix of the guidelines for assessing and managing risk associated with dams. So you can fully get the explanation in the guideline. But going to the point, is an FN chart. It shows risk reduction trajectories for particular failure modes. Anything else going on? As we're almost 10 minutes over time, I'm gonna thank all the speakers, the organization, the co-authors, and the public. And I wish you all the best, and I really wish we can see each other more in person mode soon.
Thanks, Ignacio. I'll see you in June.
Hopefully, we count on you. All the other speakers, thank you very much. You made my work very easy. Goodbye.
Have a good night.
Hello, good morning all. Am I audible?
Yes, sir.
I am audible, isn't it? Okay.
Yeah, you are audible.
Okay. Okay, sir. Okay, then today I'll be sharing the experiences which we had in our division that is presently where I'm working, that is Central Water and Power Research Station, with regard to the temperature control studies in mass concrete. And in this presentation, I'll be concentrating on one particular case study, that is the Polavaram project, where the spillway was constructed using mass concrete. So directly I am going to the presentation. So why this thermal cracks occur in mass concrete dams? It is primarily because, as we know, the primary constant of cement is lime. So when we add water to lime, the exothermic reaction takes place whereby calcium hydroxide and heat is liberated. So this rise in temperature takes place due to heat of vibration of cement, which develops thermal gradient between the initial temperature of concrete and the surrounding air temperature. So due to the increase in temperature, expansion takes place, and when this expansion takes place, certain thermal gradients, and when these thermal gradients are restrained, cracks occur in concrete. As you all know that concrete is strong in compression and weak in tension. So if the stresses due to these thermal gradients, that is these thermal gradient stresses are tensile in nature, and if it exceeds the tensile strength of concrete, cracks occur. So such situation occurs in most of the major gravity dams when concrete is placed in thick leaves. And in roller compacted concrete dams also similar problems occur where the concrete is placed rapidly with a small lift height and lift interval. Therefore, careful determination of thermal properties in laboratory, the estimation of suitable placement temperature, the construction schedule, and including the site temperature becomes very essential in order to avoid cracks in mass concrete. So what are the objectives of temperature control studies? So in this graphical representation, you can see if you place mass concrete at a particular placement temperature, it will rise to a maximum temperature and then suddenly it drops to the ambient temperature. So this particular temperature drop has to be controlled. That this temperature drop should be within the permissible limit so that cracks don't occur. So we have to control this placement this temperature drop within the permissible limit. That should be our main criteria for controlling cracks in mass concrete. So these are some of the objectives: estimation of placement temperature depending upon the construction schedule, that is the lift height and lift interval, estimation of final stable temperature, then pre-cooling requirements of concrete so that the concrete can be cooled and placed at the suggested placement temperature, and cooling history of the dam, that is to predict the temperature distribution with time. Now, what are the properties required for the temperature control studies, or rather the thermal analysis? First property is the adiabatic temperature rise, and all this stress I will be explaining in brief in my subsequent slides. Then comes the thermal diffusivity of concrete, coefficient of linear expansion, and of course the strength parameters, that is the compressive strength, tensile strength, the modulus of elasticity, all those are required. Along with that, even sometimes the creep parameters are also required. But for this Pallavaram dam, directly we approach by the stress method rather than the creep method. Then we have determined the ultimate strain capacity. For the ultimate strain capacity, it can be determined by creep as well as by carrying out tests on beams. And the most important data which we require at site is the climatological data at site for last 10 years, 10 to 15 years. In that we require the daily air temperature, water temperature, and relative humidity. So these properties 1 to 5 are determined experimentally in laboratory by conducting tests on fresh or hardened concrete. Now, these are the salient features of Pallavaram project. Most of them must be aware regarding this project. It is a multi-purpose one conferring irrigation benefits to the upland areas of Visakhapatnam, East Godavari, West Godavari, and Krishna district. It envisages drinking water supply to Visakhapatnam township and the nearby areas. It is essentially a diversion run of the scheme project on Godavari River. It is located in Andhra Pradesh near Pallavaram village, which is about 42 kilometers from Rajamundry Road. It envisages the construction of 2,454 meter long earth-cum rockfill dam across main river and a spillway of 1128.40 meter length on the right flank and power-cum reverse switch blocks on the left flank. So these are the general salient features of that project. Now regarding the concrete spillway, these are some of the salient features with regard to the design flood discharge, the flood disposal level. You can see that now there are about 48 gates, size of gate is 16 meter by 20 meter, and the length of the spillway is 1128.40 meters. Now, this was the mixed proportion that was designed for the spillway concreting. It was designated as M15 A80. M15 shows that this is 15 grade concrete, and A80 represents the MSA, as the maximum size of aggregate. As you can see, the maximum size of aggregate, even that quantity in that is around 626 kg per m cube, 40 to 80 MSA aggregate. So this gives the mixed proportion of the concrete mix. Cement was around 210 kg per m cube. The admixture used the water content, and these are the details of the concrete mix. So we carried out the thermal studies on this concrete mix. The design of this mix was carried out by the project authorities from CSMRs. Now, what is the procedure for conducting, what are the laboratory tests that has to be carried out for conducting the temperature control studies? So it comes the determination of strength, creep, and elastic properties of mass as well as screen concrete, determination of thermal properties, computation for estimation of placement temperature for various lift heights and lift interval, and computation of thermal stresses. Now, these are the average compressive strength of the concrete mix that we obtained. You can see for 3 days, 7 days, 20 days, and 90 days, we actually calculated. So we, since the mix, as we know, it was of 80 MSA, we carried out using the screened as well as the unscreened mix. So for screen mix for 40 MSA, we carried out the cylinder compressive strength on 150 mm by 300, 150 mm dia by 300 mm height cylinder. So these are the values of the compressive strength. And for the full mix, since due to that 80 MSA, we carried out the test on unscreened mix. For that, the cube compressive strength was determined on 300 mm by 300 mm cubes and 300 mm by 600 mm cylinders. And even the modulus of elasticity was also determined on the cubes as well as the cylinder. The size are as given below. So in this we can see the 3 days compressive, the 28 days compressive strength is 235, and here we can see 200, and for cylindrical compression it was around 235, and for 90 days it was around 278. So as we can see, it is well above the designed mix, that is of 15 MPa or 150 kg per cm square. And even the modulus of elasticity, you can see it was within the acceptable range. Now, even the split tension was the most important criteria, so we took it as the tensile strength of concrete. So whatever our recommendations were there, that whatever the stresses induced due to this temperature variation in concrete should not exceed this particular value. That is the 3 days compressive strength. So here we, for a further safety, we are told that it should not exceed 10.5 kg per cm square. So that was the final criteria that we had adopted. Now, this was the first, that is the adiabatic temperature rise. So in this, actually we carry out the temperature in an adiabatic calorimeter. In this, the fresh concrete is taken in polythene bags. It is thermally sealed in the adiabatic calorimeter. We insert one sensor into the concrete and one sensor in the surrounding. And in surrounding, we have got some heat, and we have got certain controllers. With that controllers, we maintain the adiabatic condition. There is neither loss of heat to the surrounding or gain from the surrounding. And this particular test we carry out for 7 days for conventional mass concrete. But for RCC concrete, sometimes we have to carry it out for around a month or so. That is primarily because around 60 to 70% of cement is replaced by fly ash in RCC. So in this, we obtain the temperature time, and then we plot it. And then this particular plot is statistically fitted by using the Box-Lucas equation. It is an exponential rise equation. And after fitting the exponential rise equation, we get these two parameters, which are required for our further analysis. That is T0, the ultimate rise in temperature, and M, that is the rate of rise. So this is one particular experiment, that is adiabatic temperature rise, in which two parameters we get. And the second thing is the thermal diffusivity of concrete. That is the rate at which the concrete diffuses heat to the surrounding. It is the inverse of conductivity. So this test is also primarily conducted in a water bath. We take hardened concrete of 20 centimeter by dia by 40 centimeter height into a water bath. It is heated to a certain temperature, say 60-70 degrees Celsius. And for this, we are following the USBR standard. So these are standard USBR plots. And then we monitor its temperature, and then we cool it. Then from that cooling curve, and from the empirical relations, and from the standard diffusivity curve, as per USBR guidelines and as per the IS provisions we have. It is actually a IS 14591. That is the guidelines for temperature control studies. So from these things we get the thermal diffusivity. And the third is the thermal expansion. To determine the, we have to know the expansion of concrete. In this also, the saturated specimen is kept into a water bath. We take its initial reading, and then we heat it to a certain temperature. We take its final reading, and using this expression, we determine its coefficient of linear coefficient of thermal expansion. So after getting these three parameters for this particular mix under study, these were the parameters that we obtained. And the other important parameter, as I have told, is the temperature data. So the temperature data is also very important. So we collected a data of almost 10 years from 2005 to 15. We took the monthly air temperature, and this was the monthly average that we got, 28.8 degrees. And similarly, even for winter temperature and as well as the summer temperature, and this is the mean annual water temperature. So all these parameters are required for running some in-house programs that we have, which include all those input parameters as I have told earlier. And as we know, this concrete construction takes place in lifts. So in in lift-based construction, even some temperature losses has also to be observed. So for that, we follow the guidelines given by IS as well as the USBR. So from heat loss, we finally convert it to the temperature loss. There are three idealized conditions. So from the three idealized conditions, we get the total temperature loss. So these are the three losses. I cannot, since due to restriction in time, I cannot go in details of how these losses are computed, but it is very well explained in the IS code as well as the guidelines of Builder Canyon project of USBR. So after getting all these input parameters, we finally calculate the thermal stresses. So in thermal stresses, we can see the parameter is alpha, that's the coefficient of thermal expansion. The restraint factor, for this also guidelines are given what should be the restraint factor. And from this we get the placement temperature, then the losses. This is the ultimate adiabatic temperature rise, and this is the final stable temperature. So from all these parameters, we will be calculating the thermal stresses. So the permissible thermal stresses as recommended by CWPRS for the mix M15A and 80 understand has been computed with 10.5 kg per cm square based on the 72-hour split tensile strength. So that was the criteria suggested by us. So that so from these computations, the thermal stresses should never exceed this value. Now we had given a ready reckoner to the project authorities as well for various combination of lift height and lift interval, and depending upon the placement temperature and the ambient temperature, what is the loss, and what are the thermal stresses. So these were the combinations that we had given. So if you are going in for a lift height of 2 meters and a lift interval of 72 hours, so the placement temperature can be 12 degrees Celsius. But if you want to reduce it, then you can increase the placement temperature also. So these were the and depending upon the air temperature. So it is by permutation and combination you have to select the placement temperature so that the stresses doesn't exceed that the value of 10.5 kg per cm square. And we had given a graphical representation also depending upon the lift height in meters and the placement temperature, and for mean summer air temperature and annual air temperature. So if you are selecting a lift height of 1.7 meters, the placement temperature should be 13 degrees Celsius. For if you are considering mean air temperature 31.5 degrees Celsius. So based on this also several combinations were suggested to the project people. So finally, the placement temperature of mass concrete, where we are told that for annual air temperature 28.9 degrees Celsius, the mass concrete can be placed at a lift height of 1.5 meter, maintaining lift interval 72 hours by maintaining placement temperature 13 degrees Celsius. And for mean summer air temperature 31.5, the mass concrete can be placed at a lift height of 1.5 meter, maintaining a lift interval of 72 hours by maintaining placement temperature 12 degrees Celsius. And how to achieve this placement temperature? For that also, we have done certain cooling calculations. That means the aggregate can be chilled, part replacement of water with ice, or you can use chilled water. So all these combinations are also given as a ready reckoner for the project people. And during the construction, we had carried out a site visit around 4 years back. So you can see the photographs of the spillway block under construction, the mass concrete. And the recommendations and conclusions. The computations and the results are based on measured thermal strength and elastic properties of mass concrete with design mix M15A80 based on laboratory tests, site parametric data provided project, and as per various standards and past studies conducted. In this, I would like to add that as far as the temperature control studies are concerned, the determination of all the thermal parameters, thermal strength, elastic, and creep properties at laboratory is mandatory. Because nowadays, what people say, they go for quasi-adiabatic test, or they go for heat of adhesion test. Just they test the heat of adhesion of cement, and then they work out all these things using empirical relations. That doesn't solve the problem. So for all the thermal properties, we stress the point that actual thermal studies has to be carried out in a laboratory. And these are some of the suggestions that we had given to the project authorities. Continuous curing is important because volume change due to alternate wetting and drying may lead to development of surface cracking. And up to next concrete, where the concrete surface lips have to be kept moist in order to prevent drying of concrete. And at the same time, following the removal of foam, the side surface has to be kept moist by using a sprinkler system. And in this way, certain cooling effect is achieved in summer, whereby heating by sunlight is counteracted, whereas in the winter, the concrete is protected against excessive cooling. So these are the suggestions that we have. Just by following the recommendation of CWPRS, the Spillway project has been constructed. It is almost in completion stage in mass concrete without development of any thermal cracks. And these are the references that we do. This is the IS code that we have, IS 1451, the temperature control studies of mass concrete, and the other two, the USBR manuals. That means thermal control, the final report of builder can be part 8, and for cooling, it is the final report. So by going through all these references, what are equations we have adopted, you'll be getting. Thanks for your patient hearing. Thank you very much.
Thanks, Mr. Pillai. I think for your presentation, this is a very pertinent topic, particularly for the concrete dams. And most of the risk safety aspects related to dams are basically revolve around this, thermal stresses, which normally get developed when you really don't pay much attention to the core issues related to the concrete. We have an experience, when we were doing one of the concrete dam. We tried to increase the lift height because just we wanted to expeditiously construct the dam because of some risk related to the onset of monsoon season. Okay. So what we tried to do was we increased the lift height to 2.3 meters. Okay. And at that time the air temperature was around 29.5 degrees centigrade. And we did the placement temperature at 11.5 degrees, and we also did some study. Okay. And but we used the slag cement. That was one important thing which I wanted to tell you. And slag cement with at least 55% of fly ash. Yeah, fly ash. So that was the thing which very successfully we could do that concreting without any thermal cracks. Without any thermal. Okay, good. And the dam is also very safe. Now it's almost 11 years, 10 to 11 years. It has been operating very successfully. So I mean, this is a myth that increasing the lift height, it always creates problems. It's not necessary. You have to really do the temperature studies, and then good temperature study can really lead to a good result. Okay. So thank you very much for your wonderful presentation. I think we can go to the next one, which is related to the sonic wave velocity measurement for evaluation of in situ quality of dam by Mr. Vijay. So Mr. Vijay Godke online. Please start your presentation, but limit your presentation in 12 minutes time, 12 to 15 minutes, please. Thank you. Okay, thank you.
Hello. Good morning, all of you. Myself, Dr. Vijay Godke. Is it audible, sir?
Yeah, you are audible. Yeah, you are audible.
Good morning, all of you. Myself, Dr. Vijay Godke, Scientist B from Central Water and Power Research Station, Khadakwasla, Pune. Today, I am delivering a PPT on my paper, Sonic Velocity Measurement for Evaluation of In Situ Quality of Dam. Health of any structure is a very important aspect. Structural health monitoring is a major task in the field of civil engineering. especially massive structures like dam, powerhouses, aqueduct, sealing basins, weirs, etc. Non-destructive testing is the powerful tool for assessing the structural health. Due to aging or after the disasters such as earthquake of high magnitude near the dam may result the damages in the dam structures or any important structures. So for assessing the in situ quality of the structure, non-destructive testing CWPRS is well equipped and has inspect or measure doing harm, that is non-destructive. Non-destructive testing is used to detect honeycombing, voids, internal cracks, inhomogeneities, etc. of the civil structures. There are various techniques or methods for non-destructive testing. First is the visual inspection, rebound hammer test, ultrasonic pulse transmission technique, sonic transmission technique, impact echo test system, resonant frequency test system, and GPR, that is the ground penetrating radar. These are the various NDT technique for evaluating the in situ quality of the structure. So I will explain briefly the other 6 methods, and detailed I will explain the sonic transmission technique. In visual inspection is also very important. Most basic and common inspection method tools include fiberscope, boroscope, magnifying glasses, or mirror. In this technique, which technique is we want to use, that a rebound hammer or UPV or sonic or a GPR, which technique we want to use, we can decide by visual inspection. So this is also main important technique, that is visual inspection. Second is the rebound hammer test, and the method is elaborated in IS code 13311 part 2. In that there is a plunger. This is the one concrete beam, and we are pressing this plunger, and the plunger there is a spring and a rebound back, and that number is appear in this screen. That number is the rebound number. If that rebound number is above 40, then the quality of concrete is good to very good layer. Or if that rebound number is 30 to 40, that layer is good layer. If rebound number is 20 to 30, layer is fair. If that rebound number is less than 20, that is the concrete, poor concrete. And if 0, that is delaminated. But it has some limitations. So some people tell that this is directly correlated to the compressive strength. But I will say that this is give the rough idea about the compressive strength, and it gives the hardness of the structure, that civil structures. Then second method is the ultrasonic pulse UPV, ultrasonic testing of the civil structures. In that we are using the Pandit equipment, that is the portable ultrasonic non-destructive digital indicating tester, And in that there are transmitter and receiver. The CWPRS having so many sensors, that is ultrasonic, in the range of ultrasonic frequency, that 20 kilohertz to 200 kilohertz. And this is the photograph. We are transmitting the signal of ultrasonic frequency. This is the 54 kilohertz frequency transmitter, and it transmit to the one side and receive to the other side, and the time taken from the transmitter to receiver is given in this Pandit equipment. And if we know the time, it gives the time in microsecond. If we measure the distance between this transmitter and receiver, and we will get the time taken from that, we can find out the velocity. And there is a velocity criteria. In IS code also given the velocity criteria. If the velocity is above 4.5 kilometer per second, then the concrete is excellent. If the velocity is in the range of 3.5 to 4.5 kilometer per second, then the concrete is the good quality. And if the velocity is in the range of 3 to 3.5 kilometer per second, the quality of that concrete is good. If the velocity is less than 3 kilometer per second, that concrete is doubtful. This is given in the IS code, but CWPRS have developed own code by various grading. If there is a M20 grade, M30 grade, like that, we CWPRS have developed own codes. And this is a very important method for detecting the anomalies or in situ quality of civil structures, but it has the limitations. So it has it goes up to only 5 meter. In impact, we have the another equipment also, impact equator system. In that Pandit, that UPV will get only the anomalies. If some there is some weak zones, we can find out with the help of the Pandit equipment or UPV technique. But impact equator system can detect the where is the anomalies, what is the size of the anomaly. It gives the with the help of this impact ecosystem, and this that technique is given in ASTM C 13883. Then another technique is the resonant frequency test. In that we brought the course from the dam sites or any project sites, and we test that course and gives the engineering properties, such engineering properties like Young's modulus of velocity, modulus of rigidity, and Poisson's ratio. And this procedure has been given in ASTM standard C 21502. And this is the setup. While there is a vibrator, and another side is the accelerometer, and we vibrate the we give the frequency from 1 hertz to 200 kilohertz. At a particular frequency, it resonant, and it gives the Lissajous figure, and that frequency, that is the resonant frequency in a longitudinal mode. If this placed in a longitudinal direction, that it gives the longitudinal frequency, that the resonant frequency in longitudinal mode. And if we place this in a torsional mode, accelerometer and the vibrator in a torsional mode gives the longitudinal frequency, that is the torsional resonant frequency in a torsional mode. If we'll get this n dash, that is the longitudinal frequency in a longitudinal mode, that a resonant frequency in longitudinal mode, and n double dash is the torsional resonant frequency in torsional mode. If we'll get this and measure the diameter, give the values of diameter and length, then we will get the Young's modulus of velocity and modulus of rigidity. And if we will get these two, we can find out the Poisson's ratio. So this is the this is also one important technique for non-destructive testing. Another we have taken this ground penetrating radar. With the help of this ground penetrating radar also, we can find out the anomalies. If in a dam, if there is some anomalies, some voids are there, we can find out with the help of this ground penetrating radar also. And if in concrete portion also, we can detect the corrosion. If there is a corrosion, we can detect with the help of this GPR also. This is this system also available in CWPRS. Now the technique that is the sonic pulse transmission technique. This is the very important technique for assessing the in situ quality of the dams. Massive structures, other technique have some limitations, but the ultrasonic pulse transmission technique method is suitable for homogeneous concrete structures up to 5 meters of thickness. Beyond this thickness, the ultrasonic signal attenuate, and this method does not give reliable results. Big structures, concrete structures and masonry structures like a dam, canal, and weir are tested by sonic pulse transmission technique. Frequency of a sonic pulse is about 20 hertz to 20 kilohertz. The sonic waves in the frequency range of about 500 to 1000 hertz can be generated by mild impact of a hammer on the surface of the structure to be tested. Elastic waves developed, which includes longitudinal, transverse, and surface waves. Among the various types of elastic waves, P waves travels the fastest. By detecting the arrival of P waves and measuring the travel times along different paths through the material, the wave velocities along the travel paths are estimated. These are the equipments available in CWPRS. This is the 12-channel signal transmission seismograph, and this is the latest equipment we have purchased, that is the 24-channel signal enhancement seismograph. In that, these are the geophones or geophones. In if we want to test this dam, so we this is the hammer point. We are hammering the 5 kg hammer on the upstream side, and we are placing these geophones from downstream side. 24 places we are placing these geophones, and if we hammer this and we generate the signal, it passes through the dam body, and that recorded in the instrument, that is 24-channel signal enhancement seismograph, and we can find out the time taken from the
Vijay, I think you can skip all this.
Okay, sir.
And
Okay, sir.
come to the critical points you want to make on this paper, please.
Oh, okay, sir. Okay, sir. And the criteria, the masonry, we have the criteria. Masonry portion, we have the this criteria. If velocity is less than 2 kilometers per second, then that is the poor quality. Earthen portion, if the velocity is 0.2 kilometers per second, then the that earthen portion is questionable to poor. And in this using this technique, we have tested this Tulsi Dam in Maharashtra, in Mumbai, that 150 years back, commissioned 150 years back. And in this portion, this is the upstream side and this is the downstream side. We hammer the hammers to the downstream side, and upstream side we hammer, and we places the geophones on the downstream sides at 24 locations. And we have observed the time taken from the that hammer shot to the hammer shot to the geophones, and we find out the velocities, and that velocities are in the range of 3.32 kilometer per second to 4.31 kilometer per second, and the average value is 3.95 95 kilometer per second. Already I have explained that if the structure is masonry, then the velocity, if velocity is greater than 3, that quality of that structure is very good quality. So the quality of this Tulsi Dam is in a very good quality. Only we have tested some places, so that portion is in good condition, that is good to very good quality. Then another we have earthen portion also there, and we have tested with the help of that sonic wave transmission technique. We place transmitter and hammer, and we places that geophones on this side, and we will get the we get the value velocity in the range of 0.2 kilometer to 0.36 kilometer per second, and the average P velocity is 0.27 kilometer. That also the quality of that earthen portion is also in good quality. Then we have tested in masonry portion of Powai Dam. In that also we places that sensors in this way and hammer to the upstream side, and we will get the values of velocity, that is P wave velocity, in the range of 2 kilometer per second to the 3.4 kilometer per second, and it indicates that the masonry portion of that Powai Dam is in a good to very good quality. Then we have tested in Vihar Dam also. In that also that portion is earthen portion, and the velocity came in the range of 0.64 kilometer to 1.17 kilometer per second. It indicates that the quality of the earthen portion of Vihar Dam is also in good condition. So another Vihar portion we have tested, and the P wave velocity come into 0.2 to 0.29 kilometer per second. It indicates that the velocity, that quality of in situ of earthen portion is good to very good portion. So the velocities we have tested these the 3 dams in non-destructive testing, that way, that in with the help of sonic wave transmission technique, and non-destructive testing by sonic wave transmission technique is very useful and cost effective method for assessing in situ quality of material in several types of structures, such like dams, aqueduct, wells, etc., towards assessment of structural stability. The technique has been successfully applied for assessing in situ quality of 3 dams, Tulsi, Bihar, and Powai Dam. Thank you, sir.
Thank you, Dr. Vijay, for your very, very informative presentation on the non-destructive testing.
Yes, sir.
And this goes without saying that this is a very important dimension of the dam safety program. And I think all the dam owners, they are following this program of, assessing the health of the dams or the structures, other structures, hydraulic structures, with the help of this non-destructive testing. And you have very rightly pointed out that, particularly wherever, these tests are done, once the results are there and you feel really confident and satisfied that the structure is safe. So for the safety aspect, this is one quick and, without any restriction, this is one very effective mechanism available to us, and CSMRS has really done a good job in this. Thank you very much, Dr. Vijay, for this. We can now go to the next very, very relevant presentation, for which I would invite Mr. Daniel Johnson, if he's online. This is risk management for dam rehabilitation projects. So this is a very, very relevant presentation compared to, considering the current activities which are going on in the rehabilitation of the existing projects, existing dams. So Mr. Daniel, if you are available online, can you please start the presentation? And please limit yourself in 15 minutes time. Mr. Daniel?
And good day. Today I want to talk about risk management for dam rehabilitation.
Mr. Daniel Johnson, are you
First,
online?
I want to acknowledge my 2 co-authors. One is Dave
I think
Paul,
your mic is mute. If you can unmute yourself and then...
And the second is Terry.
Yeah, we can hear you now. Yeah.
Terry Arnold, who is also with me.
Yeah.
As we know, rehabilitation of dam projects involves risks. There are several different categories and kinds of risks. Just in looking at 3 is the design risks, that there can be inadequate information available to the designers. Typically, there's a shortage of budget because everything is a little bit tight on rehabilitation projects. One thing that I stress is to look early on at a failure modes analysis to get some sense of what could go. record drawings may not exist or may be inaccurate. And then something that's come into play in the last decade or so is that there are impacts that are outside of the engineering aspect from environmental and social groups. During construction, there's a lot of risk, of course. In bidding, nothing more than the idea that during bidding, there may be some bidding changes that occur or bidding climate that's different. Labor may and may not be available readily, depending on how busy things are. Accessibility is important, how to get to the site and what the site conditions are. And of course, with regard to weather and price changes and claims can come along to affect it as well. Also, though, in rehabilitation, you need to look seriously at the risk associated with operation. And that gets into the design of what the rehabilitation is. I really think that a good approach is total design and construction, a process that includes that process from the beginning to the end of the project and actually the operation. It integrates the design and construction teams from the very beginning. And I suggest during the feasibility stage of the project to get those parties involved. Even the construction team, there won't be a contractor necessarily on project team, but there would be construction experienced personnel within the design firm or within the owner's operation that could participate in this risk assessment process. That way, all the parties come together and are on the same page from the beginning. Also, to implement a formal risk management process. And we'll go through the detail of that's going to be here in a little bit. And my interest is, or my recommendation is to initiate this at the beginning of the project, like I said, and continue it all the way through the design, construction, and actually commissioning. One thing that we get involved with on these projects is surprises. And I'm going to talk about the technical parts, the geologic and hydrologic surprises that can exist on these projects. The one on the left is settlement of underlying materials that weren't anticipated during design and rehabilitation. The middle one is a geologic condition that existed and created a problem in the left above it in this new dam. And of course, on the right is a diversion dam, a coffer dam, that was overtopped during construction, with the construction in the foreground there being flooded during the project. So risk management can be categorized into 4 different levels, different stages. First is risk identification and categorization. Identify what those risks are. The second is to perform a risk analysis of each of those identified risks. Third then is to develop mitigation for those analyses, and there's several different ways to approach mitigation. And then fourth, and it's important, is to continue monitoring that risk from its first identification until it's been resolved or all the issues have been implemented. In risk identification, I suggest that it be a formal process. As I mentioned earlier, the design construction team start at the pre-feasibility or feasibility stage and follow all the way through the end of construction and into operation. Now, the personnel involved in those risk meetings may change with time depending on what's needed in those particular work sessions. Those work sessions are updated on a regular basis throughout the design and construction. And they can be done either as a regularly scheduled workshop established in the project schedule, or at particular times when certain things are completed, like at 30% design or 60% design or something, or start of construction, middle construction, that sort of thing. But anyway, they should be regularly scheduled so that they do occur throughout the process of the project. The information that's used in these workshops, I'm going to call them workshops, is current. All we have are the current project information and having lessons learned from past projects being brought forward. As these workshops proceed through the project, the current project information, of course, will change. And lessons maybe from other projects will change too with different participants in the meetings. And it's very important to document this information. Develop a risk register so that it's documented, and it's a working product that follows through the whole project. You never completely delete anything, but you can accept that you've solved some risk, but you always keep those on the table. There are many different types of risks considered. Here's just 3 categories that I've listed. One is technical. This is kind of what we're used to, is the hydrologic, or the floods or not. Seismic, we could in seismic areas have a earthquake during the reconstruction. Geology are always conditions that we need to be well understood. And then, as I mentioned, site conditions. We may not have good information about what is an existing structure, what the foundations are like, or those types of things that are important to understand. And then design errors and omissions. We have to be careful to understand those risks. And one thing I found in my nearly 50 years of dam engineering work is that the advent of computers has done a couple of things. One, it's made it much simpler to really do detailed evaluations of systems. Second thing, though, it takes the designer or the engineer a little bit away from the practical side of the project and the field itself. So we have to be careful that we don't let design errors and omissions slip in. And of course, one of the biggest aspects is weather, and looking at how we're going to manage the construction around the weather conditions that do exist. There are contracting and construction risks. The bidding period, as I mentioned earlier, is during bidding, there can be conditions that will affect the pricing of the bidding. A couple is that what other projects of a similar type are being bid that may impact the ability of contractors to be interested in this project. Pricing variability of all sorts of things vary: fuel, labor, materials, that sort of thing. And in some cases, we can end up with shortages of material and labor. And so that's one thing to consider in looking at construction risks. Of course, then there's going to be changes that are requested maybe by the contractor to go through something, or the owner. So understanding what those could be upfront is important. And then site conditions and unknown conditions that could exist out there that will be found. It's not necessarily that you're going to understand what those are during these risk management workshops, but to acknowledge that those exist and have some conditions in the documents and designs and budgets and schedules to acknowledge that they exist and can account for those. Safety has become a very large issue on all of our projects these days. And so understanding construction means and methods, and then operation means and methods too, will come into how the project is designed. And of course, then having an inaccurate schedule. I find that it's really important to work on a schedule, a detailed schedule, very completely, particularly in areas where we have significant seasonal changes in weather. There are other risks as well. There is team member turnover. And as I mentioned earlier, there can be environmental and society requirements that exist. The regulatory agencies are getting much stronger everywhere. In the US, we've got state dam safety components now that get much more involved in the evaluation and construction of rehabilitation projects. Site access can be an issue that affects things, and that's something important to look at. Some projects, the site access is quite challenging and can affect the risks associated with the project. And then, of course, site security, making sure that the site is safe. As I mentioned, a document is very important to make sure that everything is identified early in the project and then can follow through all the way on the completion project. And just topics that are important in this risk register, basically identify what the risk is, provide a description of the risk, and that's detail of what's important. And actually, during this identification and risk description, it's basically a brainstorming session with the participants in the workshop. And those brainstorming ideas will change whether the project's in feasibility stage, 30% design, 60% design, or start of construction. So having that session where people are allowed to speak freely and brainstorm about what risks could exist is important. Then estimate the likelihood occurrence that the risk might exist. And that can just be a simple categorization like low, moderate, or high. And then the consequence or the impact of the risk should it occur. And again, that can be categorized as low, moderate, or high. One thing that's important is to assign some party responsible for that risk, whether it's the owner, the contractor, the engineer, or possibly even the regulatory agency. But some party that's responsible for the risk so they can be held accountable to make sure that the risk is mitigated. And then a timeline. Everything's on a timeline, so that's important to put in there too. And then a good description, and these are just, again, brainstorm ideas to start with, of what possible mitigation actions are on the table. And then if it's important is to look at what magnitude of cost could exist should that risk occur. Here's just an example of a risk register that the Bureau of Reclamation in the United States put together for a dam project, dam rehabilitation project. If you note, they used color-coded levels of importance from red, yellow, blue, green, and black. And that just in their nomenclature helps them quickly identify what these risks are and how important they are. One thing I find is these risk registers can get quite long in going through a design process. And so all these information is put in place. Some of these may be solved during it and can be closed, but they always stay on there to make sure that everybody's aware of that. So these can get quite long. So putting in some method to identify conditions is helpful. So there are basically 4 different ways to mitigate risk. One is to avoid it. And one of the reasons to start these processes early is that in feasibility stage, it's pretty easy to change the scope of the design. And it's easy also to look at construction procedures and what might be necessary. So it's very helpful to do that. And then secondly is to mitigate, to modify the design or construction procedures. And so that's one thing going through is to look at what can be done to mitigate the risk. And it may not completely eliminate it, but it could reduce the risk to a tolerable level. So that would be mitigation. The third is to transfer. And I mentioned before about transferring the risk to another party. And this could get into societal issues, environmental issues, and some other aspects of that, or to the contractor and let the contractor resolve those risks. And the fourth is just accept the risk. And some of these risks that we can't mitigate, we have to live with through the design and construction and operation period. But understanding that the risks exist is much better than not knowing that the risks exist. So there's a real benefit to looking at the risk process to actually understand the likely risks that could occur, and at least acknowledge that they exist, whether or not it can be mitigated. So in closing, what I find is that dam rehabilitation involves a lot of risk. I mean, uncertainties all the way through to operations. The risk can impact the scope and schedule and budget of a project. And so all 3 of those could be very much impacted by these risks. It's important for everybody, the owners, engineers, and contractors to understand and communicate as they go through the design and construction process what these risks are and what risks are. And what I find too in having a formalized workshop process for risk assessment allows us to understand and anticipate these risks so that they can be looked out for during the project and during construction. So that to me is a very important aspect of this. And then management of risk can be implemented and really understand the surprises and then what might come from those surprises and going through to make sure that it's a successful project. Anyway, so that's my summary on having risk. I thank you for the opportunity to present this today and wish you a good day.
Hello, Rajesh sir. Hello. Hello, Rajesh sir. Sir, I will present your presentation.
Yeah, please run it.
Premar Bhajantri presenting the paper on optimal design of energy dissipation arrangement for overflow, orifice, and tunnel spillway using hydraulic modeling. The dissipation of kinetic energy at the toe of spillway is essential to avoid damage to the dam and its adjoining structures and uncontrolled erosion of river bed and banks downstream of dam. The main factors that govern the choice of energy dissipation are hydraulic considerations such as tailwater levels and discharge intensity, topography and geology, type and purpose of the dam, layout of other associated structures, economic comparison, frequency of usage, and environmental considerations. Hydraulic characteristics of overflow, orifice, and tunnel spillways are entirely different. Hence, the design of energy dissipator is site-specific and may vary from project to project. The most common type of spillways are overflow spillways. These type of spillways are generally preferred on valleys where the width of the river is more to provide sufficient crest length. Stilling basin or bucket type of energy dissipators are used for energy dissipation depending on the tailwater levels. The orifice spillways are generally used in Himalayan hydropower projects to pass flood as well as flushing of sediment from the reservoir. Ski jump bucket type of energy dissipators are used for passing the flood and flushing the sediment. In case of high tailwater level, stilling basin with cylindrical lenticels are used for easy removal of the sediment from the stilling basin. In case of ski jump bucket, preformed plunge pole is generally provided for energy dissipation of ski jump jet in order to avoid uncontrolled erosion of river bed and banks. Due to high discharge intensity of the order of 200 to 300 m³ per second, the design of energy dissipation arrangement becomes very complex and challenging to design engineers. The tunnel spillways are normally used at dam sites in narrow canyons with steep abutments or at sites where there is a danger to open channel flam, landslides, or snow. The flow at the outlet end of the tunnel is always a free surface flow. Hence, generally, flip buckets are used for energy dissipation as the tailwater level is much below the exit portal of the tunnel spillway. For most of the cases, exit of tunnel portal, there will be a transition followed by a flip bucket. But however, USBR has developed a combined transition and flip bucket together, thus reducing the distance between ski jump bucket and river downstream. Sometimes the tailwater conditions at the exit portal are such that hydraulic jump may form for lower discharges. Yet the tailwater depths corresponding to higher discharges are inadequate for the formation of hydraulic jump. In such cases, dissipator in the form of combination of stilling basin and flip bucket would be suitable, that is stilling basin for lower discharges and flip bucket for higher discharges. Sometimes special type of stilling basin in the form of two-stage energy dissipators by providing a weir-like structure to be provided for energy dissipation. Omkareshwar Runoff River Hydropower Project is situated on river Narmada, downstream of Indira Sagar Storage Dam and just upstream of Omkareshwar Temple. The project has concrete gravity dam of height 64 meter and 949 meter long. It has 23 spans of spillways. The overall length of the Ogi spillway is 570 meter. To pass the design outflow flood of 88,315 cubics of discharge. The original design of spillway had slotted roller bucket as energy dissipator. Extensive model studies were carried out at Seidel Paris on sectional model and 3D comprehensive model to finalize the design and layout of spillway and energy dissipator. This is the original general layout of the spillway with the powerhouse complex on the right bank. And this is the cross section of spillway with the slotted roller bucket as energy dissipator. The studies conducted for the original design with the slotted roller bucket indicated that no roller action was taking place for any of the discharges. And also it was observed that downstream face of the teeth was subjected to large negative pressures, indicating possibility of cavitation damages. For small discharges, the bucket was behaving like a ski jump bucket, indicating the sweeping out of the jump. And for larger discharges, hydraulic jump was forming in the roller bucket. Due to high discharge intensity and incoming velocity of the order of 25 to 28 meters per second, improvement in performance of slotted roller bucket could not be achieved by modifying various parameters of the bucket. Hence, design was modified into stilling basin type energy dissipator, and further studies were carried out. As per the tailwater rating curve, 2 levels of stilling basin apron levels were considered at AL 158 and 156. Initially, stilling basin with 70 meter length and apron at AL 158 meter was tested with various appurtenant structures. Stilling basin with dentated NCL and without chute blocks, stilling basin with dentated NCL with chute blocks and 5 meter high baffle blocks, stilling basin with upstream sloping solid NCL without chute and baffle blocks were tested. None of the above alternatives performed satisfactorily due to high discharge intensity. Hence, the studies were carried out by lowering the sealing basin floor level by 2 meters, that is at 156 meter EL. With that, it was observed that the performance of stilling basin was satisfactory up to 60% of the maximum outflow flood. And also the hydraulic jump was contained within the stilling basin, and jump was not sweeping out of stilling basin for lower discharges also. After finalizing the design from section model, the design was reproduced in the 3D comprehensive model for assessing the general flow conditions. The provision of divide walls to separate the stilling basin in number of days helps in reducing the extent of return eddies formed in the stilling basin due to closure of adjoining spans. This is especially important in spillway like Omkareshwar, having large number of spans. The divide walls reduce the extent of return eddies, thereby minimizing the tendency of deposition of material into stilling basin and consequent damage due to abrasion. Segregation of stilling basin into a number of bays also facilitates easy and quick inspection or repair by restricting the zone of the dewatering. Hence, it was recommended to provide 4 divide walls dividing the stilling basin into 5 bays. And also left and right training walls were extended up to the end of the apron. Hydraulic model studies were conducted for the entire range of discharges for observing the performance of stilling basin and divide walls. It was considered that bay number 1 could be kept closed for smaller discharges up to about 10,000 cubics, which will occur frequently. Various conditions have been summarized in the table. The spillway is being operated as per the schedule of gate operation provided by Seidel Paris. It is like this: bay number 3 is operated all the time, and as the discharge increases, bay number 4 will also be operated. And if further increase in the discharge, bay number 2, 3, and 4, and then further increase up to 30,000. So all the first to fourth bays will be operated. In the extreme condition, when the flood increases beyond 30,000, bay number 5, which is adjoining the powerhouse complex, will be operated. The next case study is for Orify spillway for RAHE project in Arunachal Pradesh. This project is situated on Pare River. The dam consists of 78-meter high concrete gravity dam with breastwall spillway of 3 radial gates of 10.4 meter by 14 meter to pass the design PMF of 5,000 cubics of discharge. Spillway has schism bucket for energy dissipation. The studies were carried out on 1:60 scale 3D comprehensive model. As the tailwater was higher than the lip level, no clear ski jump action was observed for any of the discharges. And also it was observed that flow in the downstream breach beyond the point of impingement of the jet, the flow remained supercritical with high velocity of the order of 20 meters per second, pushing the tailwater up to 400 meters downstream of dam axis. The flow conditions in the river further downstream were violent. And also it was felt that to avoid such supercritical high flows downstream of spillway, the schism set should have a preformed plunge pool for proper energy dissipation. As the original design was not performing satisfactorily, it was decided to modify the breastwall bottom profile and spillway bottom profile to improve the coefficient of discharge and to raise the bucket lip level beyond the tailwater level and decrease the lip angle. And also it was suggested to have the preformed plunge pool. Hence the design was modified. This is the modified cross section of the spillway where the breastwall profile and bottom profile of the spillway was modified to improve the coefficient of discharge, and lip angle was reduced to 35 degrees and lip level was raised by 3 meters, and preformed plunge pool was proposed, which needs to be confirmed on the model studies by conducting scour studies. This is the layout of modified spillway where 2 divide walls were introduced to improve the function of spillway and flow condition downstream. The scour studies were conducted to finalize the design of preformed plunge pool. It was decided to have 18-degree downstream slope and 2-degree upstream slope. With the modified design, the performance of ski jump bucket was satisfactory for entire range of discharges. Also, flow in the river downstream of plunge pool area remained subcritical with reduced velocities from 25 meter to 7 meter. The third case study is the tunnel spillway of Parbati HE project in Himachal Pradesh. It is a runoff river project with an installed capacity of 520 megawatt on river Sainj, which is a tributary of Parbati. The project consists of Rockfield Dam and 2 spans of 4-5 type spillway. This is the intake structure on the left bank. 2 6.75 dia horseshoe-shaped diversion tunnels have been converted to additional spillway for passing the floods. Both the tunnels are having varying lengths of 440 meter and 480 meter with a ski jump bucket for energy dissipator as per the initial design. This shows the details of ski jump bucket energy dissipator in plan and section having 30-degree lip angle. Studies were conducted on 1:50 scale 3D comprehensive model. This is the upstream view of the model showing the intakes of left and right tunnel spillways, Rockfield Dam. This is the 4-5 spillway to 2 spans and intake structure. This is the downstream view of the model showing the outlets of both the tunnels and 4-5 spillway. The studies conducted with ski jump bucket indicated that the bucket was not able to lift the thick jets and the flow was just cascading over the bucket and entering into the river and riding along the left bank with velocity of 20 meters per second. Hence, it was apprehended that it may cause heavy cover and erosion of the left bank. Hence, it is decided to adopt sealing basin for further investigation. 3 alternatives of sealing basin were studied on the model. Alternative 1 was consisting of 28-meter long sealing basin with 2 rows of 3-meter high baffle blocks and 5-meter high and straight end seal parallel to the tunnel outlet. These are the details in plan and section. This is the downstream view of the model, and the studies indicated that this alternative one was not effective in dissipating the energy, as 19 meter per second velocities were observed along the end seal. Then alternative 2 with 28 meter long sealing basin with 3 rows of backflow blocks and oblique end seal parallel to the right bank were studied. These are the details of the alternative 2 in plan and section. This is the downstreaming of the model, and it was found that alternative 2 was more effective in dissipating the energy, as velocities of the order of 8 meter per second were observed along the end seal. Further studies were conducted with alternative 3. This was consisting of 22 meter long sealing basin with 3 rows of backflow blocks and oblique end seal parallel to the right bank. These are the details in plan and section. This is the downstream of the model. Studies conducted with this alternative indicated that the velocities were reduced to 12 meter per second along the end seals. However, though the velocities were higher compared to the alternative 2, because of limitation at site to provide alternative 2, it was recommended to provide sealing basin as per this alternative. All the 3 projects are completed and functioning smoothly. The role of hydraulic model studies was crucial in finalizing the design of Spillway and its supporting structure for all these 3 projects. The various alternatives were carried out to optimize the design of energy dissipators, and recommendations were given by several paras for overflow spillway of Omkareshwar project, Pare Verifies project, and Parbati 3 tunnel spillways using physical model studies. Thank you very much.
Okay, thank you, Dr. Valedictory, for presenting this study where you have tried to study the different scenarios and different alternatives and try to pick up the most optimized one. In fact, the hydraulic design is the most critical aspect of dam safety, and the more amount of efforts you do at this stage, it really leads to a more efficient design on the prototype. So this is a really good thing, and you have done a good job. Thank you very much, Dr. Valedictory. Now can we go to the last presentation of this session, which is on the monitoring and instrumentation strategies for new and existing dams by Dr. Georgios Nouianis. So if Mr. George is there, I would request him to immediately please start the presentation, as we are already running short of time. Thank you.
Hello, can you hear me properly?
Yes, we can hear you. Please go ahead, Mr. George.
Okay. So my presentation is on the monitoring and instrumentation strategies for new and existing dams. And this is really a collection of snapshots on discussing on various aspects of monitoring strategies. Let's start with the principles of monitoring and instrumentation. Monitoring and instrumentation should focus on probable failure mechanisms, and probable failure mechanisms should be established, and ways of monitoring them should be defined as early as possible when you're designing a new dam. Instrumentation can always assist in providing early warnings. For new dams, a detailed report on instrumentation is needed as part of the design. We should never forget that. And also a draft surveillance and instrumentation manual covering construction, first filling, and operation should be prepared as early as possible, and then finalized near the end of construction and before the start of first impoundment. Beyond that, during the initial filling and operation, this is updated frequently, and some incidents might indicate that you need some additional instruments or modifications to your system. Let me make a distinction of the instruments vis-a-vis the area of measurement. The the instruments could be broadly classified as instruments that provide a point information when the measurement of a parameter represents only the local condition. For instance, a vibrating wire piezometer or an earth pressure cell installed in the core of a dam, of a bankment dam, is useful for investigating the behavior of the material during construction and later on during operation, control construction procedures, and then it provides spot checking. Only by chance, an instrument that provides only point information can give you an overall information on developing problems, because the problem might occur just 20 meters away from this instrument that it is undetected. Now, instruments that provide area information is when the measurement of a parameter represents not the behavior just of this point, but it gives you a picture of a broader area, as is the case of, let's say, seepage weir at the toe of a dam, or a column of magnetic settlement plates in a dam body, or a piezometer that is installed at the base of a chimney drain downstream that gives you an overall information, overall behavior of your dam. These instruments that provide area information are the most suitable for providing also early warning for developing problems. The instruments during the operation stage should monitor probable failure mechanisms, provide early warnings on the development of conditions that could jeopardize the safety of the dam, check the efficiency of critical components of the dam, such as upstream concrete decks, diaphragm walls, grout curtains, distressed anchors, etc. And the simplicity and clarity on the purpose of the installed instrument should be the aim of a good design system. The most important instruments that provide long-term monitoring are instruments that measure the seepage to the dam and its foundation. A well-designed system measuring seepage should be able to give you not just an overall picture, but also to help you to locate the area where this problem occurs. So a system of seepage measuring should consist of many different, let's say, points of measurement. And the second most important, again, instrument for long-term behavior is the measurement and monitoring of deformations, like surface monuments and targets that are easy to install, repair, and supplement if necessary. Now I'm moving to some cautionary tales, problems that are usually encountered in instrumentation. And I'm going to start with improperly sealed cable ditches. To carry the cables of electrical instruments through an embankment dam, you have to place them in a ditch that, if not properly sealed and not properly made watertight, it can give you erroneous results and even create some problems with the dam. A common condition in many earth dams, where the cables of instruments installed near the upstream face of the core are carried through ditches to the upstream filters and then rising towards the crest. And they often result in giving you false alarms. Here I'm giving you such an example where the instruments installed at the upper half of a core, with first impoundment, they measured practically reservoir pressure with very, very little delay. Now, if you compare them to the instruments that are installed on the center line and they are carried to the downstream filters, these instruments, by comparison, give you a much better picture, and much better picture of the behavior of the core, and their results are compatible with, let's say, flow nets developing through the core. Another case that has given many false alarms is inadequately sealed stud pipes. Is the most simple of the instruments, but if it's not properly sealed, surface rainwater can seep through and fill the pipe, giving false readings. This has resulted in a few false alarms in dams and reservoir landslides. Careful examination indicated that this was the problem, and the problem was fixed, and the alarm went away. Another very common problem is poor surveying of surface monuments. Simplified methods of triangularization give very poor results, and often they appear just as noise when plotted with time. So high precision is really required for when you want these instruments to be useful. Another very common case with things that go wrong are improperly installed inclinometer columns with settlement plates in dams, where not proper telescopic joints are used, and when they're not placed properly, I mean fully opened when they're placed, and when they're not vertical, very often this results in blocking these columns, and this makes them really useless, because after some time you just cannot lower your torpedo down, and it's lots of effort goes to waste. Another very common case of instruments that are really not useful is orphan accelerographs. That is, when dam operators lack the expertise required into caring for these instruments, accelerographs are soon not operational. So what it has been recommended, that actually it was applied in a couple of cases, was to employ an agency that specializes into monitoring and research of earthquakes to take care of your instruments, and this has been proved successful in many cases. Another common problem is cross-wiring of electrical instruments. When you have a large number of instruments, it is very often that you can cross-wire them, and you can get false alarms when this is undetected. In most cases, they appear as anomalous readings during construction and during first impoundment. Very often, this problem is solved. I mean, it is identified, and then you know that you should not worry about the readings after the first impoundment. But great caution is needed when you're dealing with lots and lots of electrical instruments to properly label them. I give you an example, a dam that was recently filled, where a piezometer installed at the downstream shell with first impoundment was showing very, very high pore water pressures. When this was compared with other instruments nearby, it was easily detected that this was really cross-wired, and this was really representing measurements of the piezometer in the core. Now, we are very often deal with old dams, and many of them were, let's say, not properly maintained for many, many years, and you are called to start and modernize them and put in a new instrumentation system. There, the same principles should be followed. That is, you have to define the most probable failure mechanisms, and then to design the necessary, let's say, instrumentation system. Known deficiencies and poor performance issues should be closely monitored, particularly when it is difficult to remedy these situations. In most moderately high dams, fitting seepage monitoring devices and surface monuments on the crest are the only required instruments. You don't have to go into very elaborate systems, but in high dams, or high-risk dams, a more elaborate system might be needed, including different types of instruments. And with a view to providing also some early warnings in case of failure mechanisms developing. Although it is very tempting to try and restore damaged instruments and reinstate initial instrumentation systems, this in most cases is unnecessary and also potentially hazardous because you might damage your dam by start drilling and start installing instruments when you don't really need them. The role of visual surveillance is very important in all cases and should be not overlooked. This goes hand in hand with instrument measurements. I'm going to present you three cases very briefly of dams that we were called to provide instrumentation systems. The first is a 60 meters high, 90 years old concrete gravity dam with no problems in its behavior, but it's a high hazard dam, and it is with no instruments, but just a few kilometers upstream of a moderate town, and an early warning system is badly needed in this case. So in this is one of the few cases where we designed an extensive system of seepage measuring points, surface deformation targets, and many electronic tilt meters and crack meters, and all this linked to an automated system that could provide early warning, because you only have 10 minutes to react in order to evacuate the downstream town. Now, another case is that was in Europe. This cases are from Africa. 40-year-old rockfill dam with asphalt concrete deck, where the instrumentation that was installed included surface monuments, observation wells, and seepage measuring points. All of them were in poor repair, but they could, most of them, they could be upgraded and made operational. So the proposal was to rehabilitate existing damaging seepage measuring devices, but no additional instruments to be installed in the dam. Now, a very interesting case is an old dam, 30 years old, not very old rather, dam, 30 years old only, rockfill dam, but 110 meters high, high hazard dam, where a very elaborate system of instrumentation was initially installed. Practically all the instruments that you can imagine were installed. But all of them were heavily damaged, vandalized. All vertical tubes were blocked, and cables were cut. So this is actually not finalized yet, but it's the idea here is to rehabilitate all the seepage measuring systems. That is very easy to do. Also rehabilitate, or rather provide new reading systems for electrical instruments, vibrating wire piezometers that are installed in the dam, that their cables were not cut, so they're tested, and new measuring devices were provided for this. And also the rehabilitation of all the surface monuments. In such a dam, trying to reinstall the initial instrumentation is really not necessary, since there is no problematic behavior in the dam, and you could cause more damage than good if you try to start drilling to install new instruments. So by this, I conclude my presentation, and I thank you.
Okay, thank you, Mr. George, for this informative presentation on this issue of monitoring and instrumentation strategies. In fact, yeah, this is certainly extremely important aspect as to how your structure is behaving and the kind of health your structure is possessing. So this is an extremely important aspect, and unless you know the health related issues of your structures, it's very difficult to take any restoration plan also. So the kind of strategies you have just presented, yeah, these are very, very informative, and people who are connected with this conference, they have taken, they will take benefit out of your suggestions and recommendations. Thank you very much, Mr. George. Thank you so much. And with this, I think we have come to the end of this particular session, which has been really very, very beneficial in the sense, because the dam safety is a very pertinent issue in the today's scenario, and every country is now taking it very, very seriously. And in this Icold symposium, this still remains the key and the core issue which is being discussed. In the inaugural session also, all of us know, when we got connected with the inaugural session, I was physically present there. Everybody laid emphasis on the dam safety related issues, because whatever we have built, at least we must try to retain that. We must try to preserve whatever we have built. Of course, constructing new dams and new hydro plants, they have their own norms which need to be followed before the construction starts. But then the existing dams which we have already built, we must preserve. We must look at the safety of these structures in the larger interest of the society, the people, of the area. So I'm thankful to all the presenters who involve Mr. Sunil Pillai, who spoke on the concrete designs for the thermal stresses. And then we had Mr. Vijay Gokhale, who was very nice in telling us the non-destructive tests which can be conducted on the structures to know the health. Similarly, then we had Mr. Daniel, who told us about various risks which may occur during the dam rehabilitation projects, and how we can mitigate those risks. We also had Dr. M.R. Vajantari, who very ably told us how he modeled the energy dissipation arrangements for a few dams, and then tried to pick the most optimum design of the energy dissipation arrangement. Then finally, Dr. George, who really very ably told us about the instrumentation thing. Thank you all the presenters, and with this I conclude this session on advances in dam safety, risk assessment and management. Over to the organizers, please. Thank you, everyone. Thank you.
Thank you, sir.
Thank you.
An exclusive session, and hence all are the invited speakers. So I'm giving first the introduction of each of the speakers, and then I shall invite in turn the speakers to kindly make their presentation. We have received actually pre-recorded presentations from the speakers, except one, considering some likelihood of the technical snakes. So first I'm introducing myself. I'm Vivek Kapadia, working as a secretary in the Water Resources Department. And right now I'm looking after a mega irrigation project called Sardar Sarovar project. I'm also a council member in the International Geosynthetics Society. And I invite all our speakers today, especially Mr. Kelvin, who is from South Africa. I'm introducing him first as he is going to be the first speaker today. He has done Bachelor's of Science in Civil Engineering from the University of the Witwatersrand in 1982. He's fortunate to be a third generation in his family to have commitment to extend their services to the larger public interest in the country of South Africa in the department responsible for water resource management. Right from 1910, his family is involved into this. So I congratulate him first of all. His experience includes the design and construction of bulk water resources project, and he is associated with dams and conveyance systems, augmented by materials and technology investigations pertaining to fluid flow through soil, filter systems, and geosynthetic materials. He was involved in the development of wastewater management and related regulations, and is responsible for review of their engineering design and construction implementation. Diverse responsibilities in dam engineering have included grave and archaeological rescue, agriculture and housing developments, as well as the provision of services. I would invite Mr. Kelvin from South Africa to kindly deliver his presentation.
Good day, Chairman, ladies and gentlemen. On behalf of the International Geosynthetics Society, I would like to thank Icold for the opportunity to address the use of geosynthetic materials in embankment dam rehabilitation. To appreciate the importance of dam engineering, let's consider the total water available on Earth. If we take all the moisture in the world, in the atmosphere, in the plants, animals, water in lakes and the sea, and put it all together into a single sphere, it would have a diameter of 1,380 kilometers. If, however, we then take the seawater out of that sphere, it would reduce in diameter to 273 kilometers. If we then remove the inaccessible water, the diameter of the sphere would reduce to a mere 56 kilometers. And that represents the volume of all the fresh water on Earth, which we as dam engineers are most interested in. Looking at renewable water and taking population distribution into consideration, and look at the parameter renewable water per person per annum, we'll appreciate that the freshwater resources of the world vary widely across the planet. So it is no wonder that economists predict that by the year 2040, the countries shaded in red will have used between 80% and 100% of their available water resources, with the countries shaded in orange or deep yellow following on not far behind. This emphasizes the importance of dam engineering in managing the water resources available to us in various regions. So how can geosynthetic materials help? Well, geosynthetic materials comprise of manufactured synthetic products that come in a range of forms. They may be impermeable geomembrane sheets that are welded together, or impervious geotextile sheets or combinations thereof, such as in geosynthetic clay liners or geodrains, and we get reinforcing grids known as geogrids, geopipes, and a host of other synthetic materials. While the earliest use of a geomembrane is ascribed to the Mission Dam in BC, Canada, where a PVC sheet was used in part of the dam to augment the clay layer sealing the foundations, the use of geomembranes in interbasin transfers in exposed condition is seen quite often in balancing dams and the like. More recently, as the appreciation of water conservation grows, we see agriculture and mining lining dams with geomembranes to reduce seepage losses. Even more recently, with greater emphasis on water conservation, balancing dams and reservoirs are being covered with solar panels or floating covers to reduce evaporation losses. But let's turn our attention to dam safety for a moment. And if we look at the Icold Bulletin on Dam Safety, we'll notice that in about 1950, there was a sudden drop in the number of dam failure incidents. This was ascribed largely to the use of granular filters for non-cohesive materials. A more recent analysis of the statistics shows that as of at about 2010, 44% of dam failures were ascribed to overtopping, with 34% of failures ascribed to piping, 20% to structural failure, and about 2% to other reasons. In embankment dams, you'll notice that irrespective of the height of the dam, the rate of failure was consistent, and it was consistent for the range of type of dams. But embankment dams that fail tend to fail upon first filling. And that's about 90% of those that do fail within the first year. So, putting this into perspective, you'll note that even concrete dams or masonry dams can fail in piping, seen by the boils developing in the downstream pool. Turning our attention to an embankment dam, which was constructed of dispersive clays, we noticed that the clay core suffered significant desiccation cracks of the core to below the full supply level. Grouting up of the chimney drain using cementitious materials revealed that the filter drain, the internal chimney, was directly connected to the downstream face through rodent holes and mole holes, which would place the embankment at a significant risk of failure on rapid filling. Furthermore, the failure of Zupnoch Dam upon first filling revealed that a window in the filter system can lead to a rapid piping failure. The forensic investigation into this dam failure did, however, show us that the composite, geotextile, and granular filter did perform very well, even during the mud rush of the failure mechanism itself. Poor compaction can lead to seepage at even elevated levels and associated piping requiring remediation. If we now look at the mechanisms at play in an embankment, to be able to address rehabilitation, we need to understand what the embankment is and how it functions at present. Apart from the spillway, looking at the internal systems, we consider essential filters being beneath the riprap to prevent upstream erosion, internal drainage systems associated with the chimney drain and blanket drain, as well as toe drainage systems. the rehabilitation addresses largely external systems. But looking at the internal systems, we must know that geosynthetic materials have been used for some time. The 17-meter high Valcross Dam is reported as the first large dam to use a geotextile as a filter beneath riprap. However, geotextiles have been used internally to augment filter systems, such as in blanket drains, in chimney drains, and geotextiles have been used downstream of the core in the trench to reduce the risk of losing core material into discontinuities or cracks in the downstream foundations. If we understand what the existing embankment is, this helps us understand how we can use geosynthetic materials to our advantage for cost-effective rehabilitation. This could be by augmenting external filters for erosion control and seepage control. This could be done by way of downstream pressure relief wells or interceptor channels. And we can reduce the risk of non-overspill crest overtopping by raising the embankment through small wall-like structures. Let's have a look and see how the geosynthetic materials have helped us. The 34-meter high Rietvlei Dam was constructed with a brick core in the 1930s and was found to have an inadequate spillway as well as inadequate stability. So apart from the downstream berm, the non-overspill crest was raised by nearly 3 meters using mechanically stabilized earth. You'll note the upstream wall face serves as a wave wall. Mechanically stabilized earth block on the top of the crest can be constructed using the conventional or formally patented reinforced earth or using geogrids, binding the upper and downstream walls together. Spillway chutes are a particular challenge because of the high velocities and the need to be sensitive to poor water pressures that can develop across liners. However, we can make use of geosynthetic materials in the drainage or diversion channels at positions where the flow is a low enough velocity or subcritical. And as seen here, geocells are used, they are being filled with erosion resistance materials such as either concrete or cement stabilized soil. And this is done to reduce erosion of the channel and in some cases to reduce seepage losses into the downstream foundation area. Other examples of geotextile use may be beneath riprap of the downstream stability berm or downstream toe of the dam, where the geotextile serves as an intermediate filter between the embankment dam and erosion-resistant riprap, and to assist in pressure relief downstream of stability berms or embankment dams, we can make use of geopipes or synthetic well screens, as is being seen with the installation of well screens at a particular dam. And they are purely to reduce the pressure in the foundation. An alternative to well screens is the use of cut-off drainage trenches, where again a geotextile filter is used and the drainage media can be granular or a geosynthetic drainage layer. However, it's not only the embankment dam itself that needs rehabilitation. In some cases, it's the conveyance system, be it the river or canal, that requires rehabilitation as well. In the case of the Lesotho River, the increased sediment deposition of the river, which formed an international boundary, led to the river in the next flood breaching the right-hand bank and scouring a Ramsar wetland site. You'll note also with the levees, significant volumes of water are retained outside of the river system to the detriment of potential use. Modeling of a solution using geosynthetic bags was undertaken so that we could divert the majority of flow back down the river channel while simultaneously making provision for wetland recharge during elevated flows. This is seen in practice where the geosynthetic bags formed the abutments and main wall, with smaller bags being used to line the top end or spillway component of the right bank rehabilitation. This worked very well as predicted in the 2015 floods. It is not only the river channel that sometimes needs rehabilitation. We should note that conveyance canals can also be rehabilitated using geomembranes, even when the canal is in service, needs to remain in service. We've used divers to reline concrete-lined canals where the concrete had failed, particularly at joints. So too, dam rehabilitation may require access roads to be reinstated and rehabilitated. And side drains can be installed rapidly using geotextile filters with geosynthetic spaces such as nets or pools and geopipes for drainage. Similarly, rehabilitation projects may require the establishment of labor camps or facilities with associated wastewater treatment works. The rapid deployment of wastewater treatment works is possible using geomembranes for the containment and geogrids to reinforce the stone layer works of an aerobic wastewater treatment works. However, perhaps the most common observed use of geosynthetics is in erosion protection through mechanisms such as silt fences. In this particular case, erosion protection is being provided by a geocell being filled with erosion-resistant stone. Ladies and gentlemen, it is our belief that geotextiles can and should be used as adjuncts to internal filter systems, in particular where the granular filter is susceptible to embrittlement and cracking due to changing water quality with time as water availability reduces. Similarly, it is our belief that a wide range of geosynthetic materials, and in particular geomembranes, geotextiles, geocells, and geopipes, can be used appropriately with appropriate technology for the rehabilitation of dams. I would like to encourage members of Icold to visit the International Geosynthetics Society website for further information on geosynthetic materials and their applications, particularly in dam engineering, as well as visit the website of the Geosynthetics Institute in the USA for access to standard specifications and guidance documents as well. I thank you for your attention and wish you the very best with rehabilitation. Thank you, ladies and gentlemen.
Thank you so much, Mr. Kelvin. We are extremely grateful to have heard from you in the form of your wide experience. And now I am introducing the next speaker, who is Mr. Alberto Squero. He is Managing Director of CARPI at present. He graduated in hydraulic engineering and obtained his professional engineer license at Turin Polytechnic, Italy in 1973. From 1969 to 1985, he worked for major civil engineering construction companies in Europe and Africa, specializing in construction of roads and bridges. In 1986, he joined CARPI, a private group that provides design, supply, and installation of waterproofing geomembranes on hydraulic and civil structures. He has been responsible for design, supply, and construction of waterproofing systems on more than 200 hydraulic structures, including more than 130 dams. He is now managing director of Carpi Group. He was the chairman of the Icold European Working Group, who prepared Icold Bulletin 135 on geomembrane sealing systems for dams, and Italian representative at the European Committee for Standards for Geomembranes in Hydraulic Structures. Now I invite Mr. Alberto to kindly make his presentation. Just one important announcement: all the participants are requested to kindly place their questions in the chat box so that at the end of the session we can address all the questions. Thank you so much. And over to Mr. Alberto, please.
Mr. Director, I have
Yes.
a recorded presentation,
Thank
so
you
you
so
can
much.
start from your end.
I'm so grateful. Thank you so much. We are doing so.
Thank you.
Afternoon. My name is Alberto Spuero, and I'm going to present the use of geosynthetic material for dam repair and rehabilitation.
I think there is a problem with the video. Mr. Video, the video is not running.
Yes, I'm trying to fix the problem.
Thank you.
Geosynthetics cover several functions: fluid barrier, drainage, reinforcement, support erosion control, filtration, separation, protection. Geosynthetics water barriers are geomembranes, one layer watertight. Depending on the base material, they can be very flexible, like PVC shown on the left, or stiffer, like HDPE shown on the right.
The video is not running as expected.
Another type of geosynthetic water barrier is a Sibera mat. It's a mattress composed by two geomembranes. After placement, cement grout is injected between the two. The lower geomembrane provides water tightness, the upper one grout containment. Geomembranes in the field are not a new solution. Geomembranes have been used in large dams since 62 years. It is estimated that there are more than 350 large dam installations worldwide.
It is coming intermittently.
This keynote lecture focuses on rehabilitation. Icold has dedicated 3 bulletins to the use of geomembranes in dams. The first one in 1981, Bulletin 38, use of thinner membranes in field dams. It's recommended that the cover layer is mandatory and the maximum height of the dam should be 30 meters. What a pity, a huge work. It is not.
I'm sorry why it is troubling. Could our operators please fix the problem?
The Icold Bulletin 135 was prepared by a group which was formed by owners, government agencies, universities, designers, having extensive experience of geomembranes in dams, and coming from 11 countries. The evidence shall be proven by completion certificate issued by the owners of those dams. One of the critical aspects for a durable geomembrane system is the selection of the geomembrane line, which must be flexible. The more it adapts to the substrate, the more the load exerted by water is distributed, thus reducing risk of damage due to concentrated loads, resistant to puncture at protrusion in the substrate, and burst at cavities in the substrate when waterhead is applied, and shall be resistant to tear propagation in case of accident, especially in water conveyance structures, and resistance to impact by floating debris, ice, boats. The new Icold Bulletin include also a research by the U.S. Army Corps of Engineers regarding the evaluation of membrane material for underwater installation. The Sibylon PVC geocomposite reinforced with geotextile got the highest score, while HDP geomembranes got the lowest score. Sibylon PVC reinforced geocomposite and PVC geomembranes have been used in most state-of-the-art geomembrane projects in rehabilitation of dams. Up to date, more than 170 large dams have been waterproofed, 42 large reservoirs, 41 canals, 20 hydraulic tunnels, and 2 very high-pressure shafts. Design principle for rehabilitation of dams. To create a new durable water barrier at the upstream phase. The water barrier consists of a watertight Sibylon geocomposite. The Sibylon geocomposite is left exposed to allow inspecting it at any time. The Sibylon geocomposite is anchored by a phase anchorage system that avoids formation of slack areas and folds. Design the phase anchorage system in function of the worst loading scenario, generally generated by uplift wind. Depending on the type of substrate, use of anti-puncturing support layers. Create behind the geocomposite a drainage system that allows avoiding back pressure in case of dewatering, progressively dehydration of the dam, monitoring the behavior of the new water barrier. Create a peripheral sealing system to avoid water entering behind the new water barrier. Design the perimeter seal in function of the waterhead. The CARP system for rehabilitation of dams. Exposed Sibylon geocomposite is the new watertight element. In this picture, we see a cross-section of the waterproofing system. It includes the phase drainage layer, the waterproofing geomembrane, and the geomembrane anchoring and draining system. The benefit is that even in case of an accidental damage to the geomembrane, the phase drainage layer intercepts all infiltration water and discharges it by gravity. Then placement of the geonet in between the profiles. It's seaming of adjacent geocomposite sheets.
I apologize with the audience because every detail of these slides were described in details, but
A
unfortunately,
strip of
cannot be
PVC
heard.
is welded over the face anchorage profiles to provide full watertightness. The top seal consists of the content strip on the yacht. Chignana Dam is a gravity dam where the Siberian system was installed on the full face for rehabilitation. The project now is 32 years old. Alpegera gravity dam with the steel facing went under partial face rehabilitation. Partial face rehabilitation at Chambon gravity dam affected by alkali aggregate reaction. Grosser-Mühldorf Dam in Austria is a gravity dam for the upper reservoir of a pump storage scheme. Skies Dam, a buttress dam which was lined with exposed membrane in different campaign. Bracana buttress dam in Portugal affected by alkali aggregate reaction. The owner stated that the exposed Siberian geocomposite installed in 1992 contributed to slow the alkali aggregate reaction. Gem Lake, a multiple arch dam in United States. Le Pradot, another multiple arch dam in France, lined in 2007. Panessière in France, a dam which provides drinking water to the town of Paris. Flores Dam in California, multiple arch dam for hydropower production made in multiple stages. Publino Dam in Italy is an arch dam which was lined in 1989. Bimont in France, an arch gravity dam suffering internal sulfate attack, which underwent partial face rehabilitation. Oker Dam, Germany, arch, repair of joint, installation partially underwater. Siberian geomembrane has been used for partial face rehabilitation of an RCC dam. This is Sacco de Nova Olinda in Brazil. Application of geomembrane in masonry dam. This is the largest type of dams in India. The waterproofing system is conceptually identical to the one described for concrete dams. The roughness of the masonry subgrade may require installing an anti-puncture layer on the masonry, regularizing with mortar the surface where the tensioning profiles are placed and where the perimeter seal is placed. In masonry dam with aggressive surface, the installation of an anti-puncture layer, generally on woven geotextile, may be required. These pictures shows outstanding examples of masonry dams rehabilitation in India. On the left, Kadamparai, in the middle, Servalar, on the right, Upper Bhavani, a project which is ongoing. More information are available in a presentation on Indian experience in flexible geomembranes, a presentation which will be in this conference. Kadamparai Dam is a composite dam, 60 meter high, 478 meters crest length in the stone masonry section, and was completed in 1984. The dam forms the upper reservoir of a 400 megawatt pump storage scheme. The first impoundment, a maximum seepage of more than 1,100 liters per minute, was observed. Seepage at the drainage gallery gradually increased, well above the allowable limit. A geonet provides the drainage system, and an optical fiber cable is also installed to
to refine the monitoring. A 2,000 gram per square meter geotextile was installed on the upstream face to protect the geomembrane against puncturing. And now we can see the results. 38 liters per minute before the repair, 80 liters per minute after the repair. In the center, the dam under impoundment. Several Dam is the first geomembrane project in India under the Dam Rehabilitation and Improvement Project. It is a stone masonry dam completed in 1984, owned by Tanjetka. The purpose is drinking water, irrigation, power generation. And the scope of works is to waterproof the left abutment and the spillway, source of 80% of the leakage. Leakage in the gallery before the works, and on the right after the completion of the geomembrane installation. Upper Bhavani is a third masonry dam in India, is a project ongoing, and is the second geomembrane project under the Dam Rehabilitation and Improvement Project DRIP. It's a stone masonry dam, 82 meters high, 425 meters long crest, and is owned by Tanjetka. The dam was leaking more than 8,200 liters per minute and was declared distressed. At Upper Bhavana, the installation is ongoing, despite the difficulties created by the COVID situation. The results obtained by the application of the Siblon system in the masonry Indian dams are quite impressive. In all the three dams, the reduction of leakage has been more than 99.75%. The waterproofing system is conceptually similar to the one described for concrete dams. The anchorage system is designed in function of the existing facing on which the geocomposite is placed. The connection, embankments, concrete appurtenances, if any, require designing a peripheral seal that can accept possible differential displacements. Salt Springs in the United States is a concrete face rockfill dam. In 70 years of service, were performed 24 ineffective repair campaigns. On the left, we can see severely damaged concrete face and previous repairs. And on the right, we can see that in 2005, after 1 year of service under 45 meters of waterhead, the Siblon geocomposite is adapted to the concrete surface. This entailed minimum surface preparation. The installation was performed in stages. Mesokora in Greece is another concrete face rockfill dam, 150 meters high. Taradella Dam in Portugal, 112 meters high, was the subject to a partial face rehabilitation in the lower leaking area. El Salto Dam in Bolivia is a concrete face rockfill dam. Here, the Siblon was used to waterproof the peripheral joint plinth face slabs and of the vertical joints by using the Carpi patented external water stop system. Saforada Dam in Italy is an asphalt concrete face rockfill dam, and in 1992, the Siblon geomembrane was installed exposed. Moravka Dam in Czech Republic is an asphalt concrete face rockfill dam. In 1999, the Siblon geomembrane was installed exposed. On the left, we see a picture taken during an inspection after 12 years of service. Upper blue in United States is an asphalt concrete face rockfill dam at 3,580 meters of altitude. Here, the geomembrane was installed in 2007. Underwater rehabilitation is possible on all types of dams for full face or just local repairs. Carpi developed a system for the underwater rehabilitation of hydraulic structures in flowing water. The synthetic material used is named Siblon mat. The Siblon mat is a wide prefabricated mattress composed by two synthetic geomembranes connected by flexible strips of geomembrane. Adjacent Siblon mattresses are connected underwater by heavy-duty watertight zips. The Siblon mat is filled with cement grout to provide ballast and avoid dragging by the flowing water. And more information will be available in a presentation on underwater project, which will be also presented in this conference. Civil map is prefabricated in the factory. We can see the large rolls on the right, and then the installation is performed in flowing water. In the center, we can see the heavy-duty zip. And now we come to the conclusion. Flexible geocomposite, and in particular the civil geocomposites, can be used and have been successfully used to rehabilitate all types of dams. Civil geocomposite systems are an established and durable technology. Rehabilitation can be a full-phase rehabilitation, staged if required, or be a partial phase rehabilitation, or a measure to repair joints or cracks. Installation can be made in the dry and underwater. A technology for installation in flowing water is available and has been successfully implemented. And with the picture of Upper Bhavani in the background, I thank you for your attention. I cannot hear you.
I'm much thankful to Mr. Alberto, and at the same time, I'm extremely sorry to the entire audience for not being able to flow his presentation as per the expected level. However, we have enjoyed his presentation, replete with knowledge and experience. And I'm again thankful to Mr. Alberto for his valuable knowledge sharing. And now I am inviting the next speaker of this session, Mr. Marcus from Germany. Actually, his focus will be on the application of fabric formed concrete, that is geometries, including articulated blocks and revetments in restoration of dams and conveyance systems. He actually has done his graduation in 2009 from the Technical University of Hamburg, Harvard, Germany. And now he is the business development manager, hydraulics and dewatering at Usker in Germany. He has a wide experience of dam restoration, and he has more than 35 technical publications to his credit. He is also member of HTG, IDS, DWA, CUR, ASTM, etc. And he is chair of the ASTM D66850 standard guide for the selection of test methods for fabrics used for fabric formed concrete FFC, and ASTM D644999 standard test method for flow of fine aggregate concrete for fabric formed concrete working groups. I invite Mr. Marcus to kindly join online and scroll his presentation at his end. Welcome, Mr. Marcus.
Thank you for this very kind introduction. I'm sharing my screen. Can you see the presentation?
Certainly.
Yes, good, fantastic. So my presentation consists of two elementary components. The one is fabric formed concrete revetments, and the other one are large dam infrastructures. I think I don't know, it's not necessary to explain you what a large dam infrastructure is, but I assume not everybody is familiar with the fabric formed concrete revetments. So this is, they have a long history. This is a wonderful book only available in German, written in 1971. It's dealing with the experience of plastics for hydraulics. And it's showing almost every application we are nowadays dealing with. The materials have essentially changed during this almost 60 years period, but the systems are similar. I want to draw your attention to the center picture, which is a fabric formed concrete revetment, and it has been used since the early 60s. So there is a long-term experience with this type of system. What are fabric formed concrete revetments? At the end of the day, you have a geotextile formwork, which is porous, which is not a membrane, which has vertical ties, creating a space where you fill in highly fluid concrete. The lining effect is now achieved by the highly fluid concrete or the erosion protection. Different mattress systems are available. Uniform section mattresses, which are used for lining, which are impermeable, and then you have porous permeable systems like articulating block mattresses, filter point mattresses, or vegetative grid mattresses. All these can be used for dams. As I said, there's a long-term experience. I just want to show you some pictures. This is an erosion protection of a length bank with the uniform section mattress installed in 1977. And almost 40 years later, it's still in place. It's still doing its job. Another very interesting project here, Canal Imperial de Aragonés in Spain, installed in 1973, which is a conventional irrigation canal. It was lined with the uniform section mattress, installed in the dry, and you see the condition in 2011. So 40 years of service life, and it's still doing its job. So where's now the link to dams? If you talk about dams, everybody thinks about structures like this, mass gravity structures, arched. In this case, I have to apologize, I'm not able to pronounce this name. It's located in Russia, close to Abakan. It's the 9th largest hydroelectric power plant in the world, so it's a massive dam. But the question now is, where can you use these fabric formed concrete revetments for these type of dams? What people forget about is the structure beside the dam, the emergency spillway. So this is the emergency spillway for this Zayano Dam. And I had the pleasure to take a flyover over this dam, and you see it's a very nice concrete structure. People have the tendency to forget about the importance of these emergency spillways, which can cause serious issues and troubles. I have selected one of these emergency or these problems or emergency cases, and that's the Oroville Dam failure in February 2017. The dam is located in California. It has been constructed 60 years ago. You can see the details. I just want to draw the attention. There is a concrete spillway used for normal service, and there's an emergency spillway. So what happened in this case? The spillway is lined with concrete plates. Concrete plates have transition joints, and these joints are a serious threat for all type of concrete structures, like a masonry wall. So in this case, during the normal discharge, the normal service life, the concrete plates failed, and it occurred massive erosion. So due to this, the discharge dropped and decreased, and they had to use the emergency spillway. This was the first time that this emergency spillway was used. And you see here what happened. Strong waters has an enormous erosive force, and it found its way beside the emergency spillway. So what happened? They shut down the dam on February the 27th, and you see what has happened to the dam or the structure beside the dam. It was seriously threatening the overall dam stability. Therefore, they shut down the operation, and that is the result. So what is the conclusion of this? At the end of the day, you have to pay attention to the small things beside the dam. And this is the link where fabric formed concrete revetments come to the table. I do not have so many wonderful case studies like our friend from CAPI presented. I just have selected two very nice examples of what can be done. This is a tiny little barrage called Schadebach in Bad Rina in Germany. So it's a small storage dam with almost 1 million cubic meter of volume. The height is moderate, 3.6 meters, crest length 285 meters. In this case, you see here the cross section and the top view of the intended overflow section, emergency spillway beside the dam. What you see is from the top view that this is quite a challenging geometry. This is not a straightforward spillway. It has a lot of corners, slopes, but also dams in order to concentrate the flow, not to allow the flow to pass by the emergency spillway. In reality, this looks like this. On the right-hand side, you see the crown, the lower dam section, and on the left-hand side, you see the spillway going down on the land side of the dam. In this case, a vegetative grid mattress was used to get a nice integration into the environment. And in this case, we always recommend to place a proper filtration nonwoven beneath in order to avoid what has happened to the oil undermining and erosion of the subsoil. Normally, these type of structures are constructed with factory assembled panels. You see the layout here. These white spots on the panels are the inlets. You see how it nicely adapts to the dam section, to the lower dam section, and also how it perfectly adapts to the spillway. Then, as I said, you need highly fluid concrete. Here, the concreting starts. You see how this tubular grid pattern of the mattress develops. It nicely adapts, and that's one of the biggest benefits of the system. However, the subsoil has been prepared due to the highly fluid concrete and the adaptability of the system. You won't have cavities or voids beneath the system. So this is absolutely crucial. You see the filling process. They have initiated the filling. The highly fluid mortar is running into the system. The mattress is shaping, and this is the final look at the concreted section. You see everything nicely fits. Wonderful job done by the construction company. And we were talking about the environmental integration in the environment. Here you can see they covered it. They have greened it. In the overflow section, gravel has been placed, and at the lower section, it has been greened. So this was quite a tiny little structure. A wonderful example in my opinion. Nevertheless, you can also do it for large structures. This was, again, an example in Germany. Just a side comment, we have been using this system also for irrigation canals in India. There are some projects ongoing also during COVID time now. So this system is also well known in India. So this was the largest structure for the Cottbusser Ostsee. It's a former open pit, and they needed a flooding structure because they want to create a former pit lake. So this structure is quite impressive. It has 160-meter length, an inclination of 1 to 1.5, and is designed for a discharge of 5 cubic meters per second. So this, at the end of the day, doesn't sound a lot. But where is the superiority of this system? We have been using this system up to flow velocities of 23 meters per second for berth protection. So this clearly indicates this is a very high resistant revetment system. Some impressions from the installation. You see here the slope. Again, I have to highlight the adaptability of the system. You see, there are side dams to guide the flow, and the stilling basin at the toe of the structure is also completely lined and secured against erosion with this mattress. Some other nice impressive shots from the top. You see after completion of the project, everything has been lined. Just some impressions to see how nicely it fits. A nice aerial shot, and then it was the inauguration, and that was a big celebration. it's going to be the largest pit lake in Europe. So they celebrate it nicely. So summing up, coming to the conclusion, why can this be used? These systems provide some technological and practical benefits. Yeah? As I mentioned in the beginning, concrete slabs have the problem of the transition. Due to the unique filling system, you get compression joints, you have no transitions, you have no open joints, no joints where the flow can attack. So you have a coherent revetment. It's flexible, it adapts to the subsoil, as you have seen. I mentioned the high flow velocities it can resist. Also due to this coherent revetment style, it can be installed on very steep slopes. So imagine this spillway or this inlet structure would not have been able to be constructed with rock. Rock would have been rolling down the slope. So it allows to construct highly resistant revetments for very steep slopes. We have been using it also vertically. Underwater installation is common practice. Canal linings are normally done underwater. In this case, I haven't included an example, but they are present. And due to the filling with concrete, it's robust and long-lasting. Yeah, that was just a quick insight into fabric form concrete revetments. I thank you very much for this opportunity to provide this insight and for the organization. And I'm looking forward to some questions. You are on mute.
Thank you so much, Mr. Marcus. We are all grateful to you for sharing your valuable experience with us. Your presentation was really interesting. And now, in the last, I shall make my presentation. I shall run through.
Mr. Kapadia, we can't hear you.
720 more. I think the voice is not properly coming to the end. It is 6,750. May I scroll the presentation at my end? Organizers, please let me know. May I share my own screen and scroll it?
Sir, I think it would be better if you kindly share your screen. Yeah.
Okay. Hope my screen is visible to everyone.
Not at the moment, sir.
Is it all right now?
Yes, sir. Yeah, make it on the full screen, please.
Is it okay?
Yes, sir. That is okay, sir.
Yes, I'm making the full screen. So, my
Sir, unmute yourself. Sir, unmute yourself.
I'm unmute and sharing my screen now again. Cubic meter. It is a masonry gravity dam, 868 meter of length, having total distance 1.337. Here are the earthen flanks of the Kai Dam, and this magenta portion is the spillover section, and this blue line is the tail-race channel of the hydropower, and this one is the divide bund, which is made up of earth, and it was originally clad with the stone pitching. The basic purpose of this divide bund was to channelize the river water in the downstream of the spillover section. It is found that the nose tip portion of this divide bund, marked with blue dark line, is the most vulnerable portion because it has to take the highest magnitude of the current of the river water. When we observed in January 2019, the stone pitching on this nose tip portion was completely ruined. There were so many cavings into this earthen embankment, and the stability was also endangered because it had to take strong eddies and high velocity water currents, and the river bed beside this nose tip was also found significantly eroded, though it was a basalt river bed. The restoration plan that we proposed was like this. First of all, the inclined portion of this earthen bund was required to be corrected with properly compacted soil. Once the base is properly done with the compaction and new material filled in, a sand layer was required to be sprayed. Then a non-woven polypropylene geotextile was to be sprayed, and then in the 10-meter incline height was suggested to be provided a polyester biaxial geogrid. Again, a sand layer was required to be provided, and that was to be covered with 2-meter thick gabion layer. And then finally the top layer was to be provided in the form of 3-meter by 3-meter concrete blocks with 50 centimeter thickness. And then in the bottom of the portion, that is the base of the river gorge near this divide bund, that is at the toe of the divide bund, it was found that approximately 5-meter deep a pit had occurred. So we decided to fill up the pit with the rubbles and boulders, and that was to be covered with the 2-meter thick gabion, and the final cover or the clad was to be made up of 1.5-meter thick concrete with reinforcement on both the sides, that is top and bottom. And this is how the entire mechanism for the restoration purpose was designed. Main 3 features were there of this design. One was the multi-layer mechanism for dynamic load dispersion. Here what you see is the polypropylene, geotextile and geogrid. Then the semi-flexible kind of gabions, and then the rigid material, that is concrete. So it is multi-layer mechanism. How it is coming to use is described in the next slide. The drainage mechanism is also a special feature in case there is a high value of pore pressure inside the earthen embankment. That will be given the way out through this sand layer. The gabion voids will also permit to go it out, and each of the concrete block 3-meter by 3-meter in the width and length are provided with 15 millimeter gap between 2 consecutive clads, and that is how the pore pressure will be released. The roughness for bringing geograde into tension is ensured by providing sand layer in the bottom and top of it, so that in case there is some kind of slip circle failure, it can be prevented by the tension in this geogrid. So that is how these design features were taken care of in the design. Now I am coming to how the multi-layer mechanism comes to our succour. In the conventional single layer protection system, say there is a stone pitching or a concrete cladding on the earthen bund. Only little dispersion of the dynamic load impact is taking place over here, and whatever little dispersed force comes on the base is to be taken care of by the soil mass. So the magnitude is very high, but the area of dispersion is very low. Whereas here we have proposed a multi-layer solution. So this is the rigid concrete surface. This one is the biaxial geogrid. It is further, sorry, this one, second one is the Gabion, that is semi-flexible. It is further dispersing the force, and this third one is the biaxial geogrid, which is dispersing the load further, and that is how on a large area the dispersion takes place, and that's why the magnitude is drastically reduced, and that is how the soil mass has to take only a little magnitude load even if the impact magnitude is too high. So that is how we have tried to provide a longevous solution in the form of multi-layer dispersion mechanism made up of different materials with varying stiffnesses. The properties of the non-woven polypropylene geotextile is like this, and the mechanical properties of the polyester geogrid are given into this table. Now I am coming to the global equilibrium of forces. Obviously, this Gabion and the concrete cladding on the inclined burned surface will be tending to slide down. So this force equilibrium is done by using the basalt river bed like this. So this bottom portion that has been the launching apron will be acting as a key come apron. So this concrete surface will be acting as a launching apron when there are vertical currents of the water, and it is also going to act as a scour mechanism to protect the river bed. So naturally, whatever the river profile has been available over here has been used to form a proper keying and the anti-scour mechanism, and that is how the mission was executed within 6 months of time, that is before the beginning of the monsoon of the 2019. This solution has witnessed 2 very good monsoons and several times spill over. What here I have tried to show you through this photograph, in the background is the spillover section of the Okai Dam. What you see here, large discharge is allowed to be in the downstream of the spillover section, and you can see here how hydraulically beautiful is the view of this nose tip section now, how nicely is being entrained the river currents to be within the mid of the river gorge. So 2 monsoons have testified in the initial stage the solution that we have provided. Now I am taking you to another case study, that is of the Kadana Dam, that is that had a secondary apron very badly distressed. This is the Mahi River, which is again a very large waste flowing river shared by 3 states, Madhya Pradesh, Rajasthan and Gujarat. The dam is not as big as the Okai Dam. However, it is significantly a big dam. Its storage capacity is 1,542 million cubic meter. It is again a masonry gravity dam. Its spillover section is 113 meter, equipped with 21 radial gates. An additional spillway is also provided, made up of 6 gates, and the total discharge capacity is 31,063 million cubic, 31,063 cubic meter per second. If you see the plan of this Okai Dam, Kadana Dam, this is the roller bucket portion. In the cross section is looking like this. This is the spillover section, ogee shape, and followed by the roller bucket over like this. And this one is again the basalt river bed for a significant length. Originally it was up to this portion, And then there was a pit like this in the riverbed when the dam was constructed. But here the distance was significantly large. It was 75 meters approximately. And that's why the designers thought that this basalt riverbed itself will be acting as a natural secondary launching apron when there is a roller bucket formation over here in the form of anti-clockwise water cycle, which would be subsequently followed by clockwise cycle like these. All the dynamic loading will be taken care of by this basalt river bed, which is 75 meter in length, and accordingly the dam design was done, and that performed quite well for long years. But when we observed it again in 2019, we found that the pit became enlarged. This is the original formation of the pit when the dam was constructed in the early 70s, and here what you see is the stage in 2019. So we observed that the pit is getting enlarged because of retrogression towards the bucket, and now it has come very close to this river bucket. So the secondary apron, which has to take the forces because of the water cycle in the clockwise fashion, the length is now not sufficient of this original river bed made up of basalt. So energy dissipation is now requiring a man-made secondary apron with proper filling of the pit, so that in the subsequent years the same story.
Kindly unmute yourself, sir. Sir, kindly unmute. Sir, kindly unmute yourself. Sir, kindly unmute. Sir, your sound, sir. Sir, kindly unmute, sir. Sorry. Okay, let me check, sir. वो unmute किया हुआ उन्होंने. उनका नाम यहाँ से करेंगे बोलिए उनको कुछ बोलिए, साउंड ही नहीं आ रही।
Am I audible now?
Yes, sir.
Hello? Am I audible?
Yes, yes, sir. Now audible, sir.
Am I audible?
Yeah, yes, sir. Audible.
And yes, and may I share my screen?
Yeah, yeah.
So I think we Hello, am I audible?
Yeah, audible, sir. Audible. TV also visible.
So here we ended up with slide number 12. We discussed that the retrogression towards the bucket became very serious a problem, and hence the solution was to provide a man-made secondary launching apron. That's why we provided a design like this. It was a pit filling with the large boulders, which was covered with a biaxial geogrid, which is magenta over here. Then a layer of aggregates was provided, and that was covered with a cement sand cushion, and an RCC apron was provided atop it. And in the last length, in order to attain some flexibility, we provided gabions instead of a concrete launching apron, and this was the downstream key. So this is how entire solution was designed in order to address the issues of hydraulic gradient and the uplift. What you see here are the vertical drainages. These vertical drainages are actually meant for relief of the pressure from beneath the foundation. So that is how the hydraulic gradient will be adjusted. This is the cross section of the mechanism that we have designed finally. Had it been a single layer dispersion of load kind of a mechanism like this, obviously whatever is the load would be the reaction from the ground, that is the boulders which are filling the pit. Whereas here we have provided a multi-layer solution in the form of biaxial geogrid in the bottom that is covered with the launching apron, which is again not too thick, so it is also a flexible member. So whatever the load comes, the reaction is to be offered by three different elements. One is the tension in the biaxial geogrid, the other one in the form of flexure in the launching apron by formation of the neutral grid, and then whatever is the balance is to be offered by the boulders in the pit. So this is how we have obtained a lesser vertical reaction from the ground by reducing the distribution of the forces. So instead of going for energy dissipation, we have selected the cushioning mechanism. So breaking of the waterway is now replaced by the cushioning mechanism. So that is how the multi-layer geosynthetic system is working in this launching apron. This is the completed view of the Kadana Dam, and I'm here with extremely thankful to the audience for kindly bearing with the technical snag that haunted me on the way. Thank you so much. And now I'm concluding this session by summarizing the views of all the speakers. The first speaker was Mr. Kelvin from South Africa. He has actually covered up a large gamut of applications in repairs of dams with the help of several case studies, upstream and downstream protection works, internal drainage works, pressure relief mechanisms, stability of earthen bunds, raising of dams, spillover sections, vertical cutoff drains, etc., using varieties of geosynthetics. And he has also underlined the effectiveness of the solutions with the geosynthetics. The next speaker, Mr. Alberto, he actually provided us very valuable information and a treasure of knowledge that he has had. He enlightened us with the fact that geosynthetics is applied in the dams for last 62 years. He has enlightened us with the fact that geosynthetics is used for last 62 years in the restoration of the dams, and so far more than 350 dams have been repaired with the application of geosynthetics worldwide. He has also referenced 3 Icold bulletins, number 38, 78, and 135. And he has also covered in his presentation design principles for dam restoration, techniques for restoration of different types of dams like gravity, buttress, multiple arc, etc., along with case studies across the world. And he has also showed us some application, including water restoration underwater. The next speaker was Mr. Marcus from Germany, whose main focus was on application of geometrics, that is fabric formed concrete. He has also explained certain case studies of Spain, Russia, USA, Germany, etc. And he also made us enlightened with the fact that the flexible mechanisms, how they work in the dam restoration and restoration of the conveyance systems. So today we had very distinguished engineers in the field of dam engineering who have actually applied geosynthetics in the solutions of the dam restoration. So I am again extremely grateful to all the speakers of today's session. Barring technical snags on the way, the session was rich and replete with the knowledge treasure of the experienced civil engineers in the field of dam engineering, who have very long and rich treasure of knowledge as well. So I am again extremely thankful to everybody. I was just browsing the chat box, but so far there has not been any question in the chat box. So I am now leaving to Mr. G.P. Patel of the Central Board of Irrigation and Power Government of India to kindly take over the proceeding of the session.
Thank you very much, sir. Thank you very much. So we are at the end of this special session. So I think I should convey thanks to all, sir. It is an honor for me for giving vote of thanks. So first of all, I would like to thank our learned speakers, Mr. Calvin from South Africa, Mr. Alvato from Switzerland, and Mr. Marcel from Germany for their excellent presentation. Our chairman has already briefed what they have told us. I would also like to thank today's chairman, Mr. Vivek Kapadia, for the nice presentation, for nicely handling this session. Sir, as president of IGS India, it was your initiative to have a special session on this mega event Icold 2021, which is being watched in more than 100 countries of the world. Sir, your vision, your dream has come true. It was excellent presentation, excellent speaker, sir. It was nicely managed. Of course, a little bit problem was there, so that was unavoidable. I'm sorry for that, sir. So with this, I thank all. Still, I like to thank the virtual manager for the program which has been doing from last 3 days. So thank you very much, sir. Thank you all. Thank you.
Thank you all and goodbye.
Thank you very much, Vivek and Mr. Patel. Have a good day.
Thank you, sir. Thank you very much.
Goodbye.
Bye.
Thank you very much. Bye.
Sir, sorry, there were few things which were beyond.
Hello, can you confirm? Hello?
Hello.
Hello, is it hall 2?
Okay, sir.
Hall 2 है ना?
Anyone from virtual MNC?
Good afternoon.
Yeah, good afternoon, sir.
Can anybody confirm we are into innovative construction methodology session? Host can confirm. प्रेजेंट कर रहे हैं कोई बात नहीं।
Sir, I think there is some problem in the running of video. Can anybody manage this?
Hello, anyone from virtual MNC?
Voice of video is not coming.
Yeah, hello. Can virtual host confirm? Is it session on innovative construction methodology? All one?
Sir, myself Pankaj Vishwakarma.
Yes, sir. Yes, sir. Yes, sir.
Hello. यार मोहित
megawatt at EL 1224 meter. As I already shown you in previous slides. This is the final picture of the upstream coffer dam and diversion scheme of our VPHEP project. Now the river is successfully diverted.
I would request virtual MNC kindly restart the video, please.
This event of June 2013 has extremely impacted our powerhouse area also. Very good evening to the chairman.
Thank you.
Ladies and gentlemen of this session. Myself, Pankaj Vishwakarma, and I am a Deputy Manager Geology, presently working in TSDC India Limited. Today I am going to discuss about the mid-course corrections in significant project parameters due to extreme event of flash flood in Vishnugad Pipalkoti hydroelectric project in Uttarakhand, India. I am one of the co-author of this paper. Vishnugad Pipalkoti project is located on the river Alaknanda. Major component like desilting chamber, HRT, powerhouse, TRT are located on the right bank of Alaknanda river, except diversion tunnel and diversion cum spill tunnel are on the left bank. Before coming to the salient feature of the Vishnugad Pipalkoti HEP, I would like to discuss about the key feature of this project. Vishnugad Pipalkoti HEP is under construction project and is a 444 megawatt run of the river scheme. This project is funded by World Bank, and this is the first Indian hydroelectric project where the geotechnical baseline report has become a part of contract document. We have a 13.4 kilometer circular shape HRT of 8.8 meter finished dia. Out of 13.4 kilometer, 12 kilometer will be driven by double shield TBM machine. Main central thrust lies about 2 kilometer northeast of the dam site, but all our project component lies downstream of the MCT. Now coming to the salient feature of the project, we have a concrete gravity dam of a height of 65 meter, of which the top level is at 1270 meter. We have a diversion tunnel of 10.5 meter dia of circular in shape, and the length of which is 490 meter. We have 3 numbers of the underground desilting chamber. The length is around 390 meter, width is 16 meter, and the height is 21.25 meter. We have underground powerhouse of 146.2 meter in length, 20.3 meter in width, and 48 meter in height. Transformer hall, underground transformer hall is there. The length of which is 140.3 meter in length, 15 meter in width, and 25.5 meter in height. We have a TRT of 3.07 kilometer. The dia of TRT is 9.5 meter, 9.1 meter, and a circular shape. For the better understanding of the participant, I have divided the project layout of the VPHEP in dam complex as well as in powerhouse complex. From this figure, we can easily see that we have a 3 number of the intake structures, of which the dia is around 6 meter. And we have a 3 number of the desilting chambers. The diversion tunnel and the diversion cum spill tunnels are located on the left bank of river Alaknanda. In powerhouse complex, we have a open to sky short shaft, machine hall, transformer hall, and downstream source tank. This table shows the regional geological setup of the Vishnugad Pipalkoti HEP project. The project is located in Pipalkoti window. Pipalkoti window is basically a carbonate suits of rocks and exposes the lesser Himalaya. The rocks are grouped under the Garhwal group, and they are represented by low-grade dolomitic limestone and quartzitic sandstone and slates with metabasic rocks. This is a regional geological map of a project area. Our dam site is located close to the village Helang, and our powerhouse is located close to heart area of Chamoli district. As we all know that in June 2013, a multi-day cloud burst and a heavy to very heavy rainfall hit several parts of the Uttarakhand area. And though all the 13 districts of the state were hit very badly, but out of 13 districts, 5 districts were hit worstly affected. Out of which Chamoli was one of the district in which our VPHEP project is located. This unprecedented rainfall resulted in a sudden increase in the water level and giving rise to the flash flood in Alaknanda Basin that caused extensive riverbed and toe erosion and landslide at various locations and huge transportation and deposition of the sediments in the downstream area. This flash flood had eroded the riverbed profile significantly in the dam area, and that affected the design diversion arrangement of our VPHEP project. This event led some deposition at powerhouse area and caused a steep rise in the riverbed level. A huge quantity of the silt got deposited in powerhouse exploratory drift, and muck was left by river at the tail race tunnel outlet area also. From this figure, we can easily understand that how devastated that flood event was. Our whole drift was submerged under the water, and these photographs shows that inside view of a drift, the dia of the drift was around 2.1 meter. Almost half of the drift is filled with the silt in a length of around 400 meter. This figure shows that the L section or the gradient level of the river Alaknanda up to the VPHEP dam, the gradient is very much high, due to which at dam side of VPHEP, erosion activity has taken place. And after that, the gradient becomes gentler. Because of that, at powerhouse area, the deposition has taken place at various locations of powerhouse. This extreme flood event of June 2013 caused deposition of debris at various locations of powerhouse and resulted in the rise in riverbed level. And at places, it also caused erosions, which eventually lowered the riverbed level in dam area. After the June 2000 flood event, we have taken the revised cross sections at dam area as well as in powerhouse area. A review of fresh cross sections indicated that there is a substantial level difference in the riverbed levels at the inlet as well as outlet of the diversion tunnel. This cross sections of the diversion tunnel inlet shows that we have kept earlier our inlet at EL 1228 meter. From this figure, we can easily see that how much devastated the flood event of June 2013. Around 10 to 12 meter high water reached in dam area. This is another photo which shows the flood line at dam site area. Above this valley bridge or upstream of this valley bridge, we have proposed our upstream cover dam as well as dam site. After the flood event of June 2013, we have updated our diversion tunnel cross sections and detailed deliberation and detailed engineering. After that, we have kept our inlet levels at 1224 meter and outlet at 1216 meter. It was evident to raise the height of the upstream coffer dam also if we do not change the invert level of inlet and outlet structures, which had been located on alluvial material more than 20 meter in depth. Having further more height of coffer dam over such material was not at all suitable, and that event compelled us to review the diversion scheme thoroughly in totality, and revision was required to release the discharge. With these consideration in view and to limit the heading up of water at upstream of coffer dam, it was evolved to increase diameter of circular diversion tunnel from 10 meter to 10.5 meter with the free flow conditions. And the top of the upstream and downstream coffer dam have accordingly been adopted at EL 1239 meter against the 1242 meter that was envisaged at DPI stage. Similarly, downstream coffer dam top was placed at 1220.5 meter against 1229 meter, which indicating the height of upstream coffer dam around 17 meter and 6.5 meter for downstream coffer dam. And consequently, the invert of the diversion tunnel was also lowered at EL 1224 meter, as I already shown you in previous slides. This is the final picture of the upstream coffer dam and diversion scheme of our BPHEP project. Now the river is successfully diverted through this diversion tunnel. This event of June 2013 has extremely impacted our powerhouse area also. After taking the revised cross section at powerhouse area, we have assessed that latest bed profile, and this event has forced us to recalculate our levels of MAT and VT to at a safer elevations. From this figure, we can easily understand that on the left side, before the flood event, we have placed our exploratory drift at a higher elevation of river. But in June 2013 flood event, our drift got submerged and filled with the muck. And after detailed deliberation and reported discussion, we have kept our invert level of MAT and VT at 1075 meter against the 1066 meter and 104554 meter respectively. That was considered as tender stage. Due to this heavy flash flood, river-borne material accumulation has taken place at the right bank of the river Alaknanda near TRT outlet, and this has changed our river channel course towards the left bank. The water level near the TRT outlet touched up to a 1031 meter. This change in the river bed profile also changed the morphometry of junction at TRT outlet, and such changes in the river bed profile compelled us to flood protection arrangement, review the flood protection arrangement, and accordingly flood protection arrangements has been modified considering the existing riverbed morphometry after the flood event of June 2013. These are some photographs after the June 2013 flood event. We have kept or constructed our MAT and VT at safer height. So before summing up the presentation, I would like to acknowledge our top management of TSDC, our senior officers of GNG wing, GMGNG, AGMGNG, as well as senior manager geology for supporting or guiding me during the preparation of the presentation. Thank you.
Hello. Shall I start my presentation myself, Dr. Sanjay Burale?
Yes, sir. Start. We will start, please.
Myself, Dr. Sanjay Burale. I am working as scientist in CWPRS Pune, and I am the in charge of Geotech Engineering 1. So my topic is slope stability study using mathematical FEM model. So you can see this is Maharashtra and Goa border. Here it is Maharashtra and Goa border. And this canal was going like this here from here. And there was one hillock here and lot of methods they have utilized for constructing that canal at the toe of the hillock. But about 4 times it failed. But I have given the solution to them from last 3 years. It is that canal is standing. That is my study area. So see that this is Maharashtra. Here it is Savantwadi, and it is near Savantwadi, that location. It is border of Goa, and that, you know, there is a dam in Maharashtra. From there, the canal goes to from Maharashtra to Goa. So this is the location. You can see this is Bandha branch canal. About 4 times this canal was constructed, but it fell every time. It fell. You are what I am saying. You are hearing now, sir. It is okay. Sound is okay. Hello.
Yes, sir. Everything.
Okay. Okay. So this is the joint venture of Maharashtra and Goa, and dam was constructed in 2009. And in the first, in 5/10/2009, adjacent hillock to the inspection path, canal cut and slide in the canal, resulting into full damage to the construction protection wall and lining. Parabolic shape, one tension crack was developed, sir, that is 1.5 to 2 meter wide. And then they decided to construct the box culvert that it was suggested by Central Design Organization Nasik. That was also constructed, but it is also failed. I will show you the photograph. Next rainy season, it also failed, sir. Then they decided that hillock to re-sectioning the hillock and construct that box culvert. That also fails, sir. So you can see here, sir, this is the box culvert. And as we know that there are failure takes in 3 places: at the surface of the slope, from the bottom, or from the toe of the hillock. Here from the base of the hillock, that slip takes place and failure takes place. And these all the material from the bottom, it comes up, and there is a tilt in the box culvert. You can see here the tension crack at the top of the hillock. Here you can see the development of tension cracks, sir. This is the location, sir. Here you see for stabilizing the slope, resectioning was made to the hillock, but it fails, sir. 3 to 4 times it fails, sir. See that how much, 4 meters somewhere, 3.5 meter that hillock slides. See the box culvert, sir, how it is tilted, sir, because of failure of that means sliding of that hillock. So with my boss, I visited that site, and this you can see, and that permanent solution is required to stop the hillock for slipping. Use Midas software, GTX software, sir. For that we required data. So we suggest them to take 20 meter apart bore and supply that log bore details. So you can see up to 12, 14, these all are laterite soil, complete up. Below that is it's a rock. It's a igneous rock, sir. Sorry, basalt rock. But above that, it's a complete soil material. And when it exposed this material, when it exposed to atmosphere, it reduces its strength, and C and fire it increases, and it fails, sir. And what happens, sir? Where it joined to rock, this laterite soil and rock, between that joint, it slipped from there, sir. So this was the RCC box culvert details, sir. So this is the property of rock property, sir. Compressive tension, which is required for running that GTX software mathematical model, sir. So this is gradation curve of that soil, sir. This is dry density and maximum and minimum cohesion and phi of this soil sample, sir. So initially, this project authority, they have given solution by IIT Powai. This is the solution they have given by IIT Powai. And its costing was, it's a 36 crore solution. It is huge costlier, only for 80 meter width, that 80 meter length of that canal. This much huge solution they have given by IIT Powai. So you see that this was the original hillock profile, and this is for stabilizing soil mass benching has been made, resectioning has been made. So we have used this properties, sir, for conducting model studies, physical model, mathematical model studies. And you can see here, after running the model, huge displacement was observed along, you can see here, periphery of this box culvert, and along the slope displacement, you can see that 314.7 that is into 10 means that is centimeter. So for stopping this, initially project authorities suggested CWPRS that to construct one this retaining wall here. So we have provided this retaining wall to this model, and we have taken the run. But you can see that there is no such too much stopping of this displacement along the profile of this hillock. So various alternative we have used this. You can see various means that is dia of the piles and anchor length, then 4 meters center to somewhere 3 meter. Various alternative we have make that design. So this is alternative, one of the alternatives. You can see 3D provided, but this is suggested by IIT Powai, sir. See that completely we have not used all the remedial measure provided by IIT Powai here. So then also, yeah, it is safe, coming safe. It is that it is reduced, that displacement value is reduced, but it is too costly, sir. So you can see 3D model also. So another alternative, we have decided that to make it economical. So there also you can see that that alternative also reduces the deformation, that is displacement values, displacement of hillock. And finally, you can see that this we have suggested, sir, at the berm level, series of piles we have suggested connecting each other with beams. And this below the box culvert, piles has been, that is 4 meters center to center and about 18 meter depth, and size of the beam is 380 by 380 mm, that is square beam here at top. So this was suggested, and it reduces, sir. You can see here the displacement value reduces, and its costing was very also low. It is 6 crore. Last year, huge rainfall takes place in this area, about 1.5 times. But there another structure they have washed, but this is still standstill, sir. So you can see this is 3D views, reduction in displacement value. So you can see the box culvert, how we have provided these piles. So this is design of box culvert and piles with reinforcement, showing reinforcement. So you can see this is box culvert, and this is at the berm we have suggested with beams with piles. So this is top view, and this is 3D view, and that so is here also design reinforcement, this design of this beam and these piles. You can see here details. So this is construction has been started. You can see the construction stages at berm level. So this is you see the reinforcement, 32 mm dia reinforcement, and this is putting inside the hole, and construction is under progress. You can see here clearly. And this is at box culvert, below box culvert. You can see the construction work. So here this is that excavation is going on, and that is filled by, you can see that piles, and above that piles it is connected with beams. So this is slab is going on, bottom slab construction. So this is complete photograph. This is at berm level. You can see the top beams and piles here, which above that box culverts. We have suggested 6 meter overburden over culvert. So this was safe now. Another studies we have conducted that they want here means after construction of this box culvert and everything, then there is a IP side here, inspection path is this side, and that should be stable. So this is that studies. So this is another site, sir. So you can see here periphery of box culvert. There is a lot of displacement, 3D also you can see. So this has been suggested. Here you can see this is IP roadside, and we have suggested here, and it is reduces, sir. So here it is reduces, that value is reduces. So this is that. Thanks. Any question?
Sir, what is the status presently of this slope?
Presently slope of that, you want hillock?
Yes, sir, that you have treated to collapse.
No, at the time of collapse or now after sectioning?
After treatment.
After treatment, yeah, it's 1.5 to 1, sir.
Okay, sir.
But the problem is with that, not slope, sir. The problem is what happened in the rainy season, the rainwater percolate and it goes at the surface of the rock top surface, sir. And where that cohesion reduces, sir, between rock and laterite soil, sir. And then it start moving and it comes up. It happened like that, sir.
Okay, thank you, sir.
Thank you, sir.
Hello, Tomya, sir.
Hello, I'm Tomya. Yes.
Sir, please share your presentation.
Okay. Can you see my slide? Okay.
Yes, sir.
Okay. Hello. Hello, everyone. I'm Tomoya Miyazaki. I will start my presentation. My theme is the introduction effects of 3D information models in Koishiwara-gawa Dam construction project. In Japan, the 3D information model in civil engineering field is called CIM. CIM. It is construction information modeling or management. So I use this word in my presentation. The construction project of Koishiwara Dam is conducted by the Japan Water Agency. We started construction from 2016 and we started management operation from April 2020. Figure 1 shows the standard cross-section of the Koishiwara Dam. The Koishiwara Dam is multi-purpose dam for flood control, maintenance of the normal function of water flow, and new water utilization. It is a center core type rockfill dam with a dam height of 139 meters. In this presentation, I show the principal efforts made during the course of the development and application of the SIM system. A SIM system for the construction stage was constructed as a system to convert a design drawing into a 3D model and add attribute information to it. The target of 3D model were topography and geological information, embankment, and surrounding structures. These individually created models were integrated using Navisworks from Autodesk. Figure 6 shows an integrated model of the whole area around the dam and the reservoir. This is model of reservoir and its surrounding area. And this is model of view from the downstream of the dam body. By presenting the completed image with the integrated model, consensus building among the relevant people proceeded smoothly. Then, figure 7 shows waterway intersection on the side of the spillway. And figure 8 shows conduit and cable racks in the inspection gallery. There were construction issues as mutual interference and positional relationship. 3D model make it easier to understand three-dimensional structures than conventional design drawings. These issues were reflected in the modified design and construction plan. A SIM system for the maintenance stage primarily focuses on its use of continual verification of dam safety by means of integrating patrol inspection and measuring results on a time series based on the post-completion model. As the contents of the information to be updated and frequency of updating differ between the construction stage and maintenance stage. Two SIM systems have been developed to serve the construction and maintenance stage. Figure 9 shows the composition of the construction SIM software. Civil engineering structures such as road and dam body are affected by the initial form of the ground, and their shapes have their own characteristics. Navisworks of Autodesk was used to create the construction SIM system for the integrated management of SIM, as the software is capable of loading various data formats, making the model lighter and enable the attachment of attribute information. Figure 10 shows the composition of the maintenance stage SIM system. Maintenance SIM was created of web-based system, bringing linkage with various monitoring systems, including the measuring instruments, into perspective. The 3D models use the 3JS of web graphic libraries and has a user interface which is capable of integrally manage the SIM models for the design and construction stage, as in the case of the construction SIM system. It is believed that the developed system is capable of establishing the situation of various facilities and quickly responding to abnormalities at the operation and maintenance stage by means of combining measured data. From here, I show the utilization situation of the construction SIM system regarding such representative types of dam body work as embankment work, interior settlement, and foundation treatment. First, it is embankment work. Figure 11 shows the progress of the embankment work in the chronological order. Embankment body under the construction is shown in a 3D model, and it gradually piles up. Figure 12 is a graph showing the measurement results of the compaction degree in elevation over a time series. These measurement results are stored as attribute information of the model, and necessary information can be efficiently extracted. Next, it is embedded instrument. Various instruments are installed inside the dam body and have been conducting various observations since the construction stage. Figure 13 shows the modeling of the measured values of the different settlements. The graphs are semi-3D models, and vertical line shows elevation and horizontal line shows settlement. They can assist understanding of three-dimensional behavior, such as change of the settlement volume corresponding to the progress of the embankment work. More detailed numerical data can be checked using attribute information. In this way, it is possible to grasp the relationship among the obtained observation result using the sim as the starting point. Next is a foundation treatment. The results of the foundation treatment were created as a cylindrical model shown as figure 14. The region value is classified by color, with red being high water permeability and blue being low water permeability. The cement injection amount is classified by diameter, and the larger the diameter, the larger the injection amount. For the 3D model of foundation treatment, the region value and injection cement volume as grouting data are directly attached as attribute information, while photographs of the core, cement injection chart, and permeability test results are provided as linked attribute information. Grouting data was imported into SIM as the construction progress and used as a database. It was used to evaluate the hydrological structure and contributed to the efficiency of operations. Figure 15 shows us extraction results based on number of operations. From first operation to fourth operation, it is easy to confirm that the ground has been improved by the foundation treatment, and the area with high water permeability has been reduced. Figure 16 reports the curtain grouting result on the geological cross-section. The information on local geology at the design stage consists of the geological class, rock class, and region value. They can be easily switched on the models or shown in parallel by sliding their positions. These figures can be used as tools for information sharing and discussing among relevant people. From here, I say about operation plan of SIM for maintenance. At the Koishiwara Dam, we measure various situations of dam. For example, it is GPS system for measure the deformation of the dam body and borefall inclinometer for measure the landslide behavior of the reservoir. The maintenance SIM system developed is capable of integrating the measured data and displaying it in the form of graphs. Information of the position of each equipment using the 3D model and mutual checking of the graph for various measuring instruments make it easier to understand the three-dimensional behavior and relationship among the various sets of data. Figure 17 shows the GPS observation point on the slope of the dam site. In addition to graph display, information on history management can be obtained from the maintenance sim system, so that this information can be easily compared with the patrol records. It can be expected that the entire picture of the phenomena obtained from the measured and monitoring data can be efficiently evaluated by means of utilizing and combining the various functions. It is conclusions. In the Koishihara Dam construction project, the introduction effects of SIM were as follows. 1. By creating a 3D model of the design drawings, it was possible to easily grasp in the interference of structures that was understood with difficulty in the past, and it was possible to review the design and reflect its construction plan. 2. By presenting the completed image in a 3D model, consensus building among the relevant people proceeded smoothly. 3. By saving the attribute information at the time of construction as an external reference linked to the model, the extraction of necessary data was made more efficient. In addition, in the basic processing specific conditions can be selected by directly adding attribute information to the construction performance model, which has been useful for evaluating construction results. 4. At the maintenance stage, the history of dam and slope measurement and patrol records were consolidated into a sim-based system, make it easier to grasp the condition of the dam. It is finished. Thank you for your attention.
Hello, Rakesh sir. Hello, Rakesh sir. Please share your screen.
Hello.
Yes, sir.
I'm audible?
Yes, sir. Yes, sir.
Okay. Respected Chairman and friends, I am Rakesh Kumar Khali, Group Project Manager, Hindustan Construction, Mumbai, India. I am presenting a paper on Ranganadi Dam, a success story of foolproof planning and speedy construction. Introduction of the project. Ranganadi Dam project was a rare success story applying rarest kind of innovative experiments and most creative managerial maneuvers to make it an exceptional success. The project site known as Zero is connected only by road and has no other train or air communication. The road to project crosses NH52. The village housing the project is known as Yajali. Framework, the only rail and air connection is at North Lakhimpur, a city located in. The following structures were constructed in the first at the crop, concrete of geology, the project area lies Valley and Archean beyond. The Gonda, which is thrusted over the Archeans, forms the rock composition of shales, sandstone, and acid phyllites intersected with respective coal bands at places. The Shivalik comprises sandstone with dry bands, whereas the Archean system comprises mainly gneisses and schist. The rock cover over the dam foundation is mainly of shale and sandstone. This is the geology pictorial view. The construction planning, the quantum of work involved was huge and to be completed in a time-bound manner with an effective method of construction of coffer dam, excavation, production, and placing of concrete had to be thought of and meticulously planned. As the work had to be carried out on both the banks, it was decided to opt CKS 170 excavator and 25-ton tippers for carrying out 9,52,000 cubic meter of excavation. The entire establishment, including the crushing plant, batching plant, cableway, was planned to be set up at the left bank. The crushing plant, inclusive of primary, secondary, and tertiary crushers, and sand units for producing the maximum 1200 meter cube per day, was established to meet the maximum concrete requirement. For transporting and placing the concrete, it was decided to mobilize 10-ton and 13-ton cableways for the main blocks and Elba Kaser tower crane for the portion beyond the cableway range, pouring concrete into the overflow bucket portion. Coffer dam, for excavation job, the river has to be diverted through a tunnel. The coffer dam across the river has to be constructed between the upstream of the main dam and downstream of the diversion tunnel. Diversion arrangement have to be made in advance of the construction activity. For the coffer dam at Ranganadi, the contractor had to pledge and tenders in a lump sum basis, and there already existed on its left bank a diversion tunnel of 6.8 meter diameter, 254 meter long, and 225 cumex capacity. The condition was that the contractor would submit its design in accordance with the submission made in the tender. The design would be approved by the client, and only then the coffer dam will be constructed. The contractor was to be held responsible for safety and maintenance of cofferdams at his own cost throughout the construction period. This proposal was that the cofferdam upstream would be 22-meter high with a crest of elevation 542 with a foundation of 13-meter, and downstream would be 11-meter high with a crest of 536. And design flood was 1800 cumex, and the actual observed was 1640 cumex. Actual construction, the proposal was submitted for a concrete cofferdam. While excavating the foundation and upstream cofferdam, very large boulders mixed with riverbed material were found existing. It was the time consuming and costly to remove them up to the depth of 12 meters before reaching the sound rock level. While excavating, care was taken not to disturb the underlying material. The cofferdam design was cross-checked against the sliding, crushing at toe, and tension at heel. Additionally, rock anchoring of 25 mm dia bars, 2 meter center to center provided. Hydraulic profile of the cofferdam was designed as envisaged to pass the flood discharge of 1800 cumex. Just see the third picture. Here we have coal grouted the river bed without disturbing the boulders. And the second, this is under construction, and the final completed view of the cofferdam here. Advantages of this innovation: the problem of seepage through the foundation, as the cofferdam was not founded on the rock but on boulders, was tackled by providing extensive groutings, cement and bentonite near the upstream face of the cofferdam. It was ensured that beyond the toe of the dam, there was no exposure of material on which the dam was founded by providing the concrete apron and functioning during the subsequent year. A close observation has been maintained on the scouts in the downstream of the upstream cofferdam despite the passage of high flood 1152 cumex over the cofferdam. There has been no scores on the downstream structure. The top downstream cofferdam was used as road transportation of material during the working season, which has reduced the distance between the two banks of river by 14 kilometers. This is the pictorial view of diversion tunnel as well as cofferdam and then main blocks of the dam. And this was the arrangement made, and we got successful in this. Selection planning and layout of plant. Selection of equipment is to be carried out for the main activities, that is excavation, stone quarry, transportation, crushing of aggregate, collection and transportation of sand, cooling of aggregate, mixing and batching of concrete, placement of concrete, and drilling and grouting. Because the ratio of progress in such projects depends upon the interconnected functioning of equipment, working in series, and any weaker link will hamper the same. Therefore, the success mantra we adopted, that is right capacity of equipment at right location. The next factor determining the capacity of plant and the time available for execution. This time factor is further subdivided into two main stages: time available for excavation and time available for concreting. Excavation of soft soil, river shingle, weathered rock, hard rock has to be done before acceptable foundation is reached. Excavation equipments have to be selected on the following parameter: haul road construction required for hauling of material, depth of excavation, distance of hauling, distance of the dumping yard, approximate quantity under each class of rock. Point 1 and point 2 will decide the number of the road making machines required, and point 3 will decide the number of transport vehicle are required as per excavator. The Ranganadi concrete diversion dam, the excavation required was 9,52,000 cubic meter with the following breakup: Soft soil was 4,03,218 cubic meter. Hard soil at 3,37,352 cubic meter, and river singles 49,230 cubic meter. Weathered rock around 1,45,037 cubic meter, and hard rock was only 33,179 cubic meter. Quarrying of stone and transportation. Control and management of raw material is central to dam construction. Completion of Ranganadi Dam, concreting was planned with the peak pouring requirement quantity of 22,000 cubic meter per month. The quarries at 3-4 locations were identified and developed approximately 4 kilometer distance from the dam servicing plant. Around 1,000 cubic meter of serviceable boulders were to be quarried and transported to 4 kilometer distance a day. To produce 1,000 cubic meter of serviceable boulder, 4 500 CFM compressors were installed. Drilling was done by jackhammers and wagon drills. The drilling activities were done mainly during night hours. Crushing of aggregate. 2 numbers of crushing plant of 150 ton per hour capacity and 50 ton per hour capacity were installed to produce the required quantity of aggregate. The sizes required were 150, 80 mm, 40 mm and 20 mm down. Crushing was done with the help of crushing plant 1. Primary crushers 2 numbers, secondary crusher 2 numbers, tertiary crushers, major Marshall, roller crusher and apron feeder that was installed, and crushing plant 2, 50 ton per hour, Marshall Marathon 1, Marshall Magna and 2, and triple deck scene 1, apron feeder 1. This is the layout of crushing plant and batching plant, and block location also shown. So this was a typical layout, and this was installed at site. Very limited space was available, and this sketch shows the crushing plant, batching plant, cement go down and cableway details. This is the other view of crushing plant. Collection and transportation of sand fine aggregate. A large quantity of sand is required for construction of dam. Invariably, natural sand is not available in required quantity. It is therefore necessary to go in for crushed sand. For Ranganadi Dam, both natural sand and crushed sand were used. Natural sand was collected from the riverbed from various sand collection locations. The distance of these locations varied from 5 to 30 kilometers. Natural sand was collected from the midstream of riverbed and shifted to the bank and loaded on dumpers. The loaded dumpers carried the sand to sand hopper, where it was screened and then stored in sand bins with the help of conveyors. For production of crushed sand, for supplementary natural sand, one major Marshall crusher was installed to crush the boulders of 200 mm to 40 mm down. This was fed to a sand mill of BHS make. With this arrangement, it was possible to produce around 20 cubic meter per hour sand, that is approximately 320 cubic meter per day. Cooling of concrete at Ranganadi, the atmospheric temperature rises as high as 40 degree during the March to June. A placement temperature of 12 degrees centigrade, later changed to 18 degree, was laid down in the contract. A chilling plant of 150 TR capacity was installed, and chilled water used in the production of concrete in addition to ice flake to maintain the placement temperature. Pre-cooling of concrete was done from March to June. The chilling plant was operated when the ambient temperature rose to 35 degrees centigrade. Water was cooled 40 degrees centigrade and then used for concrete. By the time concrete was placed in the location, the temperature had gone down to 18 degrees centigrade. Mixing and batching of concrete. It was essential that batching plant of a large capacity were installed to meet out the need of progress required per day per month. Batching plant had to be handled a 150 mm aggregate size. Different design mixes grades of concrete were stored in the memory of batching plant control. These mixes could be recalled, batched, and mixed as and when required, depending upon the location of the concrete pour.
Sorry to interrupt, Mr. Rakesh. I request you that if you can come quickly to the conclusion, because we are already 5:20 and there is another session slated. So it's requested to you to quickly cover the points, sir.
Another thing, this is rotation and placement was also done with the help of 13-ton and 10-ton cableway, and one LBAC asset tower crane was also erected earlier also, and 22,000 cubic meter concrete we have poured consecutive months, and average concrete pouring was 18,000 cubic meter per month. This is the cross section of the Ranganadi Dam and Telka. Shuttering, the upstream and downstream shutters were used. Vibration and green cutting also done. Communication between this was very important, between the cableway operator and the main office and other locations. Quality control, special care was taken regarding quality aspect. A well-equipped and sophisticated laboratory was established. Each batch of concrete material was tested. Frequent inspection of for consistent homogeneous quality mixes were done. OK cards being issued before the pour and after inspecting and testing. Health and safety care was taken for PPE and project activity information, hazard mitigation measures, safe working procedures, basic safety rules, and all other things. So there was no any accident observed during concrete pouring. Conclusion, the challenges accepted during the construction of the project were working at remotest location of a remotest state where communication local and national was the first priority for this purpose. Comprehensive VSAT communication was established. These sets were used not only for the telephone, but also for e-communication like fax and email. Wireless sets were used for internal communication, and every ready vehicles for road communications. A dedicated team of engineers and workers was put together, which was committed working day and night and succeeded the completion of work in time. The management of material needed to be supplied and put in order so that work could not stop. Well, provided medical care, bonus, insurance, and any eventuality rising in their families. So, and the following is the crux of the experience and experiment done and derived through this project: proper planning and accurate layout, simultaneous execution of job, availability of raw material, timely construction of waterways over the coffer dam, a scientific human resource management and their safety from work hazards. Thank you for your kind attention.
Hello, Rajiv sir.
Hello. Yeah, it's over.
Okay, sir. Hello, Rajiv sir.
Hello.
Hello, sir.
Hello.
Yes, sir.
Yeah.
Hello, next presenter, please share your screen. Sir, DK sir, hello. Hello, DK sir. Hello, DK sir.
Yeah, host, it seems there is some problem with the sharing of the screen. How many presenters are left now, sir? Because we have to adhere to the time also, because the valedictory session is also slated subsequently.
Yes, sir. Second last presenter Rajiv Bishnoi and last Dhirendra Singh.
So is there any problem connecting?
Sir, I don't have any idea, but not for response.
And who is the last one?
Sir, Rajiv Bishnoi.
Okay.
Sir, you tell me. You call me for Rajiv, sir?
Bishnoi sahab. I think there is some. Yeah, host, do you have sir's number? You can check up whether he is able to, hear. Or otherwise, we can request the last one in the meantime.
Good evening, sir. I am Ajay Kumar, and my presentation already uploaded. That is the last presentation of this session.
Yeah, Mr. Ajay Kumar, if I may request you that, if you can quickly go through, because there is a valedictory session and we are already around 5:20. So my request would be to quickly cover the points, sir, if you can.
Sir, I have already sent the video. You can run this. And if there is any problem, then I will run from here.
Okay. So host, please run the video of Mr. Ajay Kumar.
Sir, I have already PPT, not video.
You
No
don't have.
problem. I will run from here.
Sir, you share, please.
हो गया मैडम?
Now it's okay, sir?
Sir, please share.
Yes, I have shared. Is it okay?
No, sir, no, I no see your PPT and video.
Just a minute.
Yes, sir. Yes, sir, shared.
Good evening, everybody. I am Ajay Kumar, working as CM Geology with TDC India Limited. Today, I am going to share our experiences that we gathered during the construction of our one large adit, that is a TBM entry adit. And title of our presentation is an innovative approach for construction of large adit through river borne material at Vishnugarh People Koti project, 444 megawatt, Uttarakhand in India. This is our salient feature of the project. We are going to construct one concrete gravity dam of 65-meter high, and there are 3 number of desalting chambers, one HRT with the length of 13.4 kilometer. Out of this 13.4 kilometer length, 12 kilometer shall be excavated by TBM and rest by drilling and blasting method. And other features are a precision shaft, underground powerhouse, and tailless tunnel. This is location of our TBM platform area. Yes, sir.
Your slides are not moving. It's only the first slide which is visible. Yeah, now it is moving. Yeah.
Is it okay, sir?
Now it's okay.
Okay. This is our location. Here we have planned to construct our TBM entry adit, and these areas are for this TBM platform. And alignment is from inside the hill for the HRT. This is our layout plan. This is our TBM entry adit, and this is our HRT alignment. This adit length is 632 meter, and portal of this adit is here. The main reason is choosing this topic is that we have constructed this adit for the 55-meter length in the RBM material. And geology of the project area. The project is located in the tectonic window known as People Koti window, exposing lesser Himalaya meta-sedimentary rock enveloped by low to medium grade metamorphic rocks of higher Himalaya. The rocks of window zone are grouped under the Garhwal group, represented by low grade quadratic sandstone, dolomitic limestone, and slates with metabasic sandite. Adit to TBM is located on river terrace at the right bank of Alaknanda river, just upstream of Hatsai Nala at elevation 1152 meter. The TBM platform and slope above the TBM platform are covered with huge deposit of RBM and slope pass materials. The RBM is generally showing graded material consisting silt to boulders of few mm to 2 meter in dimension. Most of the upper surface of the slope pass material had hardened due to calcareous solution activity. The calcareous leaching from upper reaches of dolomitic limestone solidifies the upper surface of the debris or RBM and it shows pseudo rock behavior. Thus, it is termed as consolidated RBM. There is no rock mass exposed in the TBM platform area. Rocks are exposed in the adjacent Nalaj area, which is almost 200 meters away from the portal of TBM entry adit. This is our geological map, and this is the alignment of TBM entry adit. This yellow one is the RBM material and slope pass material, and we can see that no rock is exposed in the near of this portal, and rock is exposed in the form of slate and dolomite in this blue color here. That is 200 meters from this side, and here it is 300 meters from this side. This is geological section of this adit, and we have constructed up to this length, and that is for the launching of our TBM chamber. That is up to 55 meter, and total length of adit is 632 meter, and rock is supposed to be encountered at 270 meter. And the upper material is consolidated RBM, and this is RBM with big boulders. And another features we got during our excavation here, that is silt and sandy layer. That is the most critical in this adit. And below this is the
Sir, sorry to interrupt you. Slides are not changing.
Now it's okay?
Yes, yes.
Then I will go in this mode, sir. This is location for the our TBM platform. Here we can see that this is the river trace where TBM entry plant. This is actual view of the material in the area, and here is the center line of the proposed TBM entry. This picture is the earlier one with the big boulder we can see here that has been accumulated during the construction of a bench change for the slope and TBM portal. This is morphometry of our slope behind the TBM entry edit portal, and upper one is the consolidated RBM. In between this is a RB, and lower at lower elevation it's a sandy silt layer which goes up to the full face of the tunnel, up to overt of the tunnel at RD around 42 meter. This is the portal area of the tunnel. We have conducted some seismic reflection survey here, and this is the along the TBM entry edit, and this is in the area of TBM platform. And through this investigation, we got the data that we are going to get a weathered rock and a jointed layer and hard rock at certain depth. But due to the consolidated behavior of the RBM material, this information was not correct at site, and we didn't get this data at expected depth. This is our displacement contour, that is after excavation of the full face of the TBM entry edit. And this is the methodology of our TBM entry edit. It was a plan to excavate in the 3 phases. The first phase was at the stage 1 heading, second phase was stage 2 benching, and third was the invert benching. This is a slope treatment that we have obtained during our slope above the portal and surrounding area. And after that, we have some different support system that is shown in this slide. And here we can see that the main tunnel is supported with the help of fourpolling SDA, SFRS, lattice girder, phase stabilization with the help of SDA, and SFRS with the invert blocking with the help of SFRS. This is our treatment in progress here.
Sir, I request, can you quickly cover and come to the conclusions?
Yes, sir, yes, sir. These are the fourpolling that we have done in our project here. That was the main feature, and this is the drill bits. And through these are the phase that we get during our excavation, and these are the stabilized phase here we can see, and the fourpolling also. And these are the geological logs of the area. We also got a lot of silt and water seepage during monsoon. This is the silt, and slope was stable, fully stable during the construction of our tunnel up to depth of length of 55 meter. And this was the benching that we did. And this is also invert closure with the benching. And this is our final output that we constructed our launching chamber for the TBM entry edit in RBM. And that is the last slide of this presentation. Thank you, sir.
Thank you, sir. Host, can you confirm, is there anybody left now?
Yes, sir. Yes, sir.
I think.
Yes, this is Rajiv Bishnoi. I also have one presentation. If time permits, I can quickly cover in 5 minutes.
Sure, sir. Sure.
Okay. Very good evening, everyone. And this presentation relates to, in fact, one of the slope stability problem which we faced at one of our project. And this, let me just share my presentation first. Okay, is it visible now?
Yes, sir. Yes, sir.
Okay, so this slope stability problem, it relates to one of the right bank of our project, potential project. In fact, when we were doing the excavation work of both the abutments at this concrete dam site, what we observed when we started the excavation from the top, we observed the heterogeneous kind of formations in the right bank. And as we were going down, excavating the material in the designed slopes and benches, there was a big landslide which took place, and that really stopped all the work there in the dam at the dam site. So then what we saw was that though the rock mass in segments which appear to be very quite competent, but then the structures were such that as soon as we were disturbing the surrounding strata or the surrounding rock mass, it was igniting it was triggering the movement in the adjacent rock mass segments. So we try to look at this problem differently, because if the reach of the abutment was something like 400-meter long and 300-meter high, so approximately it was 10,000 square meter area which was to be treated, and if you try to adopt any kind of primary support, it would have been extremely costly if you take a regular pattern of the cable anchors or the deep rock bolts, and across the board you take it in a designed spacing. So what we decided was to immediately model the entire abutment, both the abutments, and put the dam also in place, just to look at the or the understand the stability of the slopes post construction of dam. And post construction of dam, how the displacement would look like. So we created a model, finite element model of the entire valley, and then without dam, what was the displacement? With dam, we tried to understand the displacement. We simulated the entire geological features, and then the design cut slopes and the benches also were modeled there in the model. And then we found out the contours of the displacement along the valley, at different heights. And then we identified pockets where the displacements were more because of a particular or peculiar geological formation. So what we decided that time, if you can understand, this is the model, this was done on 3DAC. And I will just take you to this slide. If this slide is visible to all the participants, there is a red zone here. This red zone was basically the zone where we were getting the maximum displacements. And these displacements were beyond the acceptable limits. So we identified all such red zones in the area. And there we went for the selective anchoring, cable anchoring, and the bundled anchoring. So in a way, we just try to, rather than putting the cable anchors or the bundled anchors across the board in all the areas, we selected these areas and we were selecting the high displacement zones only, and we provided the cable anchors and the bundled anchors also. So when I say bundled anchors, it is a different type of anchor. The kind of slide I'm displaying here is a sort of a inclined pile, where we had almost 10 inches, varying from 8 inches to 10 inches diameter holes. And then inside those holes, we were having 4 bars steel bars, and then there were rings there which were keeping the bars secured in the entire length of the anchor. And this is how we created, pile-like structures at those selective locations. And then with such arrangement, we again simulated on the model that if you provide this, then what would be the displacement? We found out the displacement came within the limit. Now this is how these bundled anchors were put there. You can see in the photograph also the laborers, they're trying to push a bundled anchor inside the hole. And so these are some kind of horizontal or slightly inclined piles in the slope. And this is how we could restrict or we could contain the movement and the displacement at those red locations, the locations which are given as red by the software. And today, after 11 years, this slope is performing very well. We reduced the cost of the treatment to something like 35% of what it could have been in case we would have given the across the board kind of a solution, which normally is a conventional method, a conventional way of stabilizing the slope. So this is how the right bank of the project looks like today, well stabilized, very beautifully done. And now it's after 11 years also, it is not showing any displacement of any kind. And we could complete the project, and then our project has been operating successfully without any difficulty. So what I'm trying to say here is that we can take advantage of the technology and particularly the software tools which are available. And if you do the modeling right, if you are able to simulate the the properties of the surrounding strata and the structures which are going to come there, and then trying to if you try to analyze the scenarios in an effective and more efficient way, you will be in a position to get the outcome very correctly. And then you should try to take advantage of this in bringing the cost of the support system down, and that would save a lot of stabilization cost to the project. So this is the conclusion, and we have very successfully done this. Thank you. Thank you very much.
Thank you, sir. And it has been really very interesting and very informative session. We had a number of good papers today, and I sincerely thank all the panelists for sharing their experiences, their insights. The finding of the paper will go along to help formulating the guidelines, the framework for the areas of for dam safety and also sustainable development of dams as a whole. So I thank all the panelists, all the delegates who have joined for this wonderful and meaningful session. And thank you so much. And with that, we can conclude this session. Thank you.
Thank you, sir. Thank you.
Thank you, Mr. Amitabh.
I would request the organizers to please start with valedictory session.
We may go live now for the valedictory session. I request for the valedictory session, I request everybody, Mr. D.K. Sharma, Vice President Icold, Mr. A.B. Pandya, Chairman of the Technical Committee. I could see that Michael Roger is online, so I request also Michael Roger also to join us for the valedictory session.
Mr. Michael Rogers started right on time, but since this session got extended, he joined 10 minutes before it, and he has sent me a message also, but I'm afraid that I sent him a message, but I'm afraid that he may be slightly
But I could see that he is still online.
He is online, yes. That's correct.
I'm here.
Oh, yes. Very good. Wonderful.
Then I request Dr. R.K. Gupta, Mr. A.K. Singh, Vice President in Code, Dr. R.K. Gupta, Vice President in Code, Mr. Prakash Mahaske, President CBIP and Chairperson Central Electricity Authority.
नहीं मंगला करके है ना कोई.
All are in place, please.
Yes.
Hello.
Dr. Gupta, are you around? I can't see Dr. Gupta. Rest all people are here. Should we start?
Yes, sir. So I request Mr. D.K. Sharma, Vice President Icold, to deliver welcome address for the valedictory session.
President, I would request others to please unmute their microphones. Please mute their microphones. I called President, Mr. Michael Rogers, Shri P.S. Mahaske ji, President CBIP, Chairperson Central Electricity Authority, Shri A.B. Pandya ji, Shri A.K. Singh ji, Shri R.K. Gupta ji, Shri Vishnoi ji, Shri A.K. Dinkar, Secretary General CBIP. On behalf of Icold and Icold, it's my proud privilege to welcome you all to the valedictory session of the Icold Symposium on Sustainable Development of Dams and River Basins and Asia Pacific Group Symposium on Water and Dams. As we are aware, after air, water is the second most essential thing for survival. Water resources are not evenly distributed. Rivers carry water from mountains to the plains and are great gift of nature to mankind. Managing rivers through dams is a challenging task, which, as per Indian mythology, we have Vishwakarma, and I would say modern Vishwakarmas, that is the engineers, they perform this challenging task very well. All engineers managing dams have great responsibility towards society, and they have to live up to the trust which society has posed in them. Whether it is construction of a dam, whether it is dam safety, whether it is correct operation and maintenance of a dam, it is our responsibility to live up to the trust of common man and the society. Engineers have more challenging assignment at hand at the moment because of the climate change and these extreme events. Extreme events are so unpredictable, so uncertain, that we need to be managing our resources, managing our dams with modern tools and with utmost care. Coming to the symposium, I would say we have had 31 sessions, which include one plenary session and two special sessions, one on innovative financing of dams, which was mainly conducted by professionals from the World Bank, then geosynthetics in dam engineering, and in addition to these, we had 28 sessions. Tomorrow we will have 7 workshops going in parallel, and I'm so happy that in these workshops, topmost participants of the world would be delivering lectures on the relevant topics. In this symposium, we had 1,500 participants, more than rather more than 1,500 participants from 104 countries. I'm very happy to share with you all that yesterday during Young Engineers Forum, 323 participants were connected, which is such a great success, astounding success to my mind. And virtually having so many people connected and listening to what we were doing, and also we were enlightened by the lectures which were delivered by young professionals. I would also like to add here that from Icold side, we yesterday told that the events of Icold for young professionals, will try to make them without any fee, and they would be welcome to participate in the future events of Icold without the Indian professionals, without paying any fee. I would also like to say that unfortunately this symposium we could not hold physically, but I promise to our international delegates that during Icold 2023 event to be held physically in New Delhi, Indian National Committee will organize an excellent memorable program and study tour to our dams and other tourist attractions in India. With this, I look forward to welcome our Icold family, our friends, Icold members, the accompanying persons, to be meeting all of them in New Delhi and welcoming them in New Delhi in 2023. And I, in the end, would like to thank each and everyone for putting in their best for the astounding success of this symposium. Thank you so very much.
Thank you very much. Thank you very much, sir.
Thank you very much.
May I now invite Mr. A.B. Pandya, Chairman of the Technical Committee and Secretary General of ICID, to present an overview of the symposium.
Thank you. Thank you, Sunil. And it's my pleasure to present you with a brief outcome of various sessions that we conducted during the symposium. Let me start formally. Dr. D.K. Sharma ji, the President Icold, has just given his valedictory address, and we are very happy to note that Dr. Mike Rogers, President Icold, has also been able to join us in this valedictory session in spite of his odd hours. And we also have the fortune of having Mr. Maske, Chairperson CEA, and President CBIP, Dr. R.K. Gupta, Mr. A.K. Vishnoi, Mr. A.K. Singh, Mr. R.K. Vishnoi, and others who are all here to participate in this valedictory function. As far as the recommendations are concerned, because as we know that the most of the sessions ended up spending a lot of time, and we had a serious time overrun even today. So not all the sessions could provide us with their conclusions, but in all, we can say that we had about 28 technical sessions which covered all aspects of dam building, management and rehabilitation, and now it will be followed by the 7 workshops on the specialized topics. We had a very wide range of topics that we had covered. I will try to put in this by sharing the screen. So we had a very good session. We had the engineering challenges and safety aspects of tailings dams. Of late, we are all aware about the catastrophic failure of a tailing dam in Brazil, and that has focused the very important issue of the safety of the tailings dam. And it has the session focused on the challenges of tailing dams and how to keep them safe with other failures which were not as catastrophic. The key papers focused on understanding of tailing dams breach modeling and tremendous advances in technology that allow for greater efficiency in surveillance, monitoring, inspections, etc. We had another session on modern technologies in survey and investigation for sustainable dam development. This is a very important session, especially in the areas where we are going in for the first time for developing the dams or reservoirs. And here the role of geophysical investigations for providing us with a quick and a global information was highlighted. The geophysical investigations provide a variable information, especially in the dam safety area. Also, this information becomes quite valuable. The vibration monitoring, it has a significant role in the aging phenomena and fatigue of concrete dams. The vibrations also have a very significant role to play in the hydromechanical structures where their safety and their soundness is to be ascertained. We had a special session on use of geosynthetics in dam engineering. Once again, geosynthetics is a very vital material for the earth and rockfill dams, as well as for stabilization of the slopes and various other applications that are there with the geosynthetics. And this has been highlighted that these geosynthetics have a very strong role to play, especially in the rehabilitation, where we have to prevent the seepage through the dam, or where we have to stabilize the slopes with limited amount of space available. The conventional techniques are also there for the stabilization, but then the geosynthetics provides us with the special situations in which we are able to manage the activity. We had a session, 2 sessions on river basin management. In fact, the one session, part 1, that was covered by me. It had 8 papers in all, and it covered diverse topics about the forecasting of flows, the rehabilitation and basin management aspects, and even the sedimentation aspects. It was found that it is necessary to manage the river basin development as a focused exercise, and revenue models for operating the systems are necessary, but they should not become an end in itself. This actually obviates the kind of displaces the need for managing the water resources in the basin, because the water resources per se are not able to bring in as much revenue as let us say generation of the power and various other issues, industrial water, etc. is concerned. But if we don't manage the water well, then the basic purpose of developing of the river basin organization or a dam management organization gets defeated. Forecasting is a very important exercise in the real time and also in the planning of the river basin modeling. And in these areas, the forecasting technologies are developing very fast. There are issues like there are developments like artificial neural networks and various other similar techniques which are quite good for forecasting, and they need to be developed and integrated in our day-to-day use, which can even optimize and improve our hydropower. The structural measures, even though reviled a lot in many of the areas, do have a vital role in cooperation from the local communities in managing and maintaining these structural measures like embankments and retaining walls, etc. forms a very, very important part of floodplain management in the river basins. And this flood management has to be viewed very seriously, especially when the basin is developing and a lot of human and various other economic development is taking place in the near vicinity or even in the floodplains of the rivers. The very interesting aspect of the Austrian paper, which showed that after a point of time, the dam itself becomes an environmentally important facility. And then the protection of the habitats considerations come in the way of rehabilitation of all developments. So this is a very interesting kind of a development in which we can say that when the dam itself, which is being reviled in the initial stages as environmentally dangerous, actually ends up becoming helping the environment by creating certain habitats. So this is an area that we need to really look at from the point of view of the sustainability of the dams. The River Basin Management Part 2 had interesting discussions regarding analysis and management of water resources and sediments, development, organization and planning of the basin level. The sedimentation is a very important aspect in the river basin management, because with great difficulty we are able to create the storage facilities, and then if these storage facilities erode their capacities over the period of time, then it becomes very difficult for us to create new capacities with the kind of pressure on the land and resources that we have. We need to really seriously look at the technologies and approaches that are available for managing the sediments, especially in the tropical countries like India. The use of technology and numerical models, and inevitably the use of scale models in observation methodology, and it continue to be essential, and very important conclusions can be drawn from the scale models, and if they are integrated with the numerical models, then the overall outcome becomes quite satisfactory and quite useful. We had another session on advances in dam safety, risk assessment and management. Dam safety is the prerequisite, and there are advances in dam safety and risk assessment, and new developments are welcome. But it is more important that dam safety authorities, dam owners and developers and all in charge of maintenance follow the existing international guidelines, which must be applied to new and existing dams. Emergency action plans are a very important component, because at any time a dam has to not necessarily breach, but even when it normally releases the water and with the encroachments in the valley, the emergency action plans for even various lower level floods also become important for the management of the disaster. And for the safety assessment of dam, all possible hazards needs to be addressed. We cannot really overemphasize on one hazard and neglect the other hazard. So especially the hydrology and the earthquake, both floods and earthquakes are the crucial hazards which have to be understood and made into a appropriate part of the rehabilitation exercise. The importance of the DRIP guideline on the risk management and great contribution is expected from India in pushing forward the risk analysis and risk governance, because we are a very population intensive country. We have very great pressures on our land for the habitation and for the agriculture and all various other areas, and there the risk assessment guidelines that are available for sparsely populated countries will have to be suitably modified in order to have those guidelines which can be valued for the developing countries. The seismic mapping and microzonation, etc., and identifying various seismogenic features is a very important exercise, and that needs to be done continuously, because not adequate attention can be paid in a short period of time during which the investigations are taking place, and after a long period of time we need to really work with the seismotectonic phenomena that is affecting the site. The impact of aging, climate change and retirement risk in dam safety programs, items that need to be carefully monitored, and the value of pilot cases for addressing the challenge is very important. APRC is undertaking shifting hydropower industry towards risk-informed dam safety in the US, and we may also have to look at this in view of the limited financial resources that will be available for increasingly the larger population of the aging dams. And use of stochastic simulations in the context of risk analysis is also important, because not all positions, all situations can be visualized in a real manner, and not with the simple deterministic numerical models. These are some of the recommendations that we got, and we hope that all the other authors and other contributors will be able to provide us with their recommendations, so that we are able to get them in time and then carry out the final symposium recommendations across to all the community of Icold and world in general. Thank you very much for giving the opportunity of becoming the part of the symposium, and it was a great experience of finding so much expertise and so much interest all through the symposium by all the participants. Thank you very much.
Thank you, Mr. Pandya, for giving an overview of all the sessions and recommendations emerged during the discussions. May I now invite Michael Roser, President, International Commission on Large Dam, to share your views. Mr. Michael Roser?
Yes. Hello, my friends. It's good to see you again, even virtually. It was an honor for me to participate in this conference and especially this valedictory session. Congratulations on a very successful symposium. I was able to attend several sessions and I was very impressed. These have been very difficult conditions to conduct such an important conference. I compliment the perseverance of Icold and the organizing committee to make this symposium a success. I know it was very, very difficult over a very long period of time. And I know it's not finished yet. I know there are workshops tomorrow, and I look forward to participating in those, even in my my own presentation as part of the RCC workshop tomorrow. Icold, as an organization, we must all remain committed that our dams that we have in the world and our levees are designed, built, operated, maintained in safe, efficient, economic manners. So only then can we ensure environmental sustainability, socially equitable development of our planet's natural resources. The work that the participants have done in this conference, and especially the work that's being done on the world-class DRIP program, allows Icold, and in fact all the nations that we support and represent, to prepare to meet the challenges of the 21st century. And I strongly support what India is doing with the DRIP program, and especially the new national regulations in India for dam safety. So on behalf of Icold, I have been honored and thankful to be here with you for this meeting. I congratulate you on the success of the endeavors of this symposium. I continue to pray for the health and the safety of all of our Icold families around the world. And I look forward to seeing you all in person sometime soon. I hope this year in Marseille at our Icold Congress, and certainly in 2023 back in New Delhi. So take care, my friends. Be safe and be healthy. Goodbye.
Thank you, Michael, for sharing your views. May I now invite Mr. Bishnoi, who is Vice President of Icold and Director Technical THDC, to share your views.
Okay, thank you, Sunil. Very respected Mr. Mike Rogers, who is connected virtually to this event. Mr. D.K. Sharma, the Vice President of Icold and the President. Mr. A.K. Singh, the Vice President of Icold and the Chairman Managing Director of NHPC. And Dr. R.K. Gupta, Vice President of Icold and Member Central Water Commission. Mr. A.B. Pandya, Chairman of ICID. And ladies and gentlemen, this is a valedictory function, and we have come to the close of this highly successful symposium, as Mike Rogers just put it. It's a matter of great privilege for me to be here at this valedictory function today for an international event which has been organized so successfully by Icold, and also to share my thoughts on an issue of significant global importance. We all know that India's engagement with the dams is historical, as Mr. D.K. Sharma also put up. He also gave some mythological reference to it. We have civilization links also with the dam construction. We started this journey in India in a big way in 1950s. We speeded up further in the 1970s and 1980s. But today, as Mike Rogers just put in, that We are in 21st century, and 21st century world is an increasingly globalized and interdependent world. The last decade, as we all know, has thrown up many challenges, global challenges, which are in respect of climate change, water security, food security, and lately the energy security as well. And these challenges are, we all know that these are transnational in nature, and it all requires a concerted global response for effective resolution of all these challenges. We all know that these challenges are intertwined, and our responses to each one of them have a bearing on the other. So on this occasion, I would like to urge my fellow professionals around the world to respond to this dynamic situation in a much faster manner. Icold has been doing this very, very effectively in its own way, but we all at our own levels, individual levels, we have the responsibility to now propagate these concerns and the solutions also to the entire fraternity in our respective country. I would also like to mention that our cooperation in Icold need not be confined to dams alone. India has recently gained tremendous experience and expertise over the years in responding to the climate change concerns. Have taken up the extensive program for developing the renewable resources and contribute towards this. We also have committed our INDCs in Paris Agreement. We would be happy to share our experience and technologies with our friends across the world, entire climate change spectrum, to ensure robust partnership also. I believe that collectively Icold shall have a major say in emerging world order. I'm sure that our time-tested programs in Icold shall be transformed into vibrant and robust practices which can be adopted in years to come. Thank you so much for giving me an opportunity to speak at this function. Thank you very much.
Thank you, Mr. Bishnoi. May I now invite Dr. R.K. Gupta, Vice President in Code and Member Design and Research, Central Water Commission, to share his experience.
Thank you, Mr. Sharma. First of all, I would like to congratulate Icold for selecting such a theme for this conference, which is very much relevant in today's context, sustainable development of river basins and dams. And if we look at the theme, sustainable development of river basins and dams is not possible without addressing issues related to dam safety and dam safety management. It's very, very heartening to see that there was a great response from dam community in terms of technical contribution and sharing of experiences on these vital issues related to dam safety management and rehabilitation. It shows that not only our concerns are towards this important area, but also a commitment for adhering to dam safety management and not just dam development. But we have a great responsibility. We have to ensure that sound practices of dam safety management are adopted by all dam owners across the globe to make these hydraulic structures safe and sound for a long time, so that benefits can be utilized by many generations. In India, we started dam safety programs in 90s, and in 2012 we had a bigger program, DRIP phase 1, which is ending this year, and within few months we will be starting phase 2 of this program. This program showed that dam owners are very concerned about dam safety issues, and they are committed to safe operation and maintenance of these dams. Besides working in this direction, what I feel is dam community has to also work for bringing in laws and regulations for dam owners all over the world, which will guarantee safety of these hydraulic structures so that these dams can function for generations. I am thankful to Icold board, all the members of Icold, and entire dam community for making this event successful. And I am thankful to all the Icold and Icold members for giving me opportunity in this valedictory function. Thank you very much.
Thank you, Dr. Gupta, for sharing your views. May I now invite Mr. A.K. Singh, Vice President Icold and CMD NHPC Limited. Mr. Singh, please.
Thank you, Sunil ji. Respected Sri Prakash Maske ji, Chairman CA, Sri Michael Roser, President Icold, Sri D.K. Sharma ji, Vice President Icold, Sri A.B. Pandya ji, Chairman ICID and Technical Committee, Sri R.K. Gupta ji, Member D&R, CWC and Vice President Icold, Sri R.K. Bishnoi ji, Vice President Icold and Director Technical TSDC, Sri A.K. Dinkar ji, Secretary General CBIP. Ladies and gentlemen, it gives me pleasure to be a part of this combined symposium on Icold and the Asia Pacific Group. We are happy that NHPC got the opportunity to be associated with this event, more so as the event was a collaboration of the two leading lights in hydro sector, the Icold and the Asia Pacific Group. There was a great sense of uncertainty regarding Icold 2020 due to pandemic, but hats off to the entire CVIP team and Icold for making it possible, and that too by organizing not one but two mega scale events together. Icing on the cake has been excellent use of virtual platform, which has enabled us to connect to a far wider audience. The two symposium enabled the dam fraternity to interact with the eminent scholars, environmentalists, scientists, professionals, and the policymakers. The symposium have been successful in provided excellent opportunity to showcase and advertise and advantages of the dams to many domains of the society. Dams in general and consequently hydropower have been much criticized since scientific basis are proof. It is therefore necessary to spread awareness about the need to harness the untapped hydro potential in substantial manner from the viewpoint of its three pillars, namely economic, social, and environmental. I have been impressed by the wide array of subjects covered in two symposiums, be it the use of modern technologies in survey and investigation, dam analysis and design, advances in dam safety, repair and rehabilitation technologies to increase life of dam, innovative construction methodologies and contracting practices are reservoir sedimentation management practices. These deliberations have covered whole gamut of dam design and construction and are of particular importance for NHPC, especially in view of our upcoming 2,880 megawatt Dimang multipurpose project, which at 278 meter high shall have the highest RCC dam in the world. What I really like about the symposium is the knowledge and experience sharing it has facilitated recently. We had a flash flood event in Uttarakhand. We also had one such flood in our Nimo Vajgo project. And the experience in handling the same shall be shared in the present symposium. Dams play a critical role in such events, accommodating the and regulating the large inflow, which otherwise would have caused much destruction in the downstream areas. We need to further concentrate on the aspects of dams and make people in general realize the important role this structure play. Today, not only India, rather world as a whole faces the water crisis, which has been aggravated by the climatic changes, and we are witnessing extreme weather conditions. Hydro project can play a bigger role not only in providing the reliable, cheap, and clean power, but also in building water storage capacity of the country to meet drinking water and irrigation needs. It is indeed the need of the hour that we plan and act in a mission mode to ensure each drop of water is stored for hydropower and other uses of water. It is extremely important for all of us to keep our learning process on at all times of our life. I hope dam engineering community across the world would have gained a lot from this symposium and eventually utilize the learning in their career applications. It is also very important for all of us to remain focused on our goals and anticipate the challenges well in advance and be open to modification of construction methodologies so as to have minimum time and cost overrun. Construction business in general and development of hydropower in particular face a lot of challenges during execution, and one need to adopt and innovate during the journey itself. It is essential to accept the limitations and the approach which is not yielding the results. Our ability to resolve critical problems depends on how we adopt and implement new innovations. The outstanding success of the symposium would not have been without the guidance and support of Ministry of Jal Shakti and Ministry of Power. I once again congratulate Team CBIP, Icold, Governing Council, Team ACI Specific Group, the delegates and all the participants for putting up a great show. Symposiums have been a great success in providing platform for sharing of ideas and knowledge for the growth and development of the hydropower. Thank you. Namaskar.
Excellent delivery, sir. Thank you, Mr. Singh. I just make a mention, since you have mentioned about that Diwan project, tomorrow that RCC workshop, specially we arranged for the benefit of NHPC and others.
Thank you.
And all top experts, particularly from the Icold committee dealing with the RCC subject, they will be delivering the lecture. So I request all of NHPC officer to join for that. It will be of great help to them for Diwan project.
Sure, sir. Thank you.
Thank you very much, sir. May I now invite Shri Prakash Mahaske ji, who is the President of CBIP and Chairperson of Central Electricity Authority, to deliver valedictory address. Shri Mahaske ji.
Mahaske Saab, please start. We can't hear you.
Hello. Are you getting my voice?
Yes, we can. Please proceed.
Okay. Thank you. Thank you. Thank you, President Incold and Vice President Icold and Chairman HPRC Sri DK Sharmaji, Mr. Michael Roger, Sri AB Pandya, Sri RK Gupta, Member CWC, senior officers from CWC, Icold, Incold, and CBIP, distinguished dignitaries, delegates, ladies and gentlemen. It is indeed a matter of great pleasure for me to be with you at this valedictory session of the Symposium on Sustainable Development of Dams and Rivers Basin and APG Symposium on Water and Dam being organized by Incold in India. I would like to express my appreciation to organizer Incold for providing such an excellent platform for the experts working in the field of water resources around the world to share their ideas and plan the way forward on the theme sustainable development of dams and river basins. Friends, we know that water, food, and electricity are among the most critical basic requirements for the existence and development of mankind. Large dams have significant role in making available these necessities to the people. India is one of the fastest growing economy as well as one of the largest populated country on this globe. Accordingly, we have huge requirement of food, water, and energy, which is going to increase multifold in future. To meet these requirements and to ensure water, food, and energy security, we look forward towards our rivers for electricity generation and for getting water for multiple uses, including irrigation, drinking, etc. Water is essential for the sustenance of all forms of life on the earth. It is not evenly distributed all over the world, and even its availability at the same location is not uniform over the years. While the parts of the world which are scarce in water are prone to drought, other parts of the world which are abundant in water face a challenging job of optimally managing the available water resources. No doubt the rivers are a great gift of nature and have been playing a significant role in the evolution of various civilizations. Nonetheless, on many occasions, rivers at the time of floods have been playing havoc with the life and property of the people. Therefore, management of river has been one of the most prime issues under consideration. Optimal management of river water resources demands that specific plans which are technically feasible and economically viable should be evolved for various river basins after carrying out extensive surveys. All over the world, the dams and reservoirs play the dual role of harnessing the river water for accelerating socio-economic growth and mitigating the miseries of a large population of the world suffering from the vagaries of flood and drought. To this end, dams have been used since ages for providing storage for drinking water, as well as irrigation, flood control, and water for navigation and recreation, as well as improving water quality, quantity, and generation of electricity. The beginning of the 21st century has seen the world grappling with issues like increased global temperature on account of increased greenhouse gases being released into the atmosphere, and consequently shifted focus on the development of renewable like solar and wind. With increasing global warming and huge peaking and balancing power demand, in light of growing focus on renewable energy, there has been ever-growing interest in hydropower development in the world, and there is renewed thinking about hydro projects, especially the pump storage schemes for producing electricity. For harnessing these potential benefit, dams are to be constructed and safely maintained, for which a large pool of expert manpower is essential. The knowledge and experience sharing in such programs play a vital role in creating awareness about developments in new material, construction technologies, advancement in investigation techniques, based engineering practices, dam safety issues, like etc. I am told that during this symposium, a number of technical papers received from the national and international dam experts has been presented to exchange their experiences and latest developments related to the design, performance, rehabilitation, and environmental aspects of the dams. I understand that the presentation made by eminent water professionals in plenary session, special sessions on innovative financing of the dam project and use of geosynthetic materials in dam engineering, besides the 29 technical sessions conducted during the 3 days, were very interesting and useful. I believe that the relevance and importance of such symposium increases in the wake of rising concern of environmentalists about dam safety. I am sure that this symposium would have provided valuable information, knowledge, and food for thought to the participants. The deliberations on the key topics such as dam safety, river basin development, flood management, and extreme events, tailing dams, life extension and rehabilitation strategies, sedimentation management, and reservoirs seismicity will certainly be beneficial for the global dam community. I once again congratulate Icold for organizing this program successfully on a very apt subject in spite of several concerns due to current pandemic scenario. Thank you all for this symposium. Thank you very much.
Thank you for delivering the valedictory address, sir. Now it is, hello. Thank you for delivering the valedictory address, sir.
Thank you, thank you.
And now it is our proposed duty. It is our duty to propose the vote of thanks. So, Shri Mahaske ji, President CBIP, Chairperson CEA, and Chief Guest for the valedictory session, Shri D.K. Sharma ji, Vice President Icold and President Icold, Shri A.B. Pandey ji, Chairman of the Technical Committee and Secretary General ICID, distinguished dignitaries, esteemed delegates and guests, it is my proud privilege to propose the vote of thanks. We are highly thankful to the President CBIP for sparing his valuable time for his out of his busy schedule to participate in the valedictory session and address the participants. We are keeping note of your advice, sir. We are grateful to Shri D.K. Sharma ji, Shri A.B. Pandya ji, Shri A.K. Singh ji, Dr. R.K. Gupta ji, and Shri R.K. Bishnoi ji for extending their full support and guidance time to time for successful organization of Icold Symposium. We are also grateful to Icold President Mr. Michael Roser and Secretary General Mr. Michel Dibibo, under whose guidance and their active support to mobilize the Icold family members and extended the patronage of Icold, under whose aegis this symposium is organized. There has been a good response for the paper. The success of any conference is largely dependent on the quality of the papers. The technical committee has selected 150 technical papers for presentation in the symposium. We owe gratitude to the authors of the paper, as the conference would not have fruitful unless good quality of papers are presented. So is the case with delegates, because unless there are listeners, the author's efforts go waste. I thank the delegates for having come and their supporting organization for sponsoring their names. We are thankful. Thanks are also especially due to Mr. A.K. Dinkar and other staff members of Icold and CBIP, especially to my colleague Kalpana Adhikari, who made all the sincere efforts for the success of this event. We are also thankful to our sponsors, Diamond, Gold, Silver, and Bronze category, for their technical and financial contribution. Without them, it would not have been possible to put up such a mega show. So with these words, thank you all. We can close the valedictory session now. Thank you all.